Okay, great. Thank you, everyone. Good day, as they say. And I should have probably add the question of like, from where are you're logging in, so have an idea. I know we have people from New Zealand all the way to California, so we're just covering pretty much the whole world. Today, we'll do a full workshop for you using Pollination and Ladybug tools, trying to put a real-life workflow into 6 hours. So there will be 3 hours in the morning, 3 hours in the afternoon. There is 1 hour break. I mean, Eastern time, there is 3 hours in the morning, 3 hours in the afternoon, sorry. It's 3 hours from now, 1 hour break, 3 hours after that. And this is our team who built Pollination, and you will see some familiar faces here. So if you have any questions or you want to know anything, you can use the Slack, you can just chat here. You can turn on your mic and ask questions also. If you have been in our workshops, is pretty interactive. We have a direction of what we want to show you. There is no like end goal of like hitting 30%, energy efficiency. So don't worry about that. Just the goal of the workshop is for you guys to learn. So whatever maximizes that, we're happy to do. Just quickly, if you're new to Ladybug Tools and Pollination, Ladybug Tools has been around from 2013 as a plugin, and we started in Office 2018. So it has been 5 years. After 5 years of development and like community, it became to a point that we could start an office, which started with Chris and I, and then now we are about 10 people, and we have a platform product which is called Pollination, which will be most of the workshop today. And as you can see, like we took from 2018, August 2018 to around 2020, just developing heads down. And now we're releasing all the stuff that we have been doing, and we're doing more workshop. And we started alpha release, then we are now in beta, and we will go paid soon, closer to the end of the year. So the material that we have here are supported by the US Department of Energy Office of Science under SBIR award. And I did not put this here because we have to. I did put this here because if it wasn't for the SBIR award, this would have taken us much longer because we couldn't bring all these people to work on this project full time. So thank you. So what we're going to do, I'll do a presentation. I'll talk about what's pollination, how does it work, what makes pollination, and then what do we cover during this workshop in more details. And we do hands-on tutorials, and there will be a closing presentation. Anyone has any questions so far? Any issues? Everything good? Okay, I'll continue. So what's pollination? Pollination is an ecosystem of tools that we built for environmental building design and simulation. So it started as a cloud computing, then it changed to a platform, and now it's an ecosystem. That's how it evolved. So our overall goal is to get you from question to actionable data quickly. And the key here is actionable and data. It's not just from question to some data. And how you really want this to happen, people, is like this, right? I have a question, give me the app, I click here, data done, right? But in real world, the way it goes is you have an initial question, then you get some initial data, which helps you to ask an informed question. And it's usually like several times of doing that to get to an informed question. And then that's where we can give you actionable data. So if you don't ask the right question, the answer that you get is not the right answer for your project. And this is, as I said, is more than just once doing that. During this workshop, we keep it simple. And we're not going to challenge you a lot about like the problem and what we are trying to solve. It's mostly to showcase the ability, how the platform works, what are the things that you can take and do right after this workshop in your day-to-day practice. Okay, so how does pollination overall helps with to make this faster from a question to actionable data? As I said, when we started, we were thinking a lot of time is about like running things fast. But then we started talking to people and we realized it's about helping people to work with each other more effectively, and running things fast is just a small part of this. So this is a typical workflow, if you say that, how we work together. You have architect on one side, you have engineer, environmental consultant on another side. Sometimes this is in the same office. Sometimes this is like an external consultant, doesn't matter, you have a deadline. And then you say, great, let me do this. So the engineer consulting side says, I'll wait for you to send me the model. Then you just go, like the architect goes, make the model, designer. And then they send the model, and we know how the model goes these days, mostly like what we call BIM, which is equal to a Revit model, an AECtech model, a model with a lot of information. The person might be in, might be out. They answer you that like, oh, okay, we'll work on it. Sorry, I was out at the conference like this, or a workshop, I'll back. And then you take all this time cleaning up the model. Really, like we talk to a lot of people and say, we don't clean up the model, we just redraw everything from scratch. And that's one of the things that we really want to help. And then finally, you run your study and the result goes back. And we have 1 to 2 weeks of gap. And this is the issue, right? Because at this point, the design has changed, the deadline is closed, you don't have the time to rerun everything. So basically, we always get the report for something that we designed before that we are not using anymore. A lot of waste on time, talent, energy, and everything. So, and yes, there will be an updated model that comes in the middle of you doing the study on the engineering side, consultant side, that they ignore because they don't have time for it. So how do we want this to be? We want the same workflow, but with Pollination, when instead of having the conversation of sending me the model, you say, okay, what are you trying to resolve? And for that, you develop a recipe, you develop a solution that you deploy to Pollination. We'll work with some of these recipes today during the workshop. And then the other side, instead of sending you the full model, they just use the recipe from inside their CAD platform or from inside the web interface to set up the study and run it. Then there will be a feedback period, right? Like, oh, can we add this? Can we add that? This thing doesn't exactly look right. And at some point, the recipe is good enough for the user to use it without getting all the way to the developer or consultant. And once it's done, usually there is a long email of like, these are the things that if you can improve, it will be great. And you can improve that and then submit that as a new version of the recipe that can be reused. These are the concepts that we got a lot of this concept from software development. And this is how software is developed quickly, right? And iteratively. And you get different versions of the software. And you don't have to talk to the person to use the software. You just use it on your side. And this gives you all this extra bonus time to, on the architecture side, designer side, to do more studies or to get more projects. And on this side, it basically removes this need for the person to be there for doing everything and providing the services. So to make that happen, we developed 4 different technologies, actually 5. The 5th one we are going to show you today. We haven't showed it before, ever. So that's the exciting part. So this is 4 that you already know about probably, or you have seen it. So the first one is the CAD plugins. So we have 3 plugins for Revit, Rhino, and Grasshopper. The one for Revit is mostly for cleaning up the model, getting a clean analytical model out of Revit quickly. The one for Rhino is for QA, QC, doing all the detailed work and make sure everything is set. And the one for Grasshopper is mostly useful for running parametric studies. All these plugins are capable to help you doing everything from a start to end. As like from Revit, you can actually run the study. But as I will show you, maybe your Revit model is not ready for an energy modeling right away, right? And then Grasshopper can do one single model, but usually people use Grasshopper when you want to run parametric studies. Then we have recipes that we developed and we will talk about. Then we have cloud computing that helps you run things faster. And finally, we have the web interface, which is the place for collaboration. So there is a question here. Do you see Pollination ecosystem replacing all existing LBT Grasshopper plugins? If so, what is the target date? No, we don't. Pollination and Ladybug tools are actually complementary. So the interface that you will be using inside Grasshopper for preparing your model is LBT plugins. And Chris will show a full tutorial on that in the afternoon of how we are using Pollination with Grasshopper. So Pollination and Grasshopper, Pollination and Ladybug tools are fully compatible. Pollination is not replacing Ladybug tools. Ladybug tools will stay open source and will stay free. Very good questions. Are the slides available? I can share them with you. I think someone from Ladybug Tools team can share the link if you want to see the slides. Okay. So how does this distribute all these technologies that I just showed you? This is a hybrid solution. This is not cloud only. So we're not developing solution that you only can run if you have cloud access. You can run it locally, and all the CAD platforms are the ones that helps you on the local side. Then the translation happens, and there is a model called HVJSON that we developed, like it's a file format, it's a JSON file format that helps us for all these translations between different platforms, both between desktop and cloud, and also helps us between Pollination and Ladybug tools. Then this goes down to recipes and input. Because now we have an analytical model, we have one extra step which we think was missing for a very long time from our workflows. So now before running the study, you can QA, QC your model. You can see your analysis model, which is different from your design model, and make sure your analysis model is correct. And because there is a web interface, now someone else can check your model. And we will work through this during the workshop to show you what does that mean. You can run the simulation locally, do the result visualization locally, or you can run the same recipe on cloud in scale and faster for larger models. And you can do result visualization on the cloud. So again, something that we'll see during this workshop. So how does it work? To keep it very simple, this is how it works. You prepare your model or several models. You can use Pollination or just like somewhere else prepare your model. Then you select an existing recipe. So you say, oh, I want to run daylight factor. There's a recipe for daylight factor. Here's my model. So you put it into your recipe, or there is no recipe, you develop a new one, or you modify an existing one if you want, and then you run it. You run the recipe. You can run it on Pollination, or you can run it locally. And then finally, when it's done, you can visualize the result, which again, you can do it on Pollination, or you can do it locally using your CAD plugins. And maybe by the end of today, you can do it some other ways that we will introduce, which is very exciting. So what are the CAD plugins? Quickly, I go through them because during the workshop, I cannot cover everything and anything that we have in the CAD plugins, but this should give you a quick understanding of like, what are you dealing with? Sorry. So starting from Revit plugin, as I said, the main value proposition of Revit plugin is extracts a clean analytical model from the Revit model for you. It works with rooms and spaces. I think this part energy modelers are most interested in. I'll show you that we introduced the concept of validation. So you can talk to your architect, whoever does the design, and make sure when they give you the model, they can validate it. And if it passes the validation, then this is a model that they can hand over to you. Then for the Rhino plugin, we basically brought all the good things about 3D modeling to energy modeling. So for energy modelers here who work with other softwares, you know, like editing things in 3D is kind of like, in most of the software is almost impossible. Some software, they don't have undo, redo. It's hard to see visually. You have to edit rooms one by one. All of that is something that if you talk to people who work in CAD environment, they will laugh at you because that's just very normal. So we are bringing all those into like the ecosystem using our Rhino plugin. You can easily build like very complex, large models. And because it's inside Rhino, it handles geometry pretty well. We have done thousands of zones for rooms without having issues. You can use new functionalities like this one to identify issues pretty fast. So this is the one that helps you figure out the rooms that are very close, but they don't touching exactly. And this can be an issue if you want to run energy model and you want to solve adjacency. We also have workflows for people who are not comfortable to work in 2D, right? In 3D, you're still working in 2D. And I think that's totally fine. I hope Pollination changed that over years, but it's not like we're not building something to say, oh, you have to drop down everything that you were doing. This is an amazing solution that we have developed. You can totally work in 2D, and we have added functionalities like this one. You know, when you get the CAD plans from people, you draw on top of them, and then you just have this energy model with like hundreds of issues. This is a real model, like someone sent us to see, and this is what they ended up with. So, and there were no way to figure out all these small issues. So with these new commands that we have, you can quickly see where are the problems. And we even have commands that basically automate this process. So if you want, you can just fix the whole thing and snap it to grid and then continue working. And also, because Rhino has all the Python scripting and C# scripting and all those abilities, we have an SDK for the Rhino plugin, so you can also automate the stuff. So this is an example of automating window to bar ratio. And you might be asking, why do I need that? Because as I will talk about it later during the workshop too, the speed of change on our side will get slower and slower, right? If you want a feature to come into software, you have to go through this, like how many users are using it? Does it make sense for us to add it? Are we going to maintain it? And that will take a long time. But for you to write several lines of code and just automate something that you want to do on a daily basis doesn't take that long. For us to provide a solution like that to you and say, this will solve your problem without going through all the questions of, should it be part of the core product? That's also not going to be a problem. That's why everything that we do, we think about, can people customize it? Can people build on top of it? And the answer is yes, you can. Finally, the Grasshopper plugin, as I said, is for parametric studies. In the afternoon, we will set up a parametric run and run it on Pollination. We will show off this concept of recipes of like how you can share the same logic and use it from different platforms. Basically, you will hear me saying that build it once, use it everywhere. That's our one of our goals, that you write the logic, the recipe once, then you use it from Grasshopper, Rhino, Revit, everywhere, and the web, of course. And then because you can do that, that means you can access the result from everywhere too, which means if your engineer runs the study for you and you want to test it on your side, you don't have to get the whole model or their Grasshopper script. So if they're concerned about all the IP and everything, that's not a problem. They just need to give you access, read access to the simulation, and then you can recreate the whole thing on the Grasshopper side on the web, like wherever you're more comfortable to do so. Again, something that we will show during the workshop. And then all these things that I say, I know some people get like really kind of, you know, they're afraid of like trying multiple platforms. You don't have to go between multiple platforms. If you want, you can stay in Rhino from start to end, right? You can stay in Grasshopper from start to end, whatever you're comfortable with. Right now, you cannot stay in Revit from start to end because we don't have the full result visualization in Revit. But with Rhino inside Revit, maybe you can do that in the near future and get a good quality model too. So that was the CAD plugins. Can you share the recipe with your organization? Yes, you can, and we will do that today during the workshop. So that's the first step of workshop. You will see that you won't see anything initially, and then I'll add your team to 2-3 different projects, and you see like how it works. You can, I'll show it. Great question. So what's the web-based platform? Is exactly for doing the web-based stuff. 1, you can run stuff faster. 2, you can do real-time collaboration. We'll go through this, but basically we have a mini project management software for building simulation. There are concepts of teams, members, there are projects that can be public, private. Different teams can have access to different projects. You can set up like what's the level of accessibility for each team. Then you can, this is very specific to Pollination. Because we have the web interface, we made it possible for you to see through the whole process. And this is like, if you know about us, we really care deeply about education, and we don't want to have a platform that helps you make garbage in, garbage out faster. Again, you don't have to go through all these details. And when we do this workshop, we're not going to go through these details, but you can if you want. So we make sure like people who want to learn and who want to be an expert over time and learn more, they can do that. And the web interface makes it much easier for us to do that. And finally, because this is a hybrid solution, you can use your cloud computing when you need them. Unlike some of the other solutions that you can only run on cloud or you can only run on desktop, you can basically decide and say, oh, this is not something that I want to collaborate with anyone and it runs quickly, so let me run it locally. And then, oh, this is something that I really need more cloud computing power, so I run it on Pollination. And I know these are abstract, but we will see it during the workshop, so you should get a very, very good sense. So what are our guiding principles? And this is, I think, my only slide with no graphics. But I want to go through this quickly to make sure everyone knows like how we made our design decisions for developing the software and how are we going to make our decisions going forward. There is a post that you can read about this, about our guiding principles, but this is my short list that I wanted to talk about. One is we acknowledge the real world problems are inherently complex. And it's not about complex geometry, right? I just showed you. It's collaborative, different people, different stakeholders have different data that you need at the same time to get to the right solution. And that makes things complex. Like you want to set up something and someone else knows the value. And we are kind of right now, we don't have any good way to collaborate on that. hopefully we'll show you today that there are better ways with pollination to do that. The other one is we accept the real world is imperfect. You will get, your BIM models are not going to be perfect for energy modeling. Your simulation model that you get from someone else are going to crash. You know, you solve a JSC and it will crash at some point because it's Rhino crashes. Crash is part of the real world. You know, in people, like when we do shows and like workshops, we try to just make everything safe. You're not going to do that. Things are going to crash, but we design for that. So if we know something has a probability to crash, we save your model beforehand. So you don't lose your data, you can try again. And again, we don't complain as much if we get a model which is not perfect, because we know that's the default. Like we design to help you to resolve those imperfections and get your job done. And then recognize there is no such a thing as one size fits all solution. You will see that we go from really complexity of like you can be a developer and do everything on your own and customize everything to a level of it's really easy for everyone to use. And we think this is the healthy solution of having the one single click solutions for something very specific and having the full flexibility to do something research based. And a healthy ecosystem and should support all of that instead of being one single solution for everything. And this is in line with that is your questions will evolve over time. So your platform should also evolve. It shouldn't be that, oh, you can ask only this question. We only work on the earlier stage of design. I've heard that a lot. And apparently earlier stage of design justifies, you know, I try to find a word which is not rude or something. It justifies any kind of wrongdoing. Earlier stage doesn't justify wrongdoing. Earlier stage is just so you don't have all the information that you need. And there shouldn't be a break between earlier stage to advanced stage. There should be an evolution. You have to evolve during the time and do that better. And finally, customization and education comes before automation. I talked about that and why it's important. Because if you cannot customize your solution, you're probably running the study for something else. You know, like we have different projects that I have to tell people that this is great that you get that result, but this is not for your project. You basically run it for another project. You think you run it for your project, but you didn't set it for your project. You couldn't customize it. This is a result for another project that looks good or looks bad. The other thing is if you don't know what are you doing, there's a good chance with all this automated stuff that you just do garbage in, garbage out faster. And yeah, that's something that we are very careful not to happen. Okay, what is the workshop agenda today? We're going to start from Revit. We export a HPJSON model from Revit and show you like what's the process, what are the things that you can check inside Revit. Then we go inside Rhino. I start cleaning up the model, like QA, QC the model. And then after that, we'll go all the way to Pollination and run a simulation. During this process, I'll show you how I will share the model with Mingbo, who will be the energy simulation expert here, to set up the programs and everything for me. And then that will be the end of the day for the first 3 hours. Then in the afternoon, we try to solve the problem that we find in the morning with the model using Grasshopper and doing some parametric studies. And we go from Grasshopper to Pollination too and work with like how Grasshopper works with Pollination. And after that, we go to the new product that I just said, like we'll show off closer to the end of the workshop, which is something that we have been developing for some time now. But it's very early, so this is like alpha and like it's a proof of concept. So we want to see what you think, and we also want to get some feedback. Before I start, any questions? Yes, no, maybe. I think I already answered all the questions in that we had there. So if there is no question, let me check this again and see where do we stand. So 18 of you responded. Thank you. Let's see. Oops, sorry, those are the offices. So what's your position? Oh, we have more of environmental consultant, building performance specialist in the workshop, then followed by architects and computational designers. And 2 engineers, mechanical engineer and engineer. Welcome, everyone. Okay, this gives me a very good direction of like how to run the workshop. Experience with Ladybug tools. We have very advanced 2 that just getting started, it might be a little bit hard for you to follow along when we do it in the afternoon, but if you have any questions, we can use the break room to solve it for you overall. And like everyone is in the middle. I mean, like I consider this Chris Mackey. I wouldn't even click here as like next level Ladybug. But if it's not Chris, if someone else, well done, good for you. What is the level of expertise in pollination? As you can see, like most of you haven't tried pollination. That's what we expect. Are you going to follow? So most of you are trying to follow. Okay, I will set the speed, like make sure everyone can follow, or most of you can follow. And if you have been to workshops, it's usually at the start we have like 90% of you, and then the thing comes down, you know, you get tired and everything. But we share all the files, and the recording will be available, so that should be fine. And do you know Python? Okay, that's a good amount of people who kind of like know some Python at least. That's great. I mean, you don't need Python for this workshop. Yes, you will know after this class how to get, and like people are just adding in, you will know after this class where to start with pollination. That's the goal of this workshop. Any other questions before I get started? Anything that I forgot, Ladybug Tools team, that you need to remind me?
Maybe we'll just say that we, at the end, I think we can share the slides. I know that was a question.
Sure.
Yeah.
Sounds good. So all of you received the email, so you should have the access to this Ladybug Tools Google Drive folder. If you don't, again, like Elchin or someone can add you. Like I already sent an email. Check your spam. You should have it there. There are 3 files here. One is the 2020 basic sample from Revit. This will be the file that I will be using to open the workshop, starting from Revit. So the first thing is I'm going to start with Revit, open the model, and try to clean up that model. Basically check the model. The model is mostly cleaned up. Is that okay? Everyone is good to go? Okay, can we open? Yes, you can open. So the model is in Revit 2020, but you can Revit in 2020, 2021, or 2022. Yes, you can use 3 versions of Revit. And if your installation is successful, you should see the pollination here. So I'll give you a couple of minutes for everyone to open the model. Then you'll see the pollination here. And this is like the very boring, everyone knows model, Revit model. We tried to find a real world model for the workshop, but it seems it's very, like sharing Revit models is legally really hard to make it happen for real projects, unfortunately. But yeah, this is a model that everyone knows. Maybe from that point of view, it's a good model. Okay, so if you have that, Pollination in Revit plugin has 4 tabs here so far. So there is one for enabling and disabling the plugin. Why does it matter? Because after you install Pollination plugin, you'll see like there are some datas that are, there's some data that is added to your room. So every room now has some pollination tags to it, right? If I click here, and this is something that's happening because pollination is enabled. So if you don't want this inside your model, and if you want to keep your model clean, then you can just click on this, and this will disable the whole pollination. The only thing to keep in mind is if you add information and you disable, you're going to lose everything. So there is no way right now to disable and keep the data and bring it back. Disable means like erasing everything from your model, all the data that you put in. Then you have settings here. If you worked with our Rhino plugin, you already know about this. So these are the places that you can create material, create construction set, work with your schedule and program type manager. For this workshop, I'll be the one who doesn't know anything about this, right? My consultant is Mingbo from China. And actually today, like we're going to change a lot of time. So we're going to go to China, to Italy, and US Eastern, and no, we're not going to West side. So this is part of the real world too, but these are the places that I can go and edit my program types if I want and all those stuff. So that's the place that I have access to. Again, Mingbo will show more about this. This is the place that I can edit the stuff about my model. So if I select one of these rooms here, right, and then edit room properties, you can see this is the name, this is the story information, multiplier. I can set loads here, controls here, and then I can set modifier set, construction set, program type, and HVAC here if I want. Again, I'm not going to do that in Revit, but I just wanted you to know that you have access to all that. You can set the sensor grid, and you can export model, which is really what we are going to do. Most of the projects that we have seen so far, the process has been start from Revit, try to get a clean model out of it, and then after that, continue working either inside your energy modeling software, let it be IES, Design Builder, I don't know, TAS, whatever, because we export at GBXML too. Or you get an HPJSON, you go inside Rhino plugin, clean everything inside Rhino plugin, and then you continue doing the stuff from there. As I said, we have a full functionality here to get the recipe, run stuff, and see even the results inside Revit. But this is something very work in progress on the simulation side. So we are not going to use it for now. So okay, with that, I'm going to just click on export model. And when you click on export model, this menu shows up. There are two steps here. The step one is to say what's the file type that you want to export. Again, as I said, HPJSON is the format that we will use today to go to Rhino plugin, but you can use Dragonfly JSON. So the Dragonfly JSON is a format that keeps things extruded. Dragonfly JSON is developed, initially we developed it for urban studies. So it takes a polyline and then an extrusion. And yes, that's where most of the energy models happens too, like it's a polyline and extrusion. So if you have a model which is not necessarily very clean, and if you don't want to fix the rooms inside Revit, then Dragonfly JSON is usually your friend. So you get all the extruded geometry with Windows, and then you can quickly clean them inside Rhino. And we developed this workflow because people ask for it. And like we see like a lot of real world problems that people don't get a clean model. They don't know how to clean the stuff in Revit. They prefer to get out of Revit with most of the information that they have. And this will give you the Dragonfly with the detail option gives you all the aperture, which is usually the hardest one to redraw in your model. If I select the Honeybee JSON, I can check the phase. Make sure you set the tolerance to 0001. This is just to make sure like it's a smaller tolerance. So on Rhino side, you don't get a warning. 001 should also work, but like this is the one that I set, so we don't talk about warnings today. And one of the other things that you can do, you can pick from which level you want to export. So unlike the other exporters for Revit, which is like, oh, this is your model, you can say, I want to study a single model, or you will see a single room. You can just export what you need. It's not like export everything. So it helps you to just pick part of the model, do your studies, bring it back as needed. And here you have to select what are the objects that should be considered as aperture. I have already selected the entrance door, curtain wall, and system panel glazed. So if you have your Revit model, you should know which ones are the ones that are considered aperture. These are the ones that the plugin tries to, basically project on the walls and takes them as aperture. So you're helping the plugin to not to test everything in your model. Then I go next here. And when you go next, because I selected all the floors, it just gives me all the rooms from all the floors. Some of you might see an error here, like for I think I fixed that. So let me do this. Sorry, give me 1 second. I'll get back here. So I'll show you how to fix something. I just showed you the fixed version. Meanwhile, I answer questions. I'm still working on download. I need to IT to install. Okay, you can do that. Like, let us know if you need help. Can you explain the importance of assigning apertures? Sure. So let me open here. Can you talk about spaces in Revit? What do you want me to talk about? Like, is it like a question of like, can we handle spaces? Yes, you can do rooms or spaces if you want. Next, so you can do room and spaces if you want to export spaces instead of exporting room. For the importance of what level is needed for export. So right now, what we do from spaces and room is geometry. Unless, and all the metadata that you attach to it that I just showed. If you attach any of the metadata here, we will export it for you. We don't export any of the data inside from the space itself, but you can export it as user data. I'll show that in a minute. So let's talk about this aperture thing for a second. So what we have seen people trying to do is when you export this model, right? The thing that is hardest to simplify and export is all this windows, curtain wall, all the things that Revit just defines in several ways. We figured exporting the polyline itself is not the hardest thing for people, so people can do it easily. So what we do, we basically export the full geometry and we give you all this aperture. So if you want to edit the lines in Rhino and extrude it and then put the aperture back, you don't have to draw every single aperture inside Rhino. You get all of those exported. The question about how do you do extra information. So you can see here there is user data option. So one of the things is because we don't export all the fields, you can actually use this and say from rooms also export I don't know, all the comments that I added. Or you can create a new tag using Revit, a standard one, and you can access it here and export it as a user data, and you can just take that user data out in the future if you want. Okay, so let me go here. Let me go to geometry. This time now I have a bunch of like messages here for warning. So if I click here, you will see that this room has area of 0, it's not placed. And all the ones that I left in this one, like are the ones that are not placed. You can get other errors. For example, if the height of your room is not touching the ceiling or another level, you will get an error that you need to fix that and all those. We have documentation on Pollination user manual. Someone can copy the link here so you can see for best practices for modeling in Revit. So for this one, to fix them, I just select all of them, right click and delete, because there are rooms that are not placed. And now I have the rest of the model to export. As I said, you can select just a few of rooms and then export them, or you can select everything and export it. There are two things that you can do here that are very important. One, before exporting, you can select the whole model and run this validate command. This validate command is the way to tell you there is no major issues in your model. Your model is simulatable. It doesn't tell you all the inputs are correct because this model, there had some rooms, I didn't put any program type in. That's not an error, that's not a validation error, but it tells you all the geometry is exported in a way that's simulatable. You can export it to Energy Plus, you can export it to Open Studio, you can export it to Radiance, and it will be fine. Then the other thing that you can do before exporting the model, wouldn't be good if you can see the whole analytical model. So you can right click here, click on preview. And it should generate the whole analytical model for you. And you'll be able to check your model before exporting it. So now I can see some of the things that's going on here that I couldn't see necessarily in the menu. One is there is this gap here, which is usually the plenum space. So I either can go and try to build plenum in Revit, which you can, but it's really hard. Or I can say, I'll just do this in Rhino. It's much easier. And that's what I'm going to do. The other thing is I can go and edit my rooms and bring them all the way up if I consider those to be an area that I want to condition. But again, like that's not a good practice. So we will just add plenums there. The other thing I can see here is all the shadings here are missing, right? I didn't select the shading. So the 3D model has shadings. Oops, I can't go. But here I don't have it. And there are shadings here too that I'm missing. from my model here. So I can go, I'm not going to select these ones, but I'm going to select these two just to show as a sample. The other thing that you can do here, you can quickly go back here and check by type. So one of the things I do is I select everything and turn off and make sure all the aperture I exported correctly and look fine. You know, again, I think I have an obsession with apertures to be exported correctly because it's really hard to do if you don't have the plugin. And then check the doors. You know, you can quickly go through the layers and make sure everything is as expected. And if it's not, you can go back to Revit and fix it, or you can fix it later in any program that you want. So I said, like, I'm going to add the extra shades. The place that I can do it, there is here context shade on top. I can go here. Planting is already selected. I can select faces, and then I can go and select this guy and this one here. And that should do it for this workshop. So I just say finish. And now if I go here and I preview again, those two should be part of the preview. Let's see if it is. Yes. So I selected these two, and they're now coming in as part of my HBJSON model, which I can go and add everything else, but I'm just trying to keep the model cleaner and easier for people who don't know Revit, don't know Rhino that well, so you don't have issues selecting stuff. So I see like an error here for preview doesn't start on my laptop. That's because it's not crucial to the process. Let's just debug that later. Let's see if you can export. So now you did everything. Make sure you select, oh, one thing. If you don't select rooms and say preview, it may not work. Make sure you select rooms before doing preview. If you have done that, then there's something that we have to check. But now select everything by pressing Control-A and export. And then I save it here, model from Revit. And I call model from Revit 1 because this one has these two extra shades. Are we good so far? For people who are following, except for the preview. Okay, yeah, then that's an issue with, we can check for you. That's good. No, none of the room has sensor grids. I didn't assign sensor grids. That's intentional. I'll add in sensor grids inside Rhino. So the question was like, none of them has sensor grid. How did I add shade? I clicked here on context shade, up here, add context. Then I said select faces. And I selected the faces inside Revit, and I said, okay. And then it used to be 30, and it's now 32. If you couldn't export the model, or if you didn't have Revit, I already uploaded it to Google Drive. So you should get this model from Revit HBJSON. If you download this, you can follow along when we go to Rhino. For sensor grid stuff, here was sensor grid. You can click and you can see there is no sensor grid for any of the rooms. If you want, you can add sensor grids and you can grid size and distance from floor, and then sensor grids will be added automatically to your model. Again, it was here, sensor grids. So the rooms with errors, if you have rooms with errors, it will be just ignored during the export. Don't worry about it. And you can also, again, right-click on the rooms with errors and delete, if that was the case. Is there a way to individually remove shading instead of removing all? Good question. I don't know. I have never done it. I can check that after the workshop or during the break and let you know. I think you should be able to go back and do minus, but yeah, I'm not sure about that. Okay, with that, if there is no other question about Revit side, let's go and open Rhino. Oh, I actually have it open already. No. Open, and then we'll continue the rest of the work inside Rhino. Any questions? Any other questions?
I just
Okay.
noticed there was one in the chat that yes, the Revit plugin automatically simplifies the tree shade geometries.
Oh, yes. Oh, I didn't see that. Good
Yeah,
question.
yeah. So that it's formatted in a better format that you can use in an energy model.
Yeah, Keith, that's a great question about NSK. I don't know. These are all great questions. Thank you. Yeah, I mean, Elchin, can we get this as a text file after the workshop?
Can you repeat?
The comments that we get, the group chat, can be downloaded? Is there a place that I can access them so we don't forget about them?
Okay, I believe I can save it, but let me find out for you. But
Okay.
that's why I want to move the Slack channel for some kind of important conversations, so we can have the track. I just posted how you get this Slack workspace, and I can also add you this dedicated channel. If you guys need a help, just give me a private message.
Right.
You can definitely save the chat to a text file though too.
Okay, yeah, like I think, and I can't follow Slack. It gives me a headache. So that's a personal limitation that I have with the Slack. So yeah, like we can check the Slack questions at some point.
Okay.
Okay, with that, I assume you either successfully exported the model from Revit, or you already downloaded the model from Google Drive. If you download the model from Google Drive, there is another file there, which is a Python script called Pollination Cred Plenum. You might want to download that too. We will use that to create the plenum. During the workshop. Okay, so let me bring this thing here. The way to do it is after you install our plugin, you should see a series of commands. So first thing, if you type pollination here, this window should pop up. So if I didn't have it, and if I type pollination, you should see this. If you are on Rhino 6 and you just installed it, Rhino 6 has a limitation of just it loads one DLL at a time. So you either have to bring them in manual or you have to close Rhino and open it 3 times so you get all the 3 DLLs loaded for pollination. If you're using Rhino 7, it's already loaded. You don't have to do anything. So when you type pollination, you see this. I'll just add it here to my menu so I can keep using it. If you have issues with the Rhino plugin, I think Mingbo and Antonello can help you in a break room with any specific questions. So the first thing I do, I press Control O for opening. I go to the folder wherever you saved your file. I'm going to use the one without shading. I showed you how to export shading, but I'm going to use the one without shading, which is the one that I uploaded to Google Drive. You can easily also just like delete them in Rhino. You'll see in a second. But I'm doing this just to make sure like the people who download from Google Drive, we use the same model. There are options here just to make sure you know. Oh, we remove that thing. So we always do validation now. So I wanted to show you can set a validation. So if you open this, what you will see, there will be a validation menu that shows up. So we validate your model on import to make sure everything is fine. Then you go inside. You should see your normal Rhino. You should see your model here, right? Under layers, you can see there are organizing layers. So apertures, doors, shades, and then external shades, if any. So you have rooms here. You can't turn off active layer, of course. And you have shades. So it is already organized for you inside Rhino. Units, very good question. So the units, if you import a model from Revit, it will be set to feet. This is something that we can change, but because the units for Revit is under the hood is feet, for now we're just using that. If you're creating the model in Rhino, you can use any Rhino unit model. HPJSON has a unit. So based on the unit that you export, our importer basically sense that and export the model for you, export or import the model correctly. Any questions? No, not so far. So here is where the magic starts, right? So now you can see all these things that I have here. Actually, all the rooms showed up here in this room manager with Pollination. If I click on them here, I can see them inside the Rhino menu. If I select them inside the Rhino menu, they get selected here, right? Then every one that I have in this naming, hopefully it doesn't confuse you. These are the faces for that room. So this starts with the name of the room, and these are the faces. So you get all the faces. If face has any parent object, like a window or something, you can see that. To make sure like it's easier for you to work, one of the options is to click on this color by face type up here in the menu. So as soon as I click that, now everything is colored based on the object type. And now you can see there's a door here quickly that comes to this area on top of the roof. Everyone is following here so far? Does it make sense what I did? Okay, I assume the answer is yes. Then you can go here and do some fancy stuff. So if you click on render settings here, you can start like turning on and off the layers based on type. So I can say remove all the roof ceiling, and I can see inside, right? I can do this, add some transparency. Make sure like when you use transparency, if you have a large model, this can slow down the whole thing. For this model, they'll be fine. And by large model, I'm talking about like thousands of zones. When you have that, then orbiting might not be as fast. Is it possible to get the unique name for each face? Yes, it is. So to do that, if I press Control Shift and click here, and then it selects the, so by default, if you select, it will select the whole room, right? Then if you do Control Shift, it will select only the face. Then you can run a command called PO edit, or actually PO set face properties. And here you can see the face type, and I can name this as east facing wall. And I can press OK. And now if I go to living room, there is a face that calls east facing wall. You can also do it from here. So I can select a face, I don't know, this face, and then I double click on it, and then I can call it east facing wall. Oh, west, sorry. What do I do? So this is east facing wall. That one was west facing wall. So this is real east facing wall. This one is west facing wall. Good that I'm not setting the energy modeling properties for this model. I can't say my east from west. So far, things are just, we check the model. We know the plenum is an issue here, but let me check something else. Especially for energy modelers in the room, like you want to know about solve adjacency. Are the boundary condition for faces set correctly? So an option that you have here next to color by face type, you have another one, color by boundary condition. I click on that, and you see the blue one is for outdoor, and green one is for the ones that are face. So to make it easier for me to see it clearly, I'm going to go back to renderer settings, click on renderer settings, and remove outdoors and refresh. So what I did, I went to render setting and clicked on outdoors and refreshed it. So basically unchecked outdoors. So it doesn't show any faces that has boundary condition outdoors. So can you see the errors here? Where is the problem? This room and this room are next to each other. But because how in Revit we export the model, it doesn't really do solve adjacency between these two, right? So this is now considered outdoor, the whole face. And for this one also considered outdoor, the whole face. The other thing is this area is now also outdoors, right? Which is not correct because either we want to set them to adiabatic or we want to add plenum here and then solve adjacency with that. And that's why I said Revit models are not necessarily ready to run energy modeling. This model is totally fine to run daylight as is after we add sensor grades, right? But it's not ready for energy modeling. One, it doesn't have the, it doesn't have program types, loads, it doesn't have the metadata for energy modeling. That's one thing. The other thing, the salvage SSC is not cracked. Third, it's missing plenum and all those. So what I'm going to do is I'm going to add the plenums to this model, salvage SSC, and then I'm going to share the model with Mingbo so he can work on the model and add all the metadata to model. And the way to do that, actually, I showed it quickly, but the same menu that I showed you inside Revit is also here too. So I can go here and select one by one and set the construction, set program types, HVAC, and all those stuff that I want to set. So that's something that I don't have the knowledge to do, so I need some help from Mingbo. That's the way I will be doing it. So I see a chat is going there for some people who have some issues with importing, but I'll keep going forward for now, and then like we will have a break to talk about that. Any other questions that I need to answer? Okay, I don't see any questions there. So let's do this. Go ahead.
Mostapha, there is one more. Besat.
Will you please mention the main factors in making a clean model in Revit for energy analysis? Yes, you should. So if you're here, you see this question mark here. If you click, it will take you to our user manual. And under Revit plugin, this will take you to Rhino because we're inside Rhino. There is a place for modeling best practices. So you can see what are the best practices for getting a model out. It's mostly just makes things that make sense. It's not, we don't want you to remodel things for energy modeling mostly, I should say that. Like we're very close to using the design model for energy modeling, understanding that they can, at some point they can be different. And that's why I think having the option to come outside the Revit model and edit it somewhere else is very important. The other thing that we have seen with Revit model is because of the amount of data in Revit models and the number of people who are working on the same model, people are really scared to edit anything. We used to call this like model inertia, you know, like model data inertia. Like if you move one like part of the room, you have to talk with like 10 people. So you just don't move it. And that's why you can come in Rhino and quickly do those fixes. With that, I'm going to go to I want to add the plenums here. And then I want to run salvage SSC and share the model with Mingbo. To do that, I can go and select the face here, right? And extrude the face and build a room. So the way you do it in Rhino plugin, you don't have to do this, but if I want to create a room or if I have a BRAB, it's as simple as I select this and then I say add room. It tells me what's the property, do I want to, if there's a room, do I want to change it, and what's the maximum roof angle. So I can click on property and make it custom if I want, right? But I'm just going to use default for now. I press enter, and as quick as that, you see like this room is added here, as quickly as that. So this is as easy as this to add a room. This time we are working with a model that comes from Revit, which means I can go and draw a line here and extrude it, right? But I'm not going to do that because adding plenum for the models that comes from Revit is very common. And because of that, we basically wrote a script that automates that process. And I'm going to show you how to use that script to solve this issue. Before doing that, I think one thing I'm going to do is I'm going to get out of this. I'm going to get in this mode, going back to render and make it outdoors. So, and sorry, I usually put this on 0, so I don't need to see through the whole model. Okay. So with that, I already told you to download the Python script. Anyone needs help for downloading the Python script? You can just download it from the Google Drive and bring it down. And then from there, what you need to do is type edit Python script or run Python script. Both works. So to keep it simple, I use run Python script. This tells you to go and select the script. When you select the script, if this is the first time in your model, it will take a little bit of time for this to load. But then you should see this, something like this shows up. Then this will allow you to select each level, the level that you want to add the plenum. So in my case, it's level 1, and then I can extrude it. So one thing that just happened, you see that I'm also extruding the level for this guy here. So it's okay, I can just go all the way up. This will create all the rooms. It tells me if I want to edit anything. I don't want to edit anything because it's a plenum. The only thing is I'm going to name this plenum, and I'm going to set the story to P1. And then I say, okay. And by that, I should have all my plenums. I go back and delete this one because that one I didn't want. A cleaner way would have been for me to do this, to sort everything by story here, right? And then select this one, and instead of level 1, give this thing its own level, so level 0. So I could have separated them by level. So I will have level 0, which is this one. Then I have the plenum levels. I have level 1 for this one, and I have level 2 for the rooms on the top. Any questions so far? No, can you follow along? This is really hard to do like this because I can't see your screen, so I have no idea. Hopefully you're good. Can you show again where to add plenum? Sure. So I'm going to do this, and this is good to show you like how Rhino plugin works. So I can select all this here, right? I can right click and isolate actually. So to show you like what are some of the use cases of this. And then now I can select them and delete them. Now I press show and everything is back. So what I want to do, how did I add the plenum? I used the Python script that I shared with you. So the way to do that, I'm going to do run Python script. I selected this one that you can download too. And when it loads, it basically, this thing shows up and gives me the list of levels, right? You see now we have level 0, level 1, level 2. I selected level 1, and then I selected extrude, and I did this. And then for story, I set it to plenum, PL1, and for name, I called everything plenum. And there's a good chance I'm misspelling this, so I'm aware of that. Hopefully I'm doing it right. But you get the concept. Did I answer your question? How to do plenum? So while you're doing that, I can, for the people who know Python, I can use edit Python script command to show you the code here, because I saw like most of you, or like a good portion of you, know how to code in Python. So the thing that is really happening here, if I can zoom in, we give you access to Pollination DLL and Honeybee Schema DLL, right? And then you can import all these libraries that we have done. And then you also have access to all the Rhino greatness. So it's all the geometry flexibility that comes with Rhino, and it's all the environmental simulation, building performance simulation flexibility that comes from Pollination and Ladybug tools. So you have access to all of them here. As a result, you can quickly, these are all like document settings, right? From here, it's selecting all the rooms. Getting from that, if there is no room, there will be a warning. And then this is the menu that pops up for a story selection. If you want to keep it simple, you can have no UI, so you can put it as a text in if you want. And then from here is all the code that you need. You see like it's like 10, 15 lines of code to do the whole thing that I just showed. So you either develop this code or we develop this code for you, and then done. You have this thing automated. You don't have to wait for us to develop like a plenum builder or something. And you don't have to go through the pain of doing it inside Revit with the way that they have it. It's probably a good time to save your model if you haven't done. And you will see now that when I press Control S, I can actually save the model as a 3DM file. I can save as the model as HVJSON if I want, but one of the things that happens when you install the Rhino plugin, is now your 3DM file basically becomes a building simulation file format. So you can save your files as 3DM, and it will include all the information that is you need for simulation. So you don't have to send a Rhino model and an extra HVJSON model. You don't have to send a Rhino model and a Grasshopper script. You have a Rhino model, and that Rhino model has all the information that you need for that model. Does it make sense for everyone? Questions, concerns here? Do you want me to upload this file to Google Drive? How to show the rooms? Maybe more specific, if you want to turn on your microphone, what do you mean by how to show the rooms?
Yeah, sorry. So in my pollination, tab, none of the rooms populated when I imported the model, or at least it's not showing.
Okay, sometimes if you have this issue, can you click on this refresh manager? So refresh manager should just refresh everything. Sometimes they get out of sync, so this can help. The other thing is like you can also filter stuff with refresh manager. I think this is something that Mingbo can totally help with that. If not, like one other thing I can do, I can just share I will upload the 3DM file and the HVJSON file to Google Drive, so you can open that and you can start there. I can do that.
Thanks. Mm-hmm.
Okay. So I'm going to put this one in a new folder here, right? I call it workshop files. So this is the 3DM, just in case these are the Revit models here. Should be uploaded quickly. Okay, so you should be able to download the files, the 3DM file and the HVJSON file. Both of them should work. So do you have any other questions before I go through the process? What rendering filter do you have right now? Here I'm coloring by face type, this first one here. And on the Rhino side is set to wireframe, but you can set it to shaded. I don't think that makes a huge difference to see this values. So we added plenum, right? Remember, but we didn't fix solve adjacency. So this solve adjacency is the command that I'm very, very afraid of, because there's a good chance of things crashing. And on my computer, it crashes more than anybody else. For some reason, we're still trying to figure out why. But we'll go and do that. And that's one of the cases that say we save the model. So if anything happens, you can restart again. Let me answer this question. After filtering the levels and isolating them, how can we turn on all of the item bag again? You can use show command in Rhino. So if I do this, and then I want to only work on level 1, so I select this and I right click and isolate. I do the stuff that I want to do. For example, I go inside maybe and edit and remove this, column here and come back, whatever you want to do here. You can do all that, and then you type show and everything should come back. The other way to filter, because we know levels are very common, there is a filter by here. So you can click on filter by and then filter by a level, and then click on this isolate filter room, and this does the same thing too. And you can filter with other more advanced things that we are not going to cover during this workshop. but yep, or yep, here's another thing. Any other questions? Can you down save as Rhino 6? Oh, sorry. Yep, of course. Or save as. Oops. Rhino 6. And upload it to Google Drive. Okay, this is Rhino 6 for anyone who is following with Rhino 6. But that's the thing, if you use HVJSON, it doesn't matter if it's exported from Rhino 7 or Rhino 6. HVJSON should work for both versions of Rhino with no problem. Okay, let's go and do solve adjacency. Then after that, we'll talk about Pollination as a collaboration platform, because I'm not going to send the file to Mingbo using the Google Drive that we just used. I'm going to use Pollination to do that. And then we'll see how that goes. Again, as I said, this is the one that scares the most for me, but like hopefully this works fine. So I'm going to just set the filter here. Click on render, outdoors, refresh, close. So now you can see we are missing the surface boundary condition here. We're missing the surface boundary condition here. And you'll see there are issues with this Revit model too. In general, like things are not aligned that if you want to fix, or there is a very small line here exported. So if I wanted to fix that, I could have done, this is another thing that I usually do. I do check geometry adjacency, and then you can select all the rooms. And then I can just change this here, and you can see here, it could have shown me that, oh, there is a very small face here. I'm showing this here because when we solve adjacency, because if, depending on the tolerance of the model, this might give us an error and say like, this is a small h here that you need to fix it. But this is something that when I said like you can quickly QA/QC your model and find this stuff. Again, the command was check geometry adjacency, and all the pollination commands start with PO underline. So if you do PO underline, you should be able to see all the list of commands. And if you want to know more, if you click here and go to our user manual, there is a place for all the commands, pollination commands for Rhino. And some of them has videos, and all of them has documentation about the inputs that you have to put in the command. So that's how you can see it. I'm not going to cover all the commands that we have. I think I'm doing everything not to run the adjacency. So let me run the adjacency, and we'll see how that goes. So PO solve adjacency. So what solve adjacency command does, it basically in one go, it finds all the faces, it does the split, and then it matches all the adjacency for you too. So for larger models is really like powerful command. They just run it once and it does it all. So here we go. And it didn't crash on my computer. I don't know about yours. And one of the other things that I do is like I set the live visualization to be able to see it. That's what the plugin should be. And that's one of the things, our plugins are work in progress, right? These are the things that we know and we will fix. It's not going to stay like this. But now you see like all this are resolved, right? This is resolved between the two. So let's check on the top and see like if there are any issues that you can see with the model. Yeah, overall it looks fine to me. I don't know like if there is anything that you think is missing. But now that it looks fine, this is a good time for me to share the model with our energy consultant, Mingbo, if he's still up. That's 11 p.m. there, and he can work on the energy stuff. So how do I do that? In a normal workflow, you would have downloaded this or save it as HVJSON and email it to that person or use it Google Drive or something. But what if I could just add it, upload my model to Pollination directly? So there is a command called PO upload model, which will allow me to upload the model to a project on Pollination. And there is another command for PO download, so Mingbo can download from his side and start fixing the model. Make sense? So if you do PO upload model and try to sign in, it will give you here, sign in with whatever solution that you use to sign in, if it's your email, if it's GitHub. You just need to sign in, and after you sign in, it tells you go back to here, and you should see your profile name here. Success. I don't see any errors, so I assume everything is good. So it tells me where do I want to upload it, and what's the subfolder that I want to upload it. And now you will see that this is by default is Mostapha demo. If I click here on it, it shows me all the projects that I have access to write to it. And you see, like, I have access to AECtech stuff here that you don't. So I have a pre-workshop project that we use for testing. There is playground one for you guys to test, and there is a workshop one which I want to use with our team. You shouldn't see them, right? You're not, currently you can't see any of these AEC projects, I assume. And this is why. Because when I set the projects, I didn't add your teams. And this is why we wanted to have all your names to add you to the team. So this is how it works. So this is the Pollination web interface, right? And I go there. And here, what I have done, we all added all of you as members to the team, to the project. We created the team here for all of you attendees, and you're all here, right, as a single team. What happens is for every project now, I can go back and say who has what access to what. So we have one workshop project, which is the one that I will be using, Chris will be using. So we keep this one clean to make sure, like, you can always go and find the simulation that we run. So for this one, if I go here and I go to settings, you see on access, you have only read access. Oh, you already have read access, someone adds you, thank you. But if you didn't, you couldn't see this project, any of the things from this project. If you had write access, it would have showed that in your upload model, but it didn't show up because you had read access. But then I made a playground project for you, so you can do whatever you want here. And for that, I'll go here and give you write access, or you already have write access. I think Antoine probably did it on my behalf, thank you. So collaboration on the web, that's how it happens. So now you can see you already have write access. Be careful when you upload your files, because now all of you have write access, all of you can overwrite each other files, if that makes sense. So maybe you want to rename it, or maybe you want to put it in subfolder. So what I'm going to do here is I'm going to upload my project to workshop, upload my file to workshop project, and then let Mingbo know that the file is ready for him to continue working on. So I'm gonna come back here. Ardeshir, I saw your command, but like I'll answer that after we do this. So upload model, I select the workshop project. Then instead of copying it in root, I try to be clean, and I make a new subfolder, call it model without, or maybe geometry only. Okay, and then now if I say upload, it tells me the file has been uploaded to Pollination. I can click see file on Pollination here. And the model is here. We can check this. The plenum is exported correctly. The whole model looks fine. Maybe I should have moved this tree a little bit further, which I can do. But the good thing is you all have read access. So here's, you go. So I just sent you the link in chat. So not only you, but everyone else who has read access to this project, read or write access, should be able to see this file, should be able to just QA, QC, see everything is done correctly. Makes sense so far? So Mingbo, are you good to get started on your side?
Yeah, can you hear me well?
Okay. Well, so while you're working on adding the stuff on your side, I'll be working on setting up for a daylight simulation, and then when your model is ready, I'll do the energy modeling simulation. Any questions so far? No. Okay, for you, if it didn't, so I see the question of plenum check adjacency fixes, plenum is not green. So maybe when you created the plenum, it doesn't necessarily, it doesn't touch, so just check the model and make sure you extruded it correctly. Otherwise, if you upload the model somewhere actually on the playground, someone can help us. So can you repeat the adjacency part again? How do I show only green inside faces? Okay, so it seems like for this adjacency, I went quickly. So this is how I did it. So I'm going to run a command that we have, which is called PO rebuild. PO rebuild rooms. Why do we have PO rebuild rooms? Because you get models like GBXML models, like some energy models from someone else. And this is just, they have solved adjacency, is so broken. You just wish you had a model before, like where all the faces are merged, where all the boundary conditions are removed, and you could just start from scratch. So that's what PO rebuild rooms are. So I do PO rebuild rooms. I select all these rooms, press enter, and now you'll see all the boundary conditions are gone here. So there are only these two that are touching ground are selected as ground boundary condition. So how did I make the preview to not to show the outdoor? This is how I did it. I clicked on this here, the second one, which shows the boundary condition, color by boundary condition. Then I clicked on render settings, and inside render settings, I unchecked outdoors and press refresh. So if you click on it and you have everything, it will show outdoors, and outdoors will block me from seeing what's going inside, right? So what I did, I basically came here and clicked and said refresh. So now it shows the surfaces that has surface boundary condition, ground boundary condition, or audio body. Makes sense so far? But we have one person who is not part of the team, if you can add them. So they can show up. And also like something else, I said like, let me fix this shading which comes into the building. So I can use Rhino commands, and we have support for Rhino commands. So I just moved edge, and this is still a shade and nothing happened. So you can use Rhino commands to edit your geometry. There is a list again on our user manual of like what are the commands that we support. If you're good, I'm going to run solve adjacency again. So now you can see these two are ground, everything else was outdoor. I don't see outdoor because I used this renderer and I turned it off. So now I can do PO solve adjacency. Select all the rooms, press enter, and wait. Yeah, done. So it did everything. It did the solve adjacency. Now you can see these are now green, which means these are now. So if I select these two and isolate them, maybe I can spend a little bit more time to show you how it works. So now you can see if I select this one here, for example, right? It's under hall, so I select it again. So this is this one. If I click on it, you should see that the surface here, the boundary condition is set to surface, right? And this is the adjacent surface that has. So it already sets this for me, for the object. For the developers in the room, if you're really interested, you can see the whole schema too, of like how this object really looks like under the hood in HPJSON, but you don't have to. So, okay, now that I have everything, I do show. Did I answer your questions, like people for solve adjacency? Does it make sense how I did solve adjacency and all that? Yes, okay. So this is a step that I think someone will make a mistake. So listen and hopefully we'll get it right. So the next step is I want to run a daylight simulation, an annual daylight. So we want to evaluate the annual daylight inside this building and see how the annual daylight looks like. To do that, I have to generate sensor grids, right? There's no sensor grids in the model right now. And then I have to load the annual daylight recipe from Pollination and run it. One thing that I want to make sure I don't do is I'm not going to add sensor grids to plenums, right? I know some of you will, but not to do that. So try this. Select all the plenum ones that we just generated, right click on them, or yeah, I mean, like you can just select them and then press Ctrl H or hide. I don't know how good, like I should have asked if you guys know Rhino, like how good you know Rhino, but it's just like I just made them hidden so I don't select them by accident when I'm adding sensor grids. Does it make sense? So that's all I did. So to add sensor grids to your model is as simple as, and I save it here, PO add, and there is a command for adding sensor grids. So when I run the command, it says, please select surface rooms or grid meshes. I just select all the rooms that we have here. Did I select the rooms correctly? Okay. And then I press enter, and it tells me about the grid size and offset. So Chris is going to be our daylighting expert today for running the daylighting and like all the parametric stuff. Is grid size of 1 good, Chris? What's the grid size do you want me to set it to? 1 feet? Okay. He says it's good.
It's all good.
Okay, it's all good. I just press enter, and here you go. So for some reason it didn't add it to this. Sensor grids. Okay, this is the sensor grids here too. This is interesting. I don't know how to select something going on. So I can do, let me see, what did I do wrong? See, select sensor grids, delete everything. So let me start from scratch. Then I select all the rooms here, select objects using Rhino layers. And then I say PO add sensor grids again. The size is okay. This is the first time I see this. It's like, did I find a bug during the workshop? Yes, I don't know what's going on. So some of them, anyone else gets like the same error? So what if I just select this and add? Yeah, it looks like some of them are missing. I have to just select one by one and add them. I have no idea why. So this one doesn't necessarily even add sensor grid. Anyone else has this issue? Oh, maybe I know why. I probably should have added sensor grids before doing the solve adjacency. That might be confusing right now. No error here, got all the sensor grids. Yeah, like Mingbo thinks my computer has a setting to not do it. It looks like he is right. So I don't know, I can't add sensor grids here, which for now I'll just move forward. I don't know, like maybe just I do one more thing because I know like I get the model for energy modeling from Mingbo. So I do sell sensor grids again, delete everything. I do PO rebuild rooms. I select everything here. So this should reset everything. Now I do PO add sensor grid. No, this room decided not to have sensor grids for some reason. So I think just for the flow of the workshop, I see what's going on. This got merged together. These two rooms. There's an issue here. Oh, okay, so for me to be able to do a better job in like editing this model, I do this. I go here. I don't know. Do you have a model? Like, do you want to share with him? Like, everyone is just, this one is just for me right now. I don't know why. So let me do this. I save this model for debugging for ourselves. Save as. Sensor grid issue. And then what I'm going to do, I'm going to open this file here. This is the initial file that I brought from Revit, and then I do PO at sensor grid. Yay, and this one worked. So I did something during the process that basically broke all those, that room. We will debug that. But now I have all the sensor grades. And as I said, like now this model doesn't have the plenum, but remember, like because it's automated, no worries. I just run the script again, I get the plenums that I want. But I'm not going to spend time on that. What I'm going to do, I'm going to go to the next step to run the daylight simulation. Okay, how do we do that? To do that from Rhino plugin, you just click here on Run Simulation. And this will tell me like I'm already logged in. Then you have to name the job. So you can call it, so annual daylight for Revit.
Sorry, where is Run Simulation?
Oh, it's down here.
Oh.
And you can also, there is a command for that too, for the Revit sample model. Then description is, I don't know, the first run for the workshop. And how many of you are just, this is your first time running something on Pollination? I think a lot of you. So this is a good moment of running things on cloud. So one thing, don't run it yet, right? Because everything that runs on Pollination is a scope to a project. When you run locally, there's no such a concept. You can run anywhere and everywhere. But now you're a scope to a project, and by default, it's set to project demo. What I really want to do, I want to run it under the AEC workshop project, right? So when I select the recipe, I want to go here from project, browse, and let's see, AEC. If I type AEC on top here from projects, I can set the workshop project. And here's something interesting happens. There's no recipe inside workshop project. Someone asked about like, can you assign recipe to a project? So that's what I'm going to show you now. So the concept of projects in Pollination is to give the project managers control and the users also keep them safe from doing something very wrong. As a result of that, when you create a project which is part of an organization, like this one that we did, let me see, there's, oh, my file is here. So, and Mingbo already has non-model with programs. Good job. So I can use that. If I go under settings, there is a place for recipes. And this is the place that I can say what recipes do I want people to have access to for this project. So I'm going to add annual daylight here. And I can select from a certain version or any version. So here I'm selecting the version which has visualization, or I can select any, which means you always get the latest. So this is one. Then I'm going to add energy modeling, annual. So annual energy use. And I'm going to add the latest version is 036. I'm going to add that. So now there are two recipes added here. Now if I go back to Rhino and go to the same project here, browse. You see now I have access to the two recipes that I just added to the project. I do annual daylight, and the annual daylight one will show up. You guys don't have access, I'll just give you access. If you run in demo, you will have access to all the public recipes, right? So that's fine. Yes, you don't see workshop folder, that's by design. Remember, you only have read access to workshop. You don't have write access to workshop. You have access to playground, so what I'm going to do, I'm going to give you the same access to give everyone access on the playground project. So I go here, I go inside playground project, settings, recipes, and then I add annual daylight. And here also I add dispersion for all of you. And then I'm going to add energy, annual energy use, and do the latest version. Okay, so now if you guys click and go to Playground project, you should have annual daylight and annual energy use. Is that right? So when you do that, you'll see this. Yes, okay, that's great. Everyone has it. You'll see that this just popped up with some inputs. And these inputs are the inputs for that certain recipe that we're using. So because I loaded annual daylight, the inputs are model, which is linked. Then there is an WEA file, which I just realized I didn't download before the workshop for you. So can someone upload the WEA file, Chris or Mingbo, to the Google Drive so everyone can download that? So we just use the same WEA file. Then there is one for CPU count. CPU count is telling like how many parallel execution do you want to allow to run on the cloud. So why don't I set this to like unlimited, like 2000? Because one, when you have so many CPUs, there is an overhead for this parallelization, right? So be careful about that. It's not like for every simulation, more CPUs means faster run. Because then you break down the model more, it means like you have more machines waiting to be available and all those. So for this model, probably like having 25 is more than enough. And then what I'm going to do, there is another one here, and you can read all the descriptions of everything. It's similar to Ladybug tools components, right? You can just read everything. That it says what is the minimum number of sensors. This is for, it says like if you have, for example, 10 grid, and then you use 10 sensor grid, and you have 25 CPUs, then every grid will get 1, right? When we break down 10 to 25. So this is the place to make sure like your sensor grid doesn't get too small. So I'm going to put a number about like maybe 500 sensors here to make sure it doesn't break down the model too much. Then I have to change the north. North is 0, I don't change it. And here is access to radiance parameters if you want to change it. Here is access for post-processing if you want to change it. Did you upload the WEA file already?
I uploaded the workshop folder.
Yes, thank you. So if you go to workshop folder, which one is WEA? Which one, like, how do I change the, is it this? Okay, here we go. So there is, oh, there is no WEA though. I mean, I can quickly do that, but I think I will get people confused.
One second.
Yeah, right, I think that's something that we want to show on the Grasshopper side, that how the same recipe can look different using the handlers. Any other questions?
Mostapha, there's one question on the Slack channel.
Okay.
Kit is asking, at some point, can you explain why Pollination uses WEA rather than other weather file formats?
So, okay, now you made me to show this. So in reality, it's used for a daylight study. I know I should not play the daylighting guy today, that's Chris, but because the question came up, we really only need the information inside WEA, but we understand a lot of people really have access to EPW and they don't know how to generate WEA. Because of that, there is a concept of handlers. Sorry, we'll show this again in the afternoon, but I'll just show it to you today. That the answer is, it depends on how you load the recipe and where you load the recipe. So it's WEA because that's the most efficient file format to use for the simulation. But it doesn't mean that you always need to have WEA. If I load the same recipe from inside Grasshopper, so I go here, I go to the same project. Now you see if I hover my mouse here, it says a WEA object. This can be also the path to a WEA or an EPW file. So in Grasshopper, we have a handler that takes EPW and converts it to WEA under the hood and sends it there. Inside the recipe, we decided to separate this from the recipe because it was one extra step on the cloud that we didn't really need. From all the EPW information, we really need the information inside the WEA file. Good question. Any other questions? There is a question about schema version, which I can't help. Just if you install Pollination before, make sure to install the latest version because everything comes together.
Don't worry.
Okay.
Yeah, I made sure that they're helped. Yeah. It was
Okay,
just
thank
version
you.
of the plugin.
Yeah, we figure out the breaking rooms, so
Right.
we will
It's
helping
all
them.
like make sure you have the latest version which installs everything. Pollinate yet? Are we still selecting a file? No, we haven't hit Pollinate yet because I'm waiting for a WEA file to make sure everyone has a WEA file
So
and also answering
if
questions.
anyone has installed the plugin successfully, you should be able to find the weather file underneath the Ladybug tools, the folder.
Resources.
The
Do we have
resources
WEA file
weather.
there?
Yeah.
Okay, that's good. That's another thing for people to know. So what I'm going to do, I'm going to learn how to download the stuff from Google Drive. So I'm going to download this file, save it, and then put it in my workshop folder so I can access it. Okay, so now we have WEA file here too, which is the weather file that we need for daylight simulation. And now what I'm going to do, let's go here, run simulation. I mean, you guys feel free, if you're done, you can just start. Probably, I guess some of you have started already running. It's cloud computing, go for it. But make sure like our account resources are shared for the whole AEC. So they'll see if you leave anything for me, but we give a very good amount of resources to everyone. So this should be annual daylight for private sample file. First daylight study, and then I select the recipe. Do workshop and annual daylight. Okay, and then I go select the WEA file that I just downloaded. I'm going to change the number of CPU count to 25, and I'm going to change minimum sensor count to 500. Make sure it doesn't go crazy. And with that, I will be able to pollinate. You can see you can run it locally, but because it's a daylight simulation, it's annual daylight simulation, it takes some time. You can run it. I just select pollinate, and it should start running in a few seconds. So one of the things that happens here, and you'll see this afternoon, the difference between this, what we have here, and what we have in Grasshopper, the Rhino UI for running simulation is pretty work in progress. In Grasshopper, it's much better, so you can keep track of simulation live from Grasshopper. But from Rhino, when you run it, you have to go back and see it on Pollination to see how it's running. And because it's on cloud, really, like you didn't need to run it because you could have reused what I ran. But I know for this workshop, probably you want to run it to have a sense. So you see this is running. Oh, interesting. No one else is running anything? Do you have any issues setting it up?
Mostapha, there is a not authorization error multiple people get.
You don't have not authorization error. Let me check. So this is the one. Let's, maybe I blocked all of you so I can run it. Running on my own Pollination workspace, so that's working. So again, there is something about permission we can check. So if it's running, then you can see all the inputs are here. The model that I just submitted for this specific run is here, and it has all the sensor grids too, right? So I can see that. And if you want, and you're interested, you can see the whole process live here as it's running until I check what's going on with the rest of the stuff. So I can check, you see this is running live, so I can see it generated the sum pass, it split the grid here, and if I click on every step, I can see even the commands of what's doing what. So now it's in the step of like, it's distributed the jobs and it's running it for all the sensor grids, and then once this is done, it will fix it together. Yeah, so if you couldn't run it, you can run it in your demo folder, but let me check and see what's going on with that you don't have access. So in Playground, settings, access, you have write access. You should be able to.
I think if you check the recipe, Mostapha, I think you only gave access to the viz tag, so maybe you'll want to give more tags so people can try out some more recipes.
Okay, let me do annual daylight. Everything. Let's see if this is going to change anything. So is it going to change anything? Because they should have access to these too. One other thing we can do, we can go a little bit crazy here and delete this access and add you as admin. See if this solves the problem. So I just added you as admin. Can you check and see if that one running? I did the one with tag viz. Yes, I ran the one with tag viz. Now it works. Okay, so it seems if you have write access, you can't write recipe for some reason. If you only with admin access, you can do it. But yeah, you get the concept. So if you run it, it should, all the jobs that you guys are running, everyone who is running the job should slowly start to show up in Playground. Now I can see, okay, here, wow, oh, okay. You were waiting for it. So here we go now. So this is running. So a couple of concepts for you guys to know. So in Pollination, the resources are for the account. So the whole account gets access to number of parallel CPUs and everything. So for this workshop, we just kind of like make it close to unlimited for you to be able to run everything. But when you work with project with your team, you want to make sure you are considerate to other people, right? So if you run something, you don't want to hog everything that's available, so stop other people from working. This is again something that we are figuring out what's the best UI for you to know, like how much resources are available. Should we take care of that for people and schedule it? Should we allow the project managers in your offices to set like, this is how I want people to run it? This is something that if you give us feedback, will be really helpful. But overall, hey people, it happened. You can add like cloud computing to your resumes if you haven't done already. But like cloud computing, daylighting, I don't know the things that shows up in people's resume. But the simulation is running. We have to wait for the simulation to be done. And then once the simulation is done, I can load the results back. And it's interesting to see like with everyone using the resources where we end up paying with this. Any questions meanwhile?
You jump back to sensor grids?
I jump back to what sensor grids?
Creating them? What's
oh, in
density?
Rhino? Okay, sure. So to create the sensor grids inside Rhino, so I just select everything, select sensor grids and start from and delete them. So if you want to create sensor grids, there is a command called PO add sensor grids.
Mm-hmm.
And then it allows you to select the room. And then it asks you about grid size and offset, and it creates the sensor grids for you.
What are you using for space?
I was using grid size as 1 feet and then offset 2.5. You can change it if you want to change it. So let me do a different sensor grid here. I don't know how it's going to affect like loading the results back, but oops, sorry, not cell. So if I do add sensor grid, I can, if I want to change the grid size, I click on it and I can say 3, right? This is just like a normal Rhino command. So now you can see this sensor grid is like every 3, whatever number I put there, 3 feet.
Okay. And adjacencies have to be solved?
For daylighting, solve adjacency doesn't matter. It really matters for energy modeling.
I see.
Right? Because for daylighting, I don't need solve adjacency because it's not about heat transfer between the spaces. Can you upload the 3DM model post sensor grid that they've used for daylight? Sure. This is the model. Save as. But as we will show you, you really don't need my model to visualize the result or show the results. You can just pull the model directly from Pollination. So you don't need my model, but for this case, I just uploaded it. Simulation is done. Let me try to find where is Google Drive and AECtech. So for anyone who wants model with sensor grids, here is the model with sensor grid. Any other questions? Until when it will be open? Till the end of the year. Yes, the beta period now, our schedule is until the end of the year.
Sensor grids are assigned per room.
Per room,
is
yes.
in the list.
Yes. How do you get the debug option on the app Pollination Cloud page working in demo and don't see it? So if you go, so there are two concepts here that you should know of. In Pollination, when you run a simulation, we call it a job, right? This is a job that you have here. When you go inside a job, there can be one or several runs. So in this case, we just ran one single simulation, so that's a run. So to see the debug, you can see it for a run. So I go to this job, I go to the run here, I click on run ID, I click on debug, and this will show me the debug for this run. Does it make sense? And here is the cool thing. If you ran it on, you know, like I can see it. So if you run it on here, I can see it. If it's a public project, you can see it too. So for everyone, oh, it's done. Look at cloud computing here, getting the stuff done on time. And everyone is around 5 minutes, right? Because again, we were careful about the resources. And if you had even like way too many simulations, right, running in parallel, that's the beauty of cloud. When you run parametric studies, it should take about the same amount of time. Any, I'm reading the questions doing, what's the model doing that takes time? What's the model doing that takes time? Can you just tell me a little bit more what the model is doing? You know, what's happening behind the scene, why we have to wait for daylight simulation? So when I click run, it basically submits the model, generates a radiance model, runs the simulation on that. And yes, so there is no simple model behind the scenes. So what really happens is, and let me use someone else's model so we can debug it. So when you submit the model, this is the HPJSON model that comes in. Let's see if Michael has done right. Oh, everything looks good. So you see, like, so when this model comes, this is an HPJSON model. An HPJSON file, we have code that takes this HPJSON. So if I go back to this, oops, sorry, I should have gone back to the run. So if I go back to run here, the first step of the process, what we do, or the recipe does, in this case, it creates a RAD folder. So there is a command that takes this model, the HPJSON model that you have in, and it creates a folder out of it. So this is the input model. This is how the grids are created. And you can actually go, if you're really interested, you can go and see the model that is generated on Pollination, right? So that was the first step of the process. Then there are other steps, right? It creates an octree. Then it splits the grids for you. You don't necessarily need to know about all this unless you're really interested to learn about all this. Does it make sense? So that's what was happening behind the hood. And that's the beauty of recipes. It basically packages this whole logic and give it to you so you can use it. And whoever writes the recipe takes care of all the QA, QC for you. how can you visualize building orientation in Rhino scene to ensure orientation matches intention per site? So in Rhino scene, in all the Ladybug tools work, and also in Pollination, Y+ is north, unless you change it. The way you want to change it, either you rotate your model, or when you run simulation, and this time I'll just do the default one so I can quickly show you this. Or if the recipe allows you, you can change the north here. You can change the north value to set the north value for your simulation. But from geometry-wise, Y+ is always north. I can no longer see playground in select recipe folders on my demo. Oh, that shouldn't happen. Like, just probably you just need to refresh and just check. You most likely that should show up. I can also check here. So if I want to select a recipe, you browse here first, right? You go to AEC and playground is here. Okay, so now the simulation is done. There are two places that I can, there are so many places, but like there are two places that I can show you now to visualize the result. And we're getting to the last hour of the morning session. We're good on time, I guess. One thing is, if you use the one with tag viz, after the simulation is done, you should see the output called visualization. If you click on it, now you see the same model that you had previously, with the difference that now you actually see results here, right? If you can't find it, you can just, and you see I'm not using the one that I submitted, I'm using the other one because everyone can access everything. Here we go. So you can click on this link if you can't find it. I can do it again. Maybe I should be more structured, so not to get people confused. So here I go to workshop projects. This is the one that I ran, and like you don't have access to this, so there's only one job here. I can click on it. I go here. Either I can go inside the run, or here when I see the summary of all the runs, there is one output here called visualization. I click on it, it takes me here. And now I can see this. I click here and I turn off the roof, turn off roof ceiling to be able to see the results. There are different metrics that comes with annual daylight study. So if I click on grid, I can see all of them here. So I'm interested in useful daylight illuminance mainly, and I can set the legend to be 0 to 100. And I can change the color set. So let's use the AECtech one for people like this color set, but it doesn't really tell the story well. So I just use the nuanced one for this one. So, but you can now see you have a full-fledged viewer just in the web to see the result of your simulation. Everyone is following? Any questions? So the way I edited the model, I can go here. I went to that link that I shared, or I can share this link with you too. Then you can see the model. Then you can click on this hamburger, I think they call it, menu on the left. And you have access to the settings. You can toggle if you want the orientation. If some people work in parallel instead of perspective. I think I said it in a very loaded way. I don't know why. But then you have different access to everything. You can change the visualization. So if I want to prepare this for visualization to send it to someone, I don't want things to be colored based on type because the client doesn't care. So I'm going to just select everything and make them white-ish, right? Like this. And then I'm going also to turn on the edge. Give it a little bit of, or maybe I don't turn on the edge for everything. I'm going to only go to aperture and turn on the edge for aperture. So it gives me a little bit better view here. And what I can communicate now to my client is this large windows were good, but you can see here when we check useful daylight illuminance, we get a lot of daylight. So it's like potential glare here on this side. And you can see the same issue here in this room is just like all 0. Wow. So it's just like all blue-ish. And maybe I can just even turn off the aperture for you so you can see the results better like this. Make sense so far? So if we want to send it to the client, depending on how you want to work with the project, you can either share the link to the VTK.js. You can also take a screenshot, right? Save it or just open it and then leave comments on the screenshot, whatever you want. And you can do something better even. Okay, can I do the result for the ground floor only? You cannot do it inside our web viewer for now. We're working on it. That's a very good question. The link works, but could you show how you get there from workshop folder? Yes, I can show again like how I get there from workshop folder. So workshop, I go to the job that I just ran. Right, I click on jobs. Under jobs, there is a list of runs. And inside run, I have all the inputs of the run, and I have all the outputs. And one of the outputs is visualization. So I click on visualization. It takes me here. I click that on this VTK.js, which is the format that we use for visualization, and I'm here. And there is a bug when you resize, it just goes back, but that's a small one. And the rest I just set up. I went to grid, which has all the data. You see I have like around 6 metrics: continuous daylight autonomy, useful daylight illuminance, and upper and lower. So I select useful daylight illuminance. I set this to 100 and 0 and all the good stuff. Any other questions?
You can turn off the grid and visualization.
Yes. Yeah, you can just turn off the grid like any other layer.
But you want to see the color gradient, but not the dots.
Oh, that you technically can. We didn't expose it because there are. So if I go to here, you can see it. There's 3 types of visualization. There is surface, wireframe, and points. So if you use surface, you will see the colors as like surface. But for now, we just deployed the easy one, which was the points. But we can, if this is an important thing for your visualization, yes, you can. We can basically make surface for result visualization so it looks like a mesh. So here you don't really see the dots, right? You just see this. The reason you see that pinky thing is because of the color of the floor. So now that's gone, and then you can also go and change the point size to be larger. So they look very similar to a mesh, even they're not a mesh. For now, until like we give you the real mesh.
Mm-hmm.
Yeah. How do you send simulation to the right pollination job? Okay, so there is another question here. This is something I think in the UI we have to work on. It seems like no one can find it. So if when you do run simulation, here, when you select the recipe, right, you can select the project that you want to run the recipe under. So Alex, this is the place that you want to go. So if you go AEC, then you can find it. So you click on run simulation, then you select the project, and then it will show you all the projects that you have right access to. So you can submit the job. 12:10. Okay, we're good on time, but if there is like 1 or 2 more questions I can answer, and then we can go and see what Mingbo has done with the model for energy modeling. Any other questions? So if you only see your demo folder, can you see the project on Pollination? Can you see the project on Pollination web app? If you can see the Pollination on web app, okay, so if you cannot see the project on Pollination web app, then that means you're not part of the team yet. So send your information to Antoine so he can add you to the team. If you can see it on Pollination, then you should be able to see it here. This is the same API call. Like we're just calling the same thing on the web and from the Rhino. So it's not like there are 2 different places. They should give you the same answer. Okay, so we talked about result visualization on the web, but what if I want to visualize the stuff inside Rhino? So of course you can do that too. So if I click on load results here, for you, if you didn't do all the crazy things that I did with my model, then you should see a run here. For me, for some reason, because I think I did Control-Z and everything, it didn't work, but now I can add a cloud job. So I go here and browse. I go to AEC. Oh, this is the one that I have read access to, so it will be a very long list. Okay, so these are all your demo. This might be another thing. Oh, okay. So if you're checking the read access, because there are like several pages, your project might be like in a different place. So you have to go next to find it. That's again something that we can really do some work on the UI side to be better. But this is the result of the run that I just ran. So I should be able to load it, and then I can load the same UDI result. Inside Rhino. Here you go. So the same result that I just ran, and I select sensor grids and hide them. So I just see the result. And if I want, I can double click here and set the legend to 0 to 100. So it makes sense. So now, not only we have the results from web, now I can load that result and bring it back to Rhino and just make it part of the 3D file. So if I save this, now this will be model with results. So this means if you open this file later, all the results are baked like Rhino geometry. So now, again, as I said, we're making Rhino your like platform for running all this building performance simulation stuff. Any questions so far? Does it make sense, the whole process? So we start from Revit, we came inside Rhino. I have no expertise on energy simulation. I asked Mingbo to help me, right? I know some daylighting, so I set it up for daylighting. I ran the UDI, and now I realized, oh, we have a lot of potential glare issues in this room and this room, which I will ask for help from Chris in the afternoon to help us with resolving that. But if you remember, I gave a model to Mingbo to help me with setting up all the metadata for energy modeling, right? Here you can see all the programs are empty for me, all the constructions are empty. I didn't set any of this. I want them, and Mingbo, what he did, he basically fixed that and uploaded that back to Pollination for me. So what I can do now, I can go and download that model. What I'm going to do actually, I'm going to download it in a separate file, and then I show you, and then I come back and download it from here. I just want to show you some of the concepts that we have. You don't have to do that. Just wait and we download it again in a new file. So I have opened a new instance of Rhino. Oh, do we get the data in Excel to display analysis using Power BI? You can, all the information that you have. So if you want to use any of your tools to display the results, if I go here back to a project, let's say playground. And if you have your run here, the whole folder is here. So if you want to get the outputs, you can go here. And for example, UDI that I just showed, the UDI values are here. I mean, you can download this one. This is a zip file. So you can download and get all the results. So anything and everything that you run is accessible to you and you can download it. This is another place that I can go get it, like runs, workspace. This is everything that has been executed. Results are here. And these are the EEL values. Metrics are here, which has all the UDI, everything. So UDI, for every single room, if you want to read it, you can just click on it and these are the values, right? So basically you have access to the whole data that you create for every simulation. But there is a better solution, which we will show you like at the end of this. So UDI is showing a range of 100 to 2000. So when I ran the simulation, the answer is, I don't remember, but I can check. And that's one of the good things about pollination because we keep track of all the inputs and outputs. So here I put the minimum and maximum thresholds. So this one shows between 100 and 3,000, which is the new range. If you want to change it to 2,000 when you run your simulation, change the threshold to be minus upper threshold to 2,000, and then it will be between 100 to 2,000. Any other questions? Okay, love the questions coming.
One big small question. I think in some point I see you allow the run locally. Can you explain if there's a different workflow?
We will run the energy simulation locally.
Is it possible if you run locally, you can upload later for the visualization or share with anybody else?
This has been discussed. Technically possible. It's not. It hasn't been implemented.
Okay.
Yeah, but because we use the recipe and basically they're both the same execution on cloud or locally with the same structure, it's very possible because we exactly generate the same results locally or on the cloud. And I think that's the beauty of like how recipes are written. As I call it, develop it once, use it everywhere. That's the concept here.
Sounds good.
Okay. Any other questions before we get to see what Mingbo has uploaded? Okay. It seems there is no question. So I have a new instance of Rhino. I can go and do download model. It asks me to log in again because this is a new instance of Rhino. Okay, I'm logged in. Let's go back. Here, I go to the project and workshop project. And then I can select the model. So this is called model with program that Mingbo has uploaded here. Right now, we don't have notification system developed for pollination. So you just have to use other tools, but we know like there are way too many tools for people to get in touch and say, this is where I've uploaded the file and everything. So now that I know the file is here, I can go here and say, okay. And it asks me, where do I want to save it? So I can select to save it in the same place, AECtech, but I'm keeping my files. And then I can download it. And after I download it, I can go and open folder if I want, right? And see if it's downloaded. So this is model with program. Or I can close this. And as soon as I close this, it gives me 3 options. So the 3 options is open model, sync model, and import model. Open model, which is the one that I'm going to use now, is just like opens the model in new file. It's like Rhino open file. Import model basically adds whatever you have into your existing model. Sync model is the interesting one. And it's still under development, so it's not perfect. But what sync model allows me to do is just to take the data that I need from the updated model and then keep working on the model that I currently have. So let me open model here in the different instance, and then like let's talk about that a little bit more. So again, validation is part of the process. It's reading the rooms for me. And now you can see that the model that comes from Mingbo has a lot of plenum. I don't know why, but it's like duplicated. No, it doesn't look duplicated.
Can you try to refresh the manager?
No, it looks right. I mean, I was wrong. When I selected it, actually looks correct. So that's this. Then it has the room, and like the magic has happened here, and he has added some programs for me which I didn't know how to set up. And he also added HVAC systems to my model. So I have all this stuff that he has added. This is great. So what I want to do from his model, and did you solve adjacency too? Let's see. No, he didn't solve adjacency here, or did he? I don't know. Let me go here, outdoor. No, this model doesn't have solve adjacency corrected. So what I really want from his side, I want all the program, I want all the HVAC, but I don't want the geometry, right? I just want to get the metadata. In a normal workflow, now this would have been a moment of like, oh my God, what am I gonna do, right? Because now I have a model which I have already changed, added sensor grid, did all this stuff. I even had the model with all the solve adjacency. And now I get a new model which has all the things, but it doesn't have solve adjacency. So is it possible to sync these models together? The answer is yes, and we'll see how it works. The thing is, like, this sync, as I said, we are working on, and like this is, I'm just testing it live with you guys, so we'll see how it works. So one thing, let me do one thing first. Let me do solve adjacency on this model. Oh, actually, before doing solve adjacency, do I have plenums? No, I don't. So, oh, you know what I can do? I can import those plenums from your model.
Yes.
And then solve adjacency. Okay, that sounds good. So what I'm going to do, I'm going to do PO sync model. Or if you didn't download, let's download it again together. So I'm going to do PO download and then sync it after that. So I do PO download model. I log in if you're not logged in. I go to the AEC project. You should be able also to access this, because even if you have read access, you should be able to download it, right? So it is inside workshop, select, it's called model with programs, okay. And then I press download, it will be downloaded. I close this and I select sync model here. So you see what happened? So as soon as I set sync model, now I have all this comparison done, and it's telling me there are 4 plenums here, or like whatever, 3, 4, 5 plenums that are added. Okay, I want to keep this, and I want both to get the geometry of the plenum, and I want to get the metadata. And for this one, it tells me they have been updated, right? But I don't want to sync geometry. I just want the metadata that comes with it. Oh, I have to select one by one. So here, I'm going to remove this. Yep, this multi-select doesn't work. But what just happened, I just selected to get the plenums from the model and get all the metadata, which is all the programs from the model, but keep the geometry from my side. So I don't want to see any changes of geometry that the engineering side has done. Sorry, Mingbo, no offense. But because we added like sensor grid, all those stuff, you don't want to lose it. So now I'm going to merge this, and I keep my fingers crossed.
Hopefully it works.
No, it didn't. Yeah, I knew. Okay, let's see. Yep, it didn't work, sorry. So that's the real world problem that we just faced. So the model from Rhino unfortunately didn't work. The merge command didn't work. But I hope you saw the overall concept of the merge command. So the concept of the merge command is you don't have to redo the whole thing. You just get the parts that are usable, and that will allow you to work like in parallel and make changes. This is again another concept that we got from software development. If you have used GitHub, that's what people do, right? This is not exactly like version control and all the GitHub stuff, but we are going in that direction. There are questions here. Can't see AEC workshop for the download model project directory cited before signing up. Mingbo, is that right? For the download model, you need to have read access, or did you change
Only read?
Okay, so I don't know why. This is something we can debug during the process. But can you upload the same file to Playground project so people can download it from Playground?
Yeah, yeah.
And because we don't give up, let me try again to sync model. And if it didn't work, then I use Mingbo's model for the whole thing. So model with results. This is the last model that they have. And as you see, as I said, if there are commands that we think it can crash, we always save as your model. Here, I don't think I did anything, so I just canceled it.
I just uploaded my model to the playground project.
Okay, so everyone should be able to get it from there. So I'm going to try to do the same thing. PO download model, sign in again. Log, then go to here. I'm going to use playground here that you guys have playground too. So, and then I can select it. And these are all the models that you have uploaded, and this is model with program. So I suggest to do it inside the subfolder to keep the project clean when project is shared, but for now it's okay. And I can download it. I can close it. I can try to sync model. What will happen if I sync model totally? I know like that was totally like, what was the point of doing this? But what if I just try to merge it all together?
Yeah.
Let's see. Let's see if it crashes too. Oh, okay, this time worked. So there was something going on with the way when I just selected a few of them, it basically made the whole thing crash. But I think this wasn't that interesting because now I'm getting your geometry too. And everything also changed to go inside the shade, like the active thing. That's not a big deal, but let's see. So now that I got this from you, Mingbo, I don't know like if other people were successful doing this, merging the models. There are options here to render settings, render by room properties. So it can quickly render by, let's say, program type. And now you can see what Mingbo set up for me on this stuff. So he basically renovated my place to be an office, I think. Yeah. So all the programs that home office.
Make monies.
So yeah, that's the direction here we have now, home office. But I hope the concept is clear to everyone what we try to do. We just try to, I continue working on geometry. Mingbo did the metadata, then I tried to merge the models, and I know it crashed, but we will fix it, and you will be able to only merge the program without changing the geometry. This will help you to go forward, during the process without really waiting for someone else to finish everything for you. So what I'm going to do now, I'm going to go back here. I'm going to create the plenums. Then I'm going to solve adjacency, and I'm going to run an energy simulation, and this time I will run it locally. Sounds good? So you can see how the local workflow is. Any questions before I move forward?
Yeah, question on metadata. Are you going to, if you're working exclusively in Rhino on metadata is created on the Revit side, is that a Grasshopper plugin that you're going to introduce later?
So there is a Grasshopper plugin that we will show. There is a Grasshopper plugin too, but because we use HPJSON to go between this, and actually I don't know if we will have enough time, but if we have enough time, we'll at the end of the workshop what we're going to show is we change a model from inside Revit, and then we use HPJSON and sync it with our Rhino model. But this time, instead of syncing the programs, we only sync geometry. Right. So there are two scenarios. One is you are the designer, you're working on something, you share the model with your engineer or consultant, and they add metadata and they send the model back to you. In that sense, you want the metadata, you don't want the geometry. There is another case on the consulting side that you just fix all your model, you make everything prepared, and the designer side comes in and say, oh, we changed the design. So when they change the design, if they don't change everything, what you want from the same model, this time you want only to get the updated geometry, you want to keep all the metadata that you already assigned to your model. Does it make sense? That's why when you do the merge command, you have two options. You have sync geometry and you have sync metadata. So you can pick which ones based on the workflow that you're working on.
Okay. But all of your filters and settings run on metadata attached to geometry. So if you're starting in Grasshopper,
Oh,
You start assigning metadata to objects that way.
okay. So
No, is that how you do it? Because right now you're demonstrating a lot of named objects.
you mean like, for example, the question is how do you edit the
No,
program type for Office? A small
no, the question
office?
is if I don't have a Revit license and I'm not working
Okay, sure,
from
sure.
somewhere to somewhere else.
Right. If you don't have a Revit license, if someone else has a Revit license and they create an HPJSON model for you,
Comes with the meta.
yes, it comes with all the metadata. So I didn't set it inside Revit, but I could have done here, you know, like I could have gone inside this room and then go into edit room properties, which is the same thing, and Mingbo can show you, like, right? And then I can select here to have something. And then when I save my HPJSON, it comes with all the metadata attached to that information.
Okay,
if
so
I do
there's
this-
probably a naming convention that gets transferred along from, you inherit that.
Now I
but-
see what you mean.
but-
So no, we put all the information about that metadata. You see only the name, but you have access to all the details. Mingbo will show in a second how he set up his model on his side. So your question is basically, how do we make sure if this is called 1980-2004 Climate Zone 1, and we read it back on the other side, it will be the same data. That's your question, is that correct?
No, I'm just, I mean, it's if I'm working locally, 100% locally, and I'm just experimenting in Rhino with Grasshopper or just, Pollination needs these controls, and these controls are metadata tags. So what's that workflow because if you don't have any room and you don't have anything else data associated like that?
Okay, then you have to, oh, I see. So you're saying like, how do I start a project from scratch? So if this wasn't coming from Revit, how do you prepare your model for simulation? Is that the question?
Yeah.
Yeah. Okay. Yeah. So let's say if you have like, if you design something like this, and like, let's say these are 2 rooms and you want to add a window here and all those, what you can do, there are commands for that. So there's a command that says add rooms. So now there are rooms, then I can do, solve adjacency between the 2.
Mm-hmm.
And then as soon as I do this, now I can go add window. So there is another command that says add aperture. And this is add aperture by surface. There is another command, because just to be fast, I can add aperture by window to our ratio.
Mm-hmm.
And now you can see it's like 40% something. And now this should make my rooms done. And you see like all these new rooms that I created are added to Room Manager. So yes, you can totally start from scratch inside Rhino or Grasshopper. Okay. Sorry that I couldn't get your question right away. Makes sense. Yeah, in this workshop, we are showing a model that comes from Rhino, but it's from Revit, but you shouldn't take the model from Revit. There is a full set of command for adding a stuff, basically creating a stuff from Rhino geometry. Maybe I can say that to that. When you download the Rhino geometry, there is a new set of components that gets added to Grasshopper, which is what we will use in the afternoon. And this allows you to go seamlessly from Rhino to Grasshopper. So I can right click here and I can say read pollination model. And now this is my model. So I can continue doing anything and everything that I want to do inside Grasshopper. So this is the seamless transition that happens from Pollination to Ladybug tools. So you go to the Grasshopper side.
Okay.
Okay. You can merge models locally by using Pew. Okay. Any other question that I need to answer before we go forward? Can you send the energy model to Google Drive so those of us not Yeah, I can do that. I can just let me add plenum and then solve adjacency, and then I'll upload it to Google Drive. Or you can actually download it from Pollination. You don't need Google Drive here. So the first thing, again, remember for adding plenum, I was using this Grasshopper script. So I'm going to do the same thing. P1. And I'm happy that we are doing this over and over during the workshop too. So this is like a real world thing, right? Like you just go over and over doing the thing. And it's very important that you automate whatever is possible to automate. So that when the project comes back, it doesn't take you like a day or two to do the things that you wanted to do or you did before. So I'm going to turn this off. I do PO solve adjacency. Select all of them. And now I get an error. Oh my God. I told you this solve adjacency doesn't have a good relationship with me. Like this is something that we have been working on. No, Mingbo, do you have a model that I can use instead?
I can upload a new one.
Yeah, if you can upload a model there,
yeah.
I can use that. Any other questions? Okay, Google Drive says it's there. That's there too. So now I think on my side, I can run the energy simulation locally, or I think for the sake of workshop, I just go without solve adjacency and Rhino.
I just uploaded to 3DM to Google Drive.
Okay, thank you so much. And so 3DM. Which
model
one is the
program.
model with programs? And did you solve adjacency already too?
I merged with your model. Let me see.
So do you want to just take over and just run energy simulation on your side locally?
Yeah. Yeah,
okay,
yeah, sure.
Let's do that. Then you can show that, and you can show like how you edited some of this stuff, and then we change to Antonello to wrap up the morning session. Okay, I stop sharing here.
Let me know if you can see my screen.
Yeah, we see.
Yes, we are seeing.
All right. So I think I have several models open here. So this is the model I have merged with Mostapha's model, which includes all the program types and I can start with the one without modeling parameters inside this model, and then I can just pick several one also as for demo purpose. So let's say I'm going to use this room. It's a living room. I just double click this living room, and for whoever have done the energy modeling, we all know setting up all details is pretty complicated. That's why we have added a lot of like from the Unreal. Let me show. Is that loading? Because the list is pretty large, so it might take some time to load everything together. Okay. So all you can see here is all S3 template from, let's say, like 1980s. to 2019, all program types. So for this case, I'm gonna use one. Let's say because I'm selecting the living room for now. I'll use small office. Let's say I'm gonna use the no, this one. I'll just use the latest standard. 2019. Okay, this one. Click OK, and now this template has been added to this room. So how can we see what's actually inside this one, or can we change anything like schedules, like the lighting schedules? So basically, if we don't want to use this template, we can make a duplicate. And now I can rename it. This one will be AEC something 2019 small office, closed office. So you can change the schedules or internal loads and everything here. And click OK. So let me select the duplicate one. And click OK. And it's assigned. Because I want to create a new lighting schedules for this program type. So we can go to the pollination panel. For the first line here, we have a model resources. So here we have a schedule. So because we have imported the small office, that program type includes all these default schedules inside. So if we want to change the lighting schedule here, so we can double click. See, so the first one is a working day from Monday to Friday. We can see probably in the morning, it will be 0.85% people will be, the office will be occupied, and the afternoon will probably the same. And this is 6 p.m., 5 p.m., everything should be working fine. And probably lunchtime, what if I want to remove the lunchtime? I just double click and change the schedule. And I click OK. Now this should be changed. Let me just double click it. Oops, it is not. Let me see if, did I duplicate? Let me try to duplicate this one. Schedule name, AEC, and change the schedule. Okay. Now I have this one from my schedule manager. Now let me go to the program type. So I'll edit this one and change it to the schedule library. So I have this one, which I have just added. So for this program type, I'll just go to find the lighting schedule here. I'll just drag this schedule here and then drop to this input, and then I can click OK. Click OK. So now this program type will be affected globally. And of course, we can also change. Let me see. I'll select several rooms and then right click from the list and edit property. I can just assign all of them with a default system, or I can load from a template from OpenStudio. So from OpenStudio side, we have all kind of like roughly, I don't know exactly how many, probably Chris can correct me, it's roughly like 200 each like template, system template, HVAC templates. So we can do all air system and heating cooling only, or heating cooling with DOS. So let me just use all air system, VAV. I'll just use the default one, click OK. So for some, okay, so this is a duplicate. So I have this one is imported from the OpenStudio to our model, because this is in this system has been added to the models, which means we can edit it freely. So I can use this one and assign to 3 of them. Now you see, so the new changes only affect to the selected to three models, but the existing property won't be removed. So this is just a quick demo for adding, setting up energy properties.
Mingbo,
Yeah.
can you also show quickly how match properties work if I want just like to quickly
Yeah.
change the living room, yeah, for the other one?
So let me see if I have a bathroom here on the second floor. I want to match with this room. I have some property sets already. So I can type in, let me move this one, PO match room properties. So it will ask you to select a room to modify. So I'll try to select the second floor and click OK. What did it happen? Let me run it again. Okay, now select the source room. It should be this one. Okay. Did it work? No. But let me just isolate these 3 rooms. I order by sort by name and then isolate. So now I have 2 rooms here. So okay, so this room has property. This room doesn't have anything. Now let me run the command again. PO match room property. So select the one I wanted to modify. So this one I wanted to modify. Okay, select the source room. Oops, I hit it too fast. So I can Control Z to redo it again. So select. Okay, and select the source room. So once I select the source room, so it gives you a dialog to see which property you want to match from the source room. So if I select everything, I click OK. So this room will be updated. So the only difference here is the system and the room name. So probably I have to, I wanted to unselect the room, the display name here, right? So here, I think I have uploaded this model to the Google Drive everyone can use. So this one has everything inside. So yeah, Mostapha has shown you the color by program types. So this one, you can easily see everything by color. Underneath it works exactly the same as the one inside Grasshopper side. Basically, we are using the same code from the Python side. I guess that's all from my side. Does that make sense? Let me see if any.
Do you want to also run the energy simulation locally quickly?
Locally? Let me
So
try.
they can see like how the process of running locally, and then we have to switch to Antonello.
Yes. Okay, probably this one is because I want to log it out, log it in again. Okay, I can now close the browser. So for running locally, I also need to log it in because I need to select a recipe from the cloud. The same thing, DDY file. So here, DDY file, EPW file. And if I check run locally, I click run, pollinate. So it pops up this dialog. Basically tells you it's running underneath in the background, and it tells you every message. Hopefully, okay.
So basically, all you need to do for running locally is to select that run locally, and then pollinate. The difference is when you run stuff locally, it's blocking. Unlike the cloud, that when you run it, it goes on a cloud.
Right.
Here for local runs, it just is blocking your Rhino while you're running it locally.
Yes.
And this is again, like just to make sure everyone gets it, like this is the same exact recipe that we loaded from Pollination. So you could have, and you can run the annual daylight locally if you want. It's up to the recipe developer to allow you if they want you to have permission to run them locally. For the Ladybug tools one, for all the public recipes, we allow them for you to run them locally, like this one.
Okay.
So while this is running, if no one has any questions, let's switch to Antonello, because now what we really want to show is, so far we showed you all the more advanced stuff that Pollination does, and this is something that we usually start from there, right? Energy modeling is the more complicated one. Then you have daylight thing, then you have all this geometry, solve adjacency, things that are really important, but at the same time, a lot of design processes that we go to, especially in early stages of design, you want this quicker type of studies, right? Weather data visualization, sunlight average study, radiation study, the things that from the Ladybug tools package, Ladybug does. So what we showed so far is mostly like what Honeybee does in Grasshopper. And for that, that's something that we are working on, and Antonello is pushing the effort. So we will show one version at the end of at the end of the morning session, and we will show you another version in the afternoon, which is the more advanced version that we are currently working on and will be available. With that, Antonello, you should just go ahead.
Thank you, Mostapha. Yep. Hello, everyone. This is Antonello. I'm going to show you this small prototype. Let me share the screen first. Okay. Can you see the screen?
Yeah.
Yeah, the goal is, what we see till now, it's something that we can collocate in step 2 and step 3 of the 3-tier approach. So, but the idea is that we want to run also some very simplified analysis, because we know that we need to build with the climate first. And we also know that if we build with the climate, we can also save money later. Because if we go directly to the third step, where I have to create a HVAC system, maybe I need to create some case, you can fix something with very basic analysis. For example, how many hours I have directly on my window, hour sun, I mean. So the idea is that we want to bring some functionality of Ladybug directly on Rhino to have some quick feedback. So let me move this window here. Okay. Yeah, we have another panel for this case here. When we wrap a sort of a workflow that you can use to create some simplified analysis. And we can start obviously from the climate because, yeah, let me put the building in first, this building here. So we use the same example. You want the same change? No, here we go. So we know that this building should be stay somewhere, should be located somewhere in a specific climate. So I think, I'm sure that also you know that the first step is to analyze the climate. So where the building is located, it's in Italy or it's in Sweden, it's in Norway. So to do that, we try to wrap this basic functionality. And for example, let's suppose that this building is in Italy, close where I live here. I can copy directly from the EPW map the URL. And I can pass the URL in this way, and I get location directly. With this very simple command, I download directly the EPW file, and I wrap the data of EPW file on this plugin. So location is in now, so I can also check latitude and longitude and other info about the location. But what is nice that I can also check the graph directly. And I think this one is a very important step. For example, I note that my climate zone, it's if I want to classify with the Roudsari, it's around 4 or around 5. And commonly, because I'm using the climate file from Italy, commonly in Italy, you have a climate like this. So you have some very extreme hot day during the summer, not really extreme for some of you. And you have very few day when the temperature is very low. It's a sort of, it's not a really extreme climate for, as you can see from the diagram. And I think this one is one of the first steps that you have to do. The nice thing that you can compare the climate. So let's suppose that this building is located not in Italy, but I want to locate this building, let's see, here in Norway. So copy to clipboard, I pass the URL here again, and I get location. Now the data is different, and as you can analyze from this other weather file, in Norway, for example, in this location that I use it, there are many hours where the temperature is very low, also during the summer. For example, here I'm on June, and the temperature in this point here is 9 degrees Celsius. So what does it mean for my design? That, yeah, obviously we need to go to the next step and do some very specific analysis and detailed analysis to understand what kind of material you want to put on your building or other very characteristic of the material of the building. But what is sure that you have to do, you need to work with the mass, you need to work with the orientation or other simple stuff first. And the climate can give you the hint. For example, if I'm in Norway, I know that I want to get as much as possible the radiation. But from the other end, I need to keep in mind that the glass usually doesn't have a really good characteristic from the U for the transmittance, for example. I'm talking about the common glass, and I'm talking about some specific glass that you can put also in Arctic, for example. So in a normal world, so I need to take care also about the climate in order to set up the good strategy for my design. But for now, let's come back to the Italy because I know well this kind of climate, and I know it is that usually I have some hot week during the summer and a cold week during the winter, but nothing of really extreme. So get location again. I have the Horry plot again in, and obviously, because this one read the EPW file, you can analyze every single variable you want. Here, in this example, we have just air temperature and relative humidity split it in two different graphs. But you can zoom in and you can analyze the graph as you want. And we emulate also the Horry plot. So I can get also the chart of the Horry plot. And this can confirm what I told you. So it's not really extreme, as you can see. Or the winter, the temperature, the mean temperature, usually it's around 5 degrees, 8 degrees. And in the summer, you can get some extreme with, like in August or July. Usually in Italy, July and August are the month where you can get some extreme temperature. And you can also analyze other variables, for example, the direct normal radiation, and the other one that you know better than me that is contained inside the EPW file. For example, now I instruct direct normal radiation, and you can analyze on fly. All this just to give a fast feedback about the climate that you are using for your building, because it's extremely important, I suppose. So let's close this one. Let's close the chart and let's go to the next step. This one gives a nice overview of the climate. I can continue to analyze the file. Maybe the next we can also implement some message for the user, for example, about the classification of the climate directly, or where are the worst week scenario, or what is the worst day that you can use for your simulation. But in this case, I need another info. For example, because you know that we need to build with the sun and we need to build with the wind, because build and sun can save, can give you the energy that you need for your energy balance. We need to understand how the sun goes in the context. In this case, I cannot understand where the sun is and where the sun and how the sun goes here. So what I can do, I can also extract the sun path for my location. So now I understand better that the message that, what Mostapha told you is this window here, particular window here, is oriented in this way. This one is the north side, as you can see also from the graph. It's really exposed to the direct radiation. And this is something that we can confirm later with the small sunlight tower analysis. But by intuition, you can see here that is something of critical on your design, especially for the climate that I chose. Because I'm in Italy, I know that during the summer, I need to protect the building by the direct radiation of the sun. And this one, I give you just this image, but many of you know better than me what I'm talking about. It's because everything you can do everything. You can conduct everything to the energy performance and the comfort. These two important part of each project, each design project. And in this case, I know that the problem can be in a climate that I chose during the summer. The problem can be this one. This one is the energy that comes directly from the sun. So it's a solar heat gain. And what does it mean? That during the summer, for the climate that I choose, I need to reduce as much as possible this element here. So this arrow need to be smaller in a way that this arrow need to be smaller as well. And this one is the cooling system. So this one is the energy that comes from the sun. This one is energy that comes from the internal gain. This one is the energy that I lose. This one is the loss that I lose by transmission. And this one is the energy that I lose because of the ventilation. So to keep the temperature stable, I need to add the cooling system. So if I'm able, because I know that nowadays, usually the building has a very good envelope, also the residential one. In Italy, we have a very good window glazing system, for example, and you don't have enough crack on your building. So the goal for this small exercise is to minimize as much as possible the direct solar radiation that comes from the summer. So let's come back to the study here. So what is missing in this diagram is the sun. So I want to put also the sun in, direct sun. And here we can select, for example, one day for this short demo. So 21 June every hour, go. So, and you can also turn on, turn off your the sun in the diagram. And this confirms what I imagine, that if you move the mouse in this way, I can imagine that the radiation comes right here without any shading system in this side. Obviously, the situation changed because if I change the climate, if I go back to the,
just so you know, we are already 6 minutes over. So if you just want to probably run it with one climate, I think it will be fine. So people can take a break before we go for the afternoon.
Yeah, yeah. Let's analyze now the solar radiation that I can get on the windows. So I can use again pollination, because it yeah, you can use with pollination or you can use without it. It's up to you. So select apertures. Yeah, and then you can click calculate, and it asks to select the context. Okay, I need to unlock this one. Yeah, it run, but I need to unlock the building shades. Yeah, let's analyze without the shading system, this one, for example, and then I run again another one. Let's add something smaller. Okay, like this. So again, select aperture, calculate, select the context, calculate. Here we go. So this one is the situation. I take just one day and we have 14 hours of sun. And you can see on this window here, because of the orientation, because of the climate, because in azimuth that have, the zenith, sorry, you have almost 8 hours of sun. And also here, because I don't selected the shadings. I add only the shadings and I show you the results again, but I think it's obvious the message.
Right, yeah, so the overall, my video is off. Thank you so much for doing this, Antonio. So yes, like I saw some people asking, so yes, this is not already part of it. You can change the coloring, yes, like everything that we send out, like you can always change the coloring, don't worry about that when we release it. But this hasn't been released, and this is something that you can see that, yep, black to white. Just we wanted to show you where is the direction that we are going. So we had all the advanced stuff, but it doesn't mean you can't use the ones that are simpler and more frequent. You can basically go from weather data analysis, environmental study, and just build on top of it and go all the way to, like, you know, advanced energy, daylight, comfort simulation. I don't know if you get a chance to see the recipes that we have, but we already have even several recipes for comfort calculation and pollination that you can use very similarly to how we did run the recipes that we showed you now. So, okay, with that, this will be the kind of end of the first 3 hours session. We will have 1 hour of break, which now is like 51 minutes of that left. And then when you come back, what we're going to do, Chris will show us how to do this stuff inside Grasshopper and how we are going to design some shadings for these 2 rooms to make sure like we get good daylight, useful daylight illuminance inside the rooms. If you have any questions, our team will be around to help you. If not, like, see you in 50 minutes from now, 50. Thank you.
Okay. All right. So now you see the pollination app, our three projects basically, or the playground and the workshop. So I figured I'd let everybody know. I mean, for the first few minutes here, while people are still trickling in, I know Mingbo got to show you how he assigned a lot of the energy properties and check those and visualize those in the Rhino plugin, but we didn't really get to show you the energy simulation results because we do have visual outputs for those that you can share with the team members through the Pollination app. So to give you guys a sense of what the results look like, you guys can go to the workshop project that has the kind of official stuff that that we want you guys to look at here that we've run. And you'll see over the lunch break, I ran a version of that annual energy use recipe, the one that Mingbo had run locally when he was running things on his end. I just ran a version of that same recipe on Pollination Cloud. And so if you guys go and check out the job, and then you'll see there's only one run. We just ran a single energy simulation of the energy model that Mingbo had there. And you can see all the inputs and outputs. And some of these outputs you guys may be familiar with if you worked with like the Ladybug tools plugin, like, you have an SQL file, that SQLite file that has all the results. But importantly, we have these kind of result reports and a visual report. And if I click on these, you guys will see these are HTML files that kind of give you a summary of the energy simulation results. And so specifically, I'm just going to right click on the results HTML and download that so that I can show you guys what that looks like. And if you open the HTML file in your browser here, you'll see that it gives you a summary. It gives you the total site energy, building floor area, the site EUI. And these are all, by default, they're in metric, but you can switch these to be into IP. The recipe that Mingbo run has an input for whether you want the results in IP instead of SI. And importantly, as we scroll down here, you can see we have a lot of nice visual charts showing you the end uses, the breakdown of end uses. And looks like this building has a really high heating load. If there's anything that dominates it the most, I guess we ran this in New York. And it has all those windows, so I'm sure that's a big reason why the heating load's so high. And you can see that translates into natural gas energy and electricity. You can see again the breakdown of the electricity by end usage, and then you have monthly charts here showing the electricity consumption by end use. Natural gas heating consumption by end use. Basically there's only just one for that. And then this district heating, which is way smaller than everything else, this is just some hot water, probably supplying the bathrooms of the building, the bathroom programs that Mingbo added. So this gives you a sense. We have, a bunch of other charts here, a lot more information. You can see there's a little, navigation pane here that allows you to see some of the more detailed results. But again, so that's one of the outputs you get from the energy simulation. And then we also have this visual.html. If you download this and open this up, this will give you, looks like it's taking a second to download. Okay. Once we open up this in our browser here, you guys can see instead of giving you just a bunch of charts and tables about the energy use and the zone loads, this is going to give you a 3D view of the model right in the browser without any need for any CAD plugin. So anybody can visualize this. And you can see by default, it's coloring everything based on surface type. But I'm particularly interested in looking at coloring the results with the data, with the results of the energy simulation. And you'll see if I switch to that, I requested 3 possible outputs to color the geometry with here. So at first, I'm just looking at sensible heating energy. And you see we've got some like little sliders here so we can scroll through the days of the year all the way up to 365. And unsurprisingly, we don't have much heating in the summer. But, if I look in January and stuff, you guys can see, yeah, like the programs with the biggest heating use are unsurprisingly this big glass box that's on the ground floor. So, there may be good reasons to maybe make those windows a little smaller or use a better U value on those windows. Let's see, I can look at the sensible cooling energy in the middle of the summer. And again, some of the highest, it looks like cooling loads are on that bottom floor. Not too much in the center here, but a lot on the sides. So this gives you a sense, at least, of some of the outputs you get from that energy simulation. And you guys can feel free to check this out. There's also, a little like summary JSON that tells you like exactly what the EUI is, and this is in SI units in kilowatt hours per square meter. But again, you can get those in IP. And there are a few other things, all the detailed files of the run are also here. But yeah, so that gives you a sense of that we also have these visual outputs for energy use. Okay. All right. But what we're going to spend most of like the rest of this afternoon doing is reevaluating the daylight because in addition to having a lot of heating energy use because of those windows, Mostapha said earlier that we have a lot of glare. And so I just pulled up this is the exact same simulation that we ran earlier, that Mostapha ran earlier. It's the one that if you go over to the workshop project, it's this one right below here, this first daylight study. And so I'm just loading up these results that we looked at earlier. And I want you guys to understand clearly like what the issue is that we're trying to address. So we're looking at the useful daylight illuminance, and that's the percentage of time, of occupied time that the space gets between a certain range of illuminance values. So not too much light, but not too little light. And you can see that we barely have any useful daylight illuminance, especially on this ground floor, on this floor above here. And the reason for that is, again, if we look at the data, and if we go to, you know, we can see how much is below the illuminance threshold, which, you know, there's some stuff in the core, but that can't explain what's going on here. The reason why there's not much useful daylight is because we have way too much light coming through these huge windows that we have here. So maybe, you know, looking at the energy use and the, you know, and combined with the fact that we have a lot of glare, a lot of, you know, too much illuminance in these spaces, we go to the client and say, maybe consider making the windows smaller. But the client comes and says, okay, no, I'd really rather not do that because I like my glassy facade. So we decide as the kind of lighting consultants that maybe the next best thing that we can do is add some shades to this glass. So at least that we can cut down this glare. We'll start basically doing that. And maybe at the same time, we can, you know, mitigate some of the cooling loads or the cooling electricity. But importantly, yeah, what we're really going to try and do is we're going to size some shades to make sure that this space is still livable, that it isn't just, you know, flooded with too much sun and too much glare during most of the year, as we see here. Okay, so I want you guys, we're going to go back to the same Google Drive folder. We're going to start by working from the model with program 3DM that Mingbo gave us at the towards the end of the morning session. And if you guys just open this 3DM file within Rhino Grasshopper, we're going to start finding some ways to add some shades to this model and see if we can run some of these some simulations to show their benefit or their improvement. Okay, I think at this point we pretty much have everyone here, right? This is the part if people want to follow along, they should make sure that they have this file.
So I don't see any messages, so I assume
Okay.
we're fine.
Okay. All right, so we've got the model with program open. And, you know, it has the energy properties, not the sensor grids, but that's okay, because in order to evaluate the impact of shade on this, I mean, I could do, you know, go through and manually draw shades within the Rhino scene, you know, hit simulate one by one and see the impact that they're having on the glare within these spaces. But there's a much easier way, especially if we want to explore like a few different options of generating these shades. And so as Mostapha kind of already told you in the morning, we're going to be spending pretty much most of this afternoon in Grasshopper. And we're going to take this base model and we're going to generate some shades for it and then evaluate how much they're going to cut down the glare and how much useful daylight illuminance we're then going to be able to get out of the addition of these shades. So, all right, so once you guys have the Rhino model open here, I want you guys to open up Grasshopper, launch Grasshopper. And I think it seemed like a lot of you already had familiarity with Ladybug tools. So I wouldn't want to dwell too much on basically what everything is here, but for the people who are new, who haven't worked too much with Ladybug tools, you'll see the main tabs that you got from running our installer. There are about 5 of them, or actually 6, I should say. As a result of installing the Pollination Rhino plugin, you automatically get the Grasshopper plugin. But maybe I should say also all the Grasshopper plugin, it's completely free and open source. So you can also get it by other means, by like Food for Rhino and stuff like that. And we're going to be using those free Food for Rhino components today. It's just that you guys have installed them, you know, using the Pollination Rhino plugin. So again, the Ladybug tools components are, there's a Ladybug tab, there's a Honeybee core tab, which houses the stuff for pretty much just managing geometry and the properties that are shared between energy and daylight simulations. So we're going to be using this a bit to create some models and stuff like that. You'll see that soon. Then we have a Honeybee Radiance tab that is basically all the stuff that is specific to radiance properties, the kind of the modifiers that you might assign to those geometries to tell you the reflectance and transmittance of them. We have things for sensor grids. We have recipes to run locally even in that. But we're going to be working a lot with this in order to actually assign some of those properties for a annual daylight simulation and evaluate useful daylight illuminance. Then you have an energy tab. All the properties that are specific to energy models are within this tab. There's a Dragonfly tab, which Mostapha mentions for urban studies, but we aren't going to cover that at all today. And then lastly, and most importantly, there is a Pollination tab. And so this Pollination tab is what allows you to basically interact with the Pollination app to send your models to Pollination, execute recipes from Grasshopper. So we're going to be using this a lot today. But to start off first, I want you guys to go over to the Honeybee tab. And you'll see, so these first three categories come natively with the free Grasshopper plugin. But because you guys have installed everything using the Rhino installer, you get this extra bonus tab for components that are just about interacting with the Rhino model. And so there are a few different things here that would allow you to bring construction sets, different types of properties in. The one that we want, though, is this Pollination model. So if you guys drag and drop the Pollination model component onto the canvas. So this is, it's kind of like a, you can think of it just like any other Grasshopper parameter component, like, the one for BREPs or text or numbers, except that this is meant to house just Ladybug tools objects. In this case, just Pollination models, that you created with the Pollination Rhino plugin. So if you right click on this component, instead of having, set one BREP or something like that, we have commands for reading the Pollination model, baking the Pollination model, and synchronizing with the current model in the Rhino scene. Right now, I'm just going to select read Pollination model. And that is going to basically, it's going to take a few seconds, but it will serialize that all the model and all of its properties that we have from the Rhino scene and bring those into Grasshopper so that we can now play around with this model and do some cool parametric stuff with it. So again, all the properties come along with this. If I bring up a panel, you guys can see out of this, we're just getting, this is a model object, a Honeybee model object. And it's the same exact thing if you guys have worked with just the Ladybug Tools plugin. There's a component that allows you to just build models from the individual elements. It's the same, the thing that you get out of this component and the thing we're getting out of this component, exactly the same. So I'm actually going to use this because what I'm going to do in this process is I'm going to take this starting model, I'm going to deconstruct it, and assign certain the shade geometries to it so we can evaluate their impact on useful data illuminance. And then I'm going to rebuild everything back into a new model that I can then send off to Pollination and run through a recipe. So the first step in all of this is now, instead of just getting a singular model object, it'd be really great if I could break it down into its individual components, similar to how I can, select the individual rooms here or the individual context shades. I want to be able to select individual ones of those out within Grasshopper. So I'm going to grab this.
Hey Chris,
yeah.
Do you want to put the bifocal component so people
yes,
can
I
see
was,
the name
yeah, I
of
was
the
just going to do that.
Thank you.
I remembered a second ago, and then I stopped. So this is just so that you guys can follow along a little more easily. I'm going to use a little Grasshopper utility called bifocals that I'll show you. I'm going to leave it in icons mode because that's the way I like to work. But you guys will see above each component I drop on the canvas, you guys will get the name of the component. So that you can easily, like, if you don't know where HB model is, you can just double click and search HB model and, and get the component and easily follow along that way if you guys get lost. Okay. All right. So the next component I was going to drop on the canvas, yes, was this deconstruct model, HB deconstruct model. And so this will take my model input and will give me all the rooms in the model, all of the orphan shades. If I had orphan faces and apertures, those would also come through. But again, because this is an energy model, it's pretty much just composed of rooms and shades. So let me connect up the Honeybee model here. And you'll see out of the rooms input, I'm going to get the list of all of the rooms, basically, all the room objects that are in the model. And again, these are full objects, right? They have all the properties assigned to them. In fact, actually, maybe just to show that, that these are full room objects, why don't we try and visualize them within the Rhino scene here? So I'm going to go under the Visualize tab of Honeybee. You can see there are a few different ways that you can take these like room objects that we have here and make them display in the Rhino scene. I'll just take this Visualize by Type component. I'll go and I'll drop this on the canvas. And I can connect any type of HB object up to this, whether that's a room or shade, etc. But if I go and I connect the rooms up to this visualized by type, we'll see in the Rhino scene that we have, again, we get this nice visualization of the rooms, you know, and their various roof, ceiling, floor, aperture, door type assigned to them. Okay, all right, so I have the rooms. You can see we also have the shades are coming out here, all these context shades, and I can similarly plug those up to this visualized component, see what those look like. But all right, so now that I have the kind of the geometry of these objects within Grasshopper here, what I want to do is generate shades basically from the windows. So first thing is first, I'm going to, under the Create tab of Honeybee, we have a bunch of different ways of generating apertures, whether it's an aperture by a ratio or skylights by ratio. We have a few different types of shades that you can generate, whether that's extruded borders around windows. I'm going to grab this HB louver shades component, and this is the one that I'm going to use to assign some louvers to the model that we have here. And I'm just going to delete this panel just to make things.
So Chris, if you can, for a second, show again, like how did you load the model from Rhino using the component?
Sure, thanks.
And for everyone, we will share the Grasshopper script with you. So if you can't follow, so this is just like to put it together, and then we have the script already. We will share it with you. So don't worry if you cannot follow all the steps.
So the way that I did that again was by right-clicking and then selecting Read Pollination Model. And again, it will take, I mean, if that was quick for me, but the first time that you read it in, it's going to take a few seconds. But basically, that is how you bring the model object into Grasshopper here. And again, that has all of its properties, all the geometry, all the programs that Mingbo assigned to it. I know in this model we don't have any sensor grids, but if you know, those would come as well if we had them. But in any case, okay. All right, so I guess the main thing here, like a lot of these other components we're going to get to shortly, the critical thing that you guys need is just to deconstruct the model and grab this HB louver shades component. So again, the HB louver shades, it can take a room, a face, an aperture, anything that you'd kind of want to add shades to. In this case, we can just plug our rooms directly into this component. And you can see there are a few other required inputs. Easy way to check which inputs are required in the new LBT plugin is that you can just click on the balloon. It will always tell you what you're missing. There's also a convention that we use on the inputs. If there's a single dash in front of it, that means it's required. So there's only one other thing that we need in order to run this component, and that is a value for depth. And maybe we'll say like, all right, we want to build a parametric model and explore a few different depths of shades. So I'm going to connect up a slider for this depth value so that we can, iterate through it basically and evaluate the shades at a few different depths. Maybe we'll say that, we'll evaluate shade depths all the way from 0, just so we have a baseline, up to, I don't know, I mean, this is maybe a little too much. Maybe we'll go all the way up to 2 feet, the kind of longest that we might consider making these louvers. So to do that, and maybe we'll say, actually, I'll explore at every half a foot depth. I want to evaluate that the impact of that shade. So the easy way to do this is to bring up a slider. So I can just double click and type slider and bring up the number slider. Probably actually an easier way to do this, rather, because if you just bring up a slider like this, you'll have to manually set the upper and lower boundaries by, double clicking and, editing things in here. It's a little easier. A nice shortcut, if you guys don't already know it, is just to type what you want to be the lower end of the slider. So in this case, that'll be 0. And then I type a less than sign. And then I type the upper range of the slider. Now, I know he said 2 feet was going to be the upper range of the slider, but if I want to evaluate basically at every half foot, I'm just going to make a slider that goes up to 4. So we basically have, 4 different depths that we're exploring here. And so I just hit enter. And again, that's going to give me a slider going from 0 to 4. And then in order to turn these kind of integer values into the actual depth that I want to evaluate, I'm going to add an expression to the slider. And the easy way to do that is to right click on slider and go down to expression. And we'll just say x divided by 2. And once you have that expression in there, you can hit the check mark. And now you'll see the slider is going to go from 0 to 2. and it's just going to stop at those halfway marks. So, all right, so we had 0 feet, half a feet, 1 foot, 1.5 feet, 2 feet. All right. And okay, is everybody okay up to that point? I think I don't see any thing in the chat. Okay, so yeah, again, we just added the expression by right-clicking and set x divided by 2. Once we have that, I'm going to plug in the depth to my louver shades, and it's going to no longer be orange because it's going to run. And out of this, I'm going to get HB objects that have the shades assigned to them. And just to make sure that the shades are assigned, I have this HB visualized by type component over here. I'll just connect up the HB objects that I have here to the visualized by type. And then we should see, oh, well, right now it's a depth of 0, so I'm not seeing anything. But I'm sure if I increase this all the way up to 2, all right, I'm at least seeing some shades now. All right. So, all right, but this is just doing an overhang. I guess the default is that we only get a single shade. But we can change that, it looks like, using the next 2 inputs on this component. So we can set a distance between the louvers and then a shade count for the number of louvers to generate per window. Maybe we'll say we'll say that our louvers are maybe at a fixed value of, let's say, 1 foot apart, 1 foot spacing. So in order to do that, instead of connecting a slider up to here, I'm just going to bring up a panel that has a 1 in it, so we can specify the distance between is just 1 foot. So in order to do that, the kind of shortcut that we can use for that is we can double click and then type double quotes. That'll bring up automatically put whatever comes after it into a panel. And I'll type a 1 and then hit enter. Of course, there are a bunch of different ways that you can bring up a panel like that, as you know, in Grasshopper, but this is the shortest way I find here. So once you have a panel with 1 in it, we can connect that up for the distance between. And you can see now we're getting the louvers over the whole set of windows. All right. And then the last thing I want to do, I mean, this is probably a little too much. We have so many louvers that we're blocking the view here to the outdoors, and it would be really nice to maybe only generate them for the top portion of the window. That way we're not blocking the view zone, I guess, as they say. We're only putting the shades in the upper part of the daylight zone. And so the way we do that is limit the number of shades that we generate with the shade count. Maybe we'll say that we only have 4 shades. We only want 4 shades per window. So I'm going to double click again, type quotation marks, put a 4, and then hit enter to get a panel that has 4 inside of it. And we'll connect that up to the shade count. Oops. All right. Cool. So you should get something that looks like this. Maybe I'll change just from the, you don't have to follow along that. I'm just changing it so we have some nicer black wires. We can see what's going on. All right. So we've successfully pretty much built a parametric model, right? So we can adjust the shade depths all the way from 0 up to 2 feet. So we can now use this parametric model. We've derived it from the Rhino model, so we know all the properties match the other assumptions that were set by the other team members. We're only editing the shades here. And so now we want to basically bring this all together and send it off to Pollination. So in order to do that, I mean, the first thing that we need to do, so this is still out of here, this is a list of rooms, right? It's not actually the same type of model object that we started off with, right? We just have a list of 20 rooms here. So we somehow need to get back to just a single model like this. So in order to do that, I'm going to bring the HB model component that I dropped on the canvas earlier. Again, you can find that under the 0 Create tab. And I can connect up my rooms to the rooms of the HB model. And then you'll see out of this, right, we're getting a model. Again, it's unnamed. I can change that here if I wanted to, but the important thing is I have all those rooms here. I can also just, instead of previewing the list of rooms with this HB visualized by type, I can just connect up the model here and preview it that way. And actually, come to think of it, I can also use that to preview the model that we originally brought in from Rhino, right? So I can just connect that up to here. And you see, actually I forgot something, right? That you actually have these context shades that are not within our current model with shades. So the way that I'm going to fix that is by connecting up the shades that came from the deconstructed model I'm going to connect those to the shades of the new model that I'm creating. All right, and now I have trees, basically those tree shade, those context tree shades within the model as well. Okay. Yeah, and I see, okay, is there a question? Are we, yes, I saw someone ask if we're in IP units. Yes, we're in IP units, and Mostapha answered that. So that's why, basically, that's why these units here are going to be feet. They're, you know, depending on whatever Rhino model units you have, they can be meters, etc. But yeah, but these values that we're plugging into here, they are Rhino model units. So they're going to obey whatever unit system your model is in. And if you change those and recompute the Grasshopper canvas, it will, you know, it'll change the meaning of those numbers. Okay. All right. So we've got a model that has the context shade. It has our louvers. It has everything else from the original base model. But there is actually one thing that we're missing in this model. Well, we're actually missing in both models if we want to be able to run a daylight simulation. And that is the sensor grids. So you remember how we generated those within the Rhino plugin. Well, we can do pretty much exactly the same within the Grasshopper plugin here. And so this is where I'm going to switch over to the Honeybee Radiance tab. And you'll see under the kind of 0 tab here, the kind of very basic properties that we can add to our Honeybee models. One of these, we have actually 2 components for creating sensor grids within Grasshopper. One of them gives you like the full freedom to create whatever grid you want. But most of the time, we want to just generate the grids from the floors of the rooms, as we did exactly as we did in the Rhino plugin, and that's what the second component is meant to do. This HB sensor grid for rooms. So I'm going to drag and drop this onto the canvas, and you'll see all that it does. It takes whatever rooms we want to assign the grids to, and it takes a grid size just like the Rhino model command. It takes a distance from floor, which there's a default value for, and a few other things we can customize. But this should give us out sensor grids that we can actually then assign to our model for our daylight simulation. All right, so first thing is first, I'm going to connect up the rooms to the rooms here. Okay. And let's see, and then I need to connect up a grid size. You know, as we did in the morning, a grid size of 1 foot, that's suitable for most cases. So I'm just going to do the same here. In fact, maybe I'll just copy and paste this panel with a 1 in it from down here. And then I'll connect that up to the grid size here. All right, and then we can actually see, because the preview is on this component, we can actually see what the grids are like in the Rhino scene. Well, I guess we could if it weren't for this HB visualized by type component blocking our view. So I'm going to right click and turn the preview off here for a second, just so I can see what the grids look like. Yeah, and I noticed something is pretty funky here. So, right, so you see that we have 2 different surfaces here. So what's actually happening in this case is that we are generating, it looks like generating sensor grids from the floor of the plenum, right? And that's causing this extra surface here. This top one is the real one, but we just need to, you know, pretty much we only want to generate sensor grids for the occupied spaces, not for these plenums. Right, otherwise it doesn't make much sense. So we need to find a way to filter out the plenums from this list of rooms. And maybe just to, you know, to do a sanity check, I'll pull up a panel here, and you see, yes, indeed, we have plenums coming through here. So, all right, so I mean, we could just do this, you know, with, you know, normal like types of list management using, let's say, you know, just the the list item selector or something like that. But maybe we'll write something a little more sophisticated. Let's say we're trying to make this script to be reused maybe for a couple of different Rhino models that we want to apply these, you know, do this type of parametric louver study for. So I'm going to just right away to always strip out any room that's named room plenum. I want to have that stripped out of the model basically when I create the sensor grids. So I can do this with some native Grasshopper components. Maybe we'll jump over to the let's see, what is this? This is the sets tab, and there's a text subsection underneath this. And in there's a component called match text. Oh yeah, this is what I want. So this will allow me to basically say, you know, I'll just cast the rooms into a string, into a text string. And then I'm going to basically want to get a list of true false values for whether the text is, you know, is exactly equal to room plenum. So, all right, so the way I'm going to handle this, I'm going to connect up the rooms to the T parameter, which is the text. And then I'm going to, for the P, which is the pattern or the text pattern that I'm trying to match, I'm going to just plug in the words room, space, plenum. So I will just double click here, type quotation marks. We'll do room, plenum, hit enter. All right, and we'll connect that up to the P here. All right, and then out of this match text, I should be getting a list of true or false values depending upon the whether that room or that text that we're casting the room to is equal to plenum, right? So it's pretty much all the ones in the beginning here. So now if I actually want to get a list of rooms without all of these plenums in it, I can use one more native Grasshopper component. And I think this is the last one that I should need here. And that is called dispatch. So double click and get this native Grasshopper dispatch component. And then this takes a list and a corresponding pattern of true false values and will basically split them into whether they're true or false. So in this case, the list that I want to evaluate is the rooms. The pattern that I want to evaluate is this true false list of whether it matches the text. And that should ensure that I get one list of rooms, just the plenums coming out of one side, and then all of the stuff that's actually interesting coming out of the other side here. Okay. Cool. So we've got a little nifty set of components here that will always filter out plenums. Maybe I'll just group those together by selecting them and hit Control-G. And now it's these interesting rooms that I'm going to plug into the HB sensor grid from rooms. Okay. Cool. Cool. And maybe I'll make a little space here because I'm kind of at the edge of the canvas.
So
right.
Chris, there is one question about like how they can see the geometry as wireframe.
Ah, okay.
You can model like a wireframe if you want to show that.
So I imagine, yeah, if you guys are, depending on what your Rhino settings are, like I'm just looking at the Rhino model here in the wireframe viewport or wireframe render mode of the viewport. So if you guys want to like just switch over, if you had something like shaded, it's going to look different, obviously, right? You won't be able to see a lot of the stuff I'm showing there. So yeah, so just right click on your viewport. You can select wireframe that way. Again, I mean, if you were talking more, I think does that answer the question? Or
I think
actually,
it was more. It's like,
sorry.
Okay, you can go.
Yeah, sorry. Well, actually, it's on wireframe, but in Rhino, it shows like a shaded. Is this because of Grasshopper? Like,
is it? I mean, are you seeing something like this?
Yes, exactly. Yeah.
So sorry, yeah, you might have missed. I'm sorry if I'm going a little fast. So
Probably
I turned the preview off on this component.
Oh,
right?
I see.
So if you right click and hit preview, that'll turn it off. So you're not, I mean, it's still running, but you won't see the output in the Rhino scene. And that's what allows you to check this. And you can right click and turn the preview back on. That's, yeah. And you can do that pretty much with any Grasshopper component. If you didn't want to see the grids, you can turn the preview off there and turn it back on. Yeah, that everything should have that. So yeah, that's what I did so that I'm able to see these grids a little better. All right, and this is looking a lot more like what I expect. I'm getting just sensor grids for the rooms that I'm interested in, nothing for the plenums in between there. All right, and I think we're pretty much good. I mean, there's one last thing that we kind of have to do though. We have these sensor grid objects are just kind of hanging out here, right? They're not actually a part of this model yet, and we need to kind of bring all these together into a single model in order to be able to send it off to Pollination. So the last step that I need to do before I'm ready to go and simulate these things is go over to the Honeybee Ratings tab, and you'll see under that same basic properties tab that we use to get the HP sensor grid from rooms, there's a component called Assign Grids and Views. So if you go and drop this onto the canvas, this will allow you to take a model and you can then assign these grid objects to that model so that they're now all together within that single model object. And you can see you could also use this for views. Those are really only important for image-based or studies where you're rendering an image with radiance rather than evaluating a grid. So we don't need those today, but that's what it is for your curiosity. So all right, so I'm going to go and take the model here, connect it up to model. I'll take the grids and connect those up to grids. And now, out of this last component, now we finally have a model object that has everything we need, right? It has our rooms with our shades assigned to it. It has these context shades of trees. It has the sensor grids for just the rooms that we care about. Yeah, and that's all now encapsulated in this one object that we can send off to Pollination. Maybe I'll just connect the model up to here to make the definition a little clearer. But that's it, right? That's all that we really needed to do to set up a parametric model like this to evaluate the different depths of louver shades. So now that we have this, all right, maybe I'll just pause and make sure. Let me go through. I think Mostapha's been getting a lot of the questions here. Yeah, okay, this is just a bunch of stuff about previewing. Yeah, if you wanted to turn the preview on and off, Control Q is the shortcut for that too. So you can turn, you hit Control Q and use that to turn the preview on and off of components as well. Maybe I'll turn it back on right now. All right, but if we have no more questions, I think now we're ready to actually take this parametric model and send it off to Pollination. And so ideally what we'd like to do, we'd like to just have a single job that executes all the different options of the shades that we have here, right? As I'm scrolling through these different shade options, I want to run I want to run the same simulation, but for each of these options. And so this is where you guys will see the distinction between job and run becomes very helpful, because all of these can go together into a single job, but we're going to have, in this case, 5 different runs for the 5 different depths of shade that we're running here. All right, so maybe I'll leave that at 2 for now. And the way that we're going to do this, all right, we're going to go over to the Pollination tab. So now we're finally able to start playing with the actual and interacting with Pollination here. Maybe I'll just delete that panel to get things clearer. And I'm going to grab the very first component in the Pollination tab, this setup runs component. I want you guys to drag and drop this onto the canvas. All right. And you'll see at first this component is very, very simple. It'll tell you you got to log in first, but I'm just going to ignore that and hit click or get a recipe. And again, it's going to tell me that I have to log in. So all that you have to do for this is just hit OK. And if you're already logged into the Pollination app, like I think all of us are right now, things might be easy. Otherwise, you'll get a window popping up like this, and you just need to continue with Google or your email or GitHub, however you guys signed up or created your account. So I'm just going to do that off screen for a second with my account, but I'll show you what it should look like after you're signed in. Oops, okay. Give me a second. Get the right account. Okay. All right, so once you've logged into your account, it should say successfully logged in. You can close this browser window and go back to Rhino. So that's exactly what I'm going to do. I just minimize in case you need it. And then it will say, instead of saying login first, it should say hi, whatever your username is, with a nice smiley face there. Okay. So now that we've logged into this component, next thing we need to do, we need to get the recipe that we're interested in. So I'll click Get Recipe again. And so what's going to pop up is a little UI that you can use to navigate through your different projects. You'll see by default it's going to go to your demo project, just like in the Pollination Rhino plugin. But I want us to go. Let's see. If I'd encourage you guys, because this is this is a lot of runs. I mean, and it's probably we really only need one of them. I'd like to run it and share the results with you guys. If you guys absolutely need to run it, then use the playground one. But I'm gonna write one to workshop right now, and I'm just gonna have you guys all pull down the results once we're done, so we can visualize them together. Okay. So again, yeah, I mean, feel free to select the one just to follow along there. But again, the one that I'd want to run, I'll run this annual daylight viz. Right, so that'll give me the visualization, the same thing that you opened up here in the browser window, so that we can share this with our team members. So I'm just going to select the viz annual daylight, hit OK, and then you'll see the component's going to transform from the single input little thing to a full interface for that recipe. And so depending upon what recipe is selected, obviously you'll have different inputs here. But we can see this is exactly what we saw in the Rhino UI, right? We need a model input, we need a WEA, and then we have a bunch of the other options here. So I'll start by just connecting the model over to here. Simple enough. For the WEA, you can actually create like your own custom WEA objects and files under the Radiance tab. There's a whole kind of light sources tab and a big section for different ways of creating the WA. But as you know, as we did this morning, you can actually just plug in an EPW file here, and that's good enough. And I think the one that we used this morning, it was a, let me see. I mean, you can grab this WA if you want. I'm going to get this EPW file. So from where I have the kind of this EPW file stored on my machine, I'm just going to copy the file path up to that EPW. I'll bring up a native Grasshopper file path. There we go, file path component or file path parameter. And then I can right click that and go to set one existing file. Let's see, that'll bring up a little navigation pane. I'll paste in, paste in the file path to wherever I have these files on my machine. And I can select either the EPW or the WA. I'm just going to select the EPW, but you should feel free. Either one is going to be a suitable input for this recipe. But all right, once I hit open, you know, then you'll see we'll get the path to that EPW or WA file coming out of this component. Okay. And ultimately, that's what I can plug into my recipe here. All right. Let me see. Are there a question? Okay. Yeah, it looks like Mostapha's answering some of the questions there. Okay. All right. So maybe I'll just continue a little bit here. Again, yeah, if you guys aren't, I'd rather everybody not run everything together because we only need one of these parametric runs to analyze the results. So in a second, you'll be able to follow along by pulling down the results. So last thing I'm going to do, I'm not really going to touch much of these other inputs here, but maybe I'll just change the CPU count because I know that I don't need more than, you know, let's say 20 CPUs, I think, to run this study. And, you know, I mean, in the real world, when we actually have the pollination service up, you'll probably want to watch, you know, your CPU limits because, you know, there's more costs associated with more CPUs. So I'm just going to set this to 20 then, so that we can, set some parameters on how the simulation is going to get run. And then lastly, let's see. I'm going to go back over to the pollination tab, and now we're basically ready. We've created this run object that can be sent off to pollination. And if we go to the pollination tab and go to the next subsection over, there's a component called pollinate. And if you drag and drop this onto the canvas, you can connect up run objects to this pollinate component. And so that's how things are intended to run here. And essentially, if I just hit the pollinate button right now, it would immediately start simulating this on Pollination Cloud. But I don't want to do that yet, right? Because this is actually only one of the options, right? This is just a 2-foot shade depth. And ideally, I'd like to set this up so that I can basically have 5 different runs a part of this job that I'm executing here. So the way that we'll actually get together the different separate runs that we want to be a part of this job is that we're basically going to use the same exact methods that you would use to set up a parametric or to run a parametric model within Grasshopper. And so that'll involve us basically animating through this slider, and we're going to record each run object. So each of the run objects that come out of this component, we want to record them so that we can then basically send them all off to pollination together in one go. So all right, let me set this up right now. So first thing is first. Oh, you know what? Actually, even before I do that, I'd like to have some record on pollination of what the depth was, what the shade depth was as I ran it. And so you'll see that the recipe has this, all recipes pretty much that you load up this way will have a section for user inputs so that you can attach whatever extra data you want to each run. So the way to make use of this is if I go under the, let me see. Here we go. Under the pollination Grasshopper tab, there's a user inputs component. If I just drag and drop this on the canvas, right, this will accept basically any user input type. So I can plug up my depth here into the user input 1. And then those user inputs can then get connected into the recipe so that it gets recorded as part of that run object. But if I were to leave it just like this, basically the way it will show up in the pollination app is it'll just say user input 1 equals 2 or whatever that depth is. So if we actually edit the name of this user input 1 by right clicking on it, and then I'm going to select it and I'll just call it shade depth. Oops. It's taking a little longer to run. I guess yeah, I realized I probably should have done this before I connected it to the whatchamacallit, the create job or the recipe component rather. So forgive me while it's creating a model for each letter of the word shade depth here. If you guys want to avoid this on your end, the better way to do it, probably, or what I should have done is just bring this onto the canvas and type shade depth, before you connect it to everything. Then you can go and connect up the number here and the number here. That way it's not running all the components ahead of this one each time that you run it. So, okay. All right, but as long as it looks like this in the end, then you're good to go. All right, and again, I was saying that we want a data recorder so we can record each one of these runs as we iterate through it. So that's a native Grasshopper component. I'm just going to double click on the canvas and type record. Get that data recorder. And instead of, well, I don't want to connect up the run directly to there. I'm going to connect up the run object to this recorder component. And what you'll see is that, if you haven't used a data recorder before, I'm sure a lot of us have run parametric studies before, and so this is going to be a review. But you'll see basically what it does is that it will, every time that, something gets passed or changed to this component, it's going to record that object. So now if I were to go and run through the slider and change the depth a few times, I'm going to change it from 2 down to 1.5 down to 0.5. You'll see each time it's going to record the run object for us. So so now I have 3 different run objects at different shade depths. These are all kind of like, because they ran at all different times, I don't want to keep any one of these, so I'm just going to hit the X over here. And then lastly, in order to basically run through all of the options that are attached to this slider, we just basically want to animate through it. So animate from the bottom all the way to the end. And the way that we can do that, let me see, I'll open up the Rhino scene here so you guys can see what's going on. So, so I'm just going to right click on the depth slider. I'm going to select animate. And then it will ask you, usually animate is made if you want, intended to create animations. In this case, we're just using it to iterate through the slider. The only thing you'll probably have to change from the default is just make sure the frame count is set to, because we only have 5 options here. So just set that to 5, and then we'll hit OK. And then you'll see Grasshopper is going to iterate through each of those depths. It's going to get recorded each time at each different depth. And you can see that changing in the Rhino scene here. All right, so at the end of this, we should end up with 5 run objects, each for a different depth. Okay. All right. And you can actually see with the run object, shade depth, we can see our user parameter attached at the end there. Okay. All right. All right. Yeah, I think it sounds like someone might have put shade space depth. Unfortunately, yeah, this is, kind of nuance of scripting that you always need it to be one, without any white spaces for it to be a valid parameter name. So that's why we put the underscore there. Just checking. I think most of the questions in the chat are yeah. So someone was asking weather file is not equal to EPW from Ladybug EPW map. Yes, yeah. So the EPW file that I pulled here, this is the same as what you could get from EPW map. So yeah, so just plugging in the EPW file that you download from EPW map is good. Are there any other questions here that maybe I'll just pause for a sec also before we go and send this off. Does anybody have any questions, or you can unmute yourself if you want and ask any questions?
So I have one suggestion, because I know multiple people will run on Playground. Maybe you want people to set up the subfolder when they pollinate in the pollinate component. So everyone basically writes their files to that subfolder in the project. One of the things that Grasshopper component does, and all of our cat plugins do, they kind of abstract the concept of project for you. So when you run something, they upload the files automatically to that project for you to run, which is fine if it's your personal project that you're using. But if there is a project that's shared with other people, you should make sure before running it, you just set a subfolder So the files from that study goes to the certain subfolder. If you set it up and you run the studies, you can see what does it mean on pollination.
Yeah, that's a great idea. So you'll see that we have a few different inputs here. So yeah, so subfolder, if you just want to name that with your, maybe your username or something like that, right? So that it'll, you'll be able to tell which one yours are apart from everybody else's. Because I'm kind of running this on the master project, I think I won't do this. Maybe I'll still set a name up for my run. I'll just call this parametric louvers, maybe UDI or something, just to give it a name that I'll be able to go back and identify it by on the Pollination app. But I'd recommend you guys if you really need to, again, we'll all be able to use this project that I'm running here afterwards to visualize the results. So you don't have to, definitely don't have to run it. But yeah, if you do, I'd recommend putting a subfolder. Okay, and let's see. And any other questions? there are a few other ones here, like there's no Ladybug fly component yet in the new LBT. Because I know, you probably saw me animating through this. And we had a component to automatically do that in Legacy. We'll bring that over into the LBT plugin at some point. For now, we're just animating, or you guys can use Calibri. Calibri is also like, that allows you to iterate through all combinations of sliders easily. I'd recommend that if you have more than one parameter, if you had like depth and spacing there. Yeah, I mean, everybody should have it, slightly different tabs. I mean, I have plugins here that other people don't have, I'm sure. Yeah, okay. Like Ladybug Fly. Okay, all right. And
So
any
Chris,
other?
What if you start the run? So because it will take like.
Yes, you're right. I just realized
6
that. All
minutes,
right.
and then we have all the time to.
Yeah, to answer questions. All right, so I'm going to go and connect all 5 runs up to here. Yeah, you're right, Mostapha. I should have done this. And you'll see the pollinate component is actually going to give me some information. It'll tell me that there are 5 separate runs that I'm going to put together in this job. If I go and I left-click this, it'll say, you ready to run a parametric job with 5 runs?
You forgot subfolder. I don't know if it really matters because other people, I'm worried that.
Because you think, okay, all right, I'll just do it with my username?
Yeah, just so make sure everyone else.
Okay,
just put a subfolder for your studies like this.
Okay.
Yeah, thank you.
All right, so I'll put that. One other thing I noticed actually is that because we may actually want to reverse, because this is the order that these are going to be presented to pollination, I'd rather, scroll through it in the reversed order. So actually I'm going to reverse these jobs, just reverse this list, so that when I eventually come back down to visualize it, it's going to go from 0 shade depth all the way up to 2. Again, so you can treat this just like any other grasshopper object in a list. So yeah, that's another thing that I wanted to show. All right, so we got a subfolder. We've got our name. We like the order that things are going to run in here. And so now I'm just going to hit pollinate. Yes, and again, it will tell me, if I'm running 500 jobs, it's good that it tells me before I do this, because, it's going to use up a lot of your CPU hours. For now, I'll just hit yes. And then you'll see it'll tell you it's preparing. It's basically, zipping up all the models, all that metadata, all the sensor grids, and everything is going together. And now it's starting the run on pollination, and it's created. All right, so now if I wanted to see what this run is like, I could just go to the app. Like I know where we put it on the app here. It's, within the workshop project, and I can probably see it running there. Just to show you guys another way that you can easily access this if you don't know where exactly on the app it's going to be. You can grab this check job status component that's under the pollination tab. And for this, you can connect up the job objects. So you'll see, right, just like with the run objects, we have a job object, or really it's just a job string, right? It's the UUID is really all that you need to identify this. You can connect this up to here, and it will it'll give you the information about that job. So we can tell our job's been running for 45 seconds so far. It's running 0 out of 5 are completed. You can get individual runs out of this too when it's finished. But for now, if I right click on this component, you'll see that there's a useful little item here that allows you to check the job on pollination. So if you just click this on the, after right clicking on check job status and you go check this job on pollination, it'll automatically open up that job so that you can see it, basically see it on the app. And I imagine a lot of you, depending on whether you wrote it to your demo project or to the playground, you know, if you're running it there, that may be an easier way to find it instead of navigating to the app. And so one thing you guys will notice, so unlike the kind of other runs that we did where there was just a single run attached with a job, now we have 5 different runs and 5 different shade depths for each of those variations, each of those options that we wanted to run. And you see right now it only has the inputs. It says status running. I mean, if we wanted to check the status on any one of these, I can click on, let's say, the shade depth 0. And then that'll bring up the kind of the debug and the workspace just for that run. So if I look at the debug here, we can see the progress of that. I imagine it may have, yeah, it's gonna just starting to scale up. I think we're right before when it's going to run the ray tracing studies and scale up to the 20 CPUs that we specified there. So sorry, so now is probably the ideal time to ask for questions while we're waiting for these these simulations to finish. Let's see, does anybody have anything else? So I guess, yeah, so there's just some questions on how, I mean, we are still working out pricing. So, all right, maybe it's first clear to say that, I mean, the Grasshopper plugin, you know, the components that we use here, I said earlier, but these are free. They're always going to be free. They're completely open source. You can click the source code inside of any of these Ladybug Tools plugins and see that. And so, yeah, and so you can always count on you know, these 5 tabs of the LBT Grasshopper plugin. Those are always going to be free and open source, accessible through Food for Rhino. You're automatically going to get those whenever you buy a Pollination Rhino plugin. So once the beta for Pollination Rhino is done, we're going to be selling licenses for that. And so that'll include all the nice UI elements that we work with in the morning, and it will give you a compatible version of the engines and of the Grasshopper components for the Ladybug Tools plugin, as well as this nice little Rhino tab to communicate back and forth with the Rhino plugin. Lastly, the service, so the Pollination service. Yeah, as I said, we're still working out pricing, but there will be options for, basically you'll get a certain amount of CPU hours with a certain package that you purchase with options to extend those. So that's the kind of hierarchy for how things are eventually going to be once we're past the beta on these. Okay.
Okay.
Chris.
Like Sebastian says, like, can you pull up the GH definition?
Oh, I'm sorry. Okay.
It took me like 2 minutes to understand what this. Sorry.
Yeah. Okay. Yeah. So just so you guys can see, is there a specific part that you need to see, Sebastian, or should I just try and stay zoomed out? Is this good?
Yeah.
Can I just ask?
What is the job status one? That was just the last question.
Yeah, it's just called check job status. It's under the Pollination tab. I mean, you can also search for it probably like by just typing check job. Yeah, check job status. And so this just takes that job as input, and then you can right click it to, you know, to add, basically to jump to the Pollination app from there.
Hi, Chris. Could I just ask, when you deconstruct things and reconstruct things, how do you know what's preserved and what's overwritten?
So I mean, I guess you can always well, basically you like any property that is attached to a given object is going to stay there. So I mean, like all of these rooms, you'll see, like if I use some of the other visualization components, they're still going to have all the energy properties that Mingbo assigned to them. So basically, I mean, when in doubt, like, I mean, yes, properties will be conserved. And if I were to take this model object and I had plugged that into this recipe, then everything, it'll be equivalent to the simulation we ran earlier with the Pollination Rhino plugin. So, I mean, the only place when you, is I guess when you deconstruct, right? So we, like, these rooms, even though each room still has all of its properties, it's no longer a part of that whole model. So you just want to, you know, keep tabs on what these other elements of the model are, basically, in order so that you can reconstruct them basically with everything that you'd like to have in the model. I mean, I'd say also, like, yeah, if there were sensor grids, like I said, that you can, you know, this model object has sensor grids. If there were sensor grids in the Rhino model, they would have come into Grasshopper, and you can always access those using this HB get grids and views component that's under Honeybee Radiance. So you can just plug in the model there. And right now there isn't anything, but had we been using a Rhino model with grids, you would have seen grid objects coming out of here. And those would basically be, pretty much equivalent to the stuff that we see coming out of these components that we're using to generate the grids in Grasshopper. Yeah, so yeah, go ahead.
Sorry, just one further question. So if you had a construction in that first model, and then you deconstructed it by rooms and did stuff to rooms, would those constructions be within the rooms component, and you wouldn't need to rebuild the constructions?
Exactly. Yeah. So these rooms, whatever constructions you assigned in the Rhino plugin, those are on these rooms, and those are going, when you rebuild the model with these same rooms, like, basically all that we did with this component is that we copied the rooms, added louvers to them. Everything else remained the same. Everything else about those rooms. Right.
Great,
so yeah,
thank
so
you.
you're not losing any information, and that's kind of the beauty of it, is actually you can jump back and forth, use the Rhino plugin to assign maybe constructions to individual faces, where it's most useful, or if you need to do like a kind of mass, reassignment of constructions or something like this, you just use Grasshopper when you need to for that. Use automation where it counts. Okay. Do we have any other questions here? I see some in the chat. No. So Ladybug tools, the Ladybug tools Grasshopper plugins will always be free. Maybe this was that question was asked before, but these Ladybug tools plugins, they're always free. They're always open source. That's true. Indefinitely into the future. The only things we're ever going to charge for, and I mean, generally, if you want to know our philosophy of what the things are that are open source and free, anything that has to, has to do with the simulation and that would make the simulation more accurate, those are going to be open source. You're never going to hit a paywall to, access a certain feature of Energy Plus or something like that. The things that we are, that are products and that we charge for are just about convenience in setting up and building models and sharing models and in simulating them. Right, that we're never gonna anything fundamental to how you run the simulation itself, or how what the inputs are for that simulation. That's going to be open source.
Chris, your layout tab. Do we have to delete our legacy plugins and then?
Okay, I see. Yeah, so if you have an older version of the legacy plugin, so the latest legacy plugin on Food for Rhino has its own separate tab that you can keep installed alongside the newer Honeybee components. Okay, now I understand what you're saying. Yeah, so I'd probably recommend just uninstalling the current legacy version that you have by just going to your user objects folder and deleting anything that says legacy, deleting those out. And if you install the latest legacy plugin from Food for Rhino, it'll be in a nice, neat, separate tab from the other ones, and there won't be any issues with having that installed alongside the latest LBT plugin. Okay. Yeah, thank you for clarifying that. All right, let's see. Are there any other questions here?
I've got a question.
Yes.
Right now we ran a study with just one parameter that was varying. Let's say it was the shade depth.
Mm-hmm.
If we were running a more complex study with 2 or 3 parameters, is there any way to quickly identify which one has the greatest impact on the result, like a sensitivity analysis?
Yes, yeah. So we'll get there. Yeah. Yeah,
oh, okay.
There are definitely ways.
I'm stealing your thunder then. I'll just wait.
Yeah, thank you for asking that question.
Yeah. I mean, it's a really good one. Yeah, and there are a few different ways to do that. I mean, there are ways to do it in Grasshopper, and then but we'll get to there. Don't worry. But yeah. Yeah, I mean that's the idea with the parametric run, is that you can figure out which ones are the most effective and which ones you should focus on. All right, and then
Chris, I had a quick question about installation. So,
yep.
Are you guys thinking that like moving forward, you would let's say just for Rhino Grasshopper environment, you would install Pollination, and then that would basically give us everything, so we no longer have to install Radiance or Dace, everything else?
Yes.
Previously?
Yeah, exactly. Yeah, the installer you get with Pollination Rhino, that has everything you need. I mean, except for Revit stuff. But you're getting the simulation engines, you're getting the core libraries, you're getting the Grasshopper plugin, and of course you're getting the Rhino plugin. So all of that is packaged in the installer that you guys ran this morning, or last night, and that's what we're basically offering. Yeah. Is that?
And does it, and do you guys have any kind of like corporate or silent installers available as well? Or is that?
Yes, we do.
Okay.
Yeah, it is installable via command line.
Okay.
And yes, yeah, and there's a silent install workflow.
Thanks.
Okay. All right. Could I recommend Calibri and HB train sample scripts? Maybe. I mean, there are other examples for how to use Calibri that we can't really get into the workshop here. Oh, you shared. Great, awesome. You shared. So yeah, Mostapha's got you covered on that one. I'm just reading some of the other ones. So yeah, and Michael, you're asking if you can run sunlight hours and not need cloud computing. Yes, you can run everything locally if you want. You'll actually see, so there's a little icon that tells you if it's running on the cloud versus local. And all that you need to do to run locally is basically run on local machine. You right click on that pollinate component, you can run everything locally without using up your cloud computing hours balance. So yeah, so the idea is use the cloud for the thing that it's useful for. When you really need the scale of it, or you need to share the results with other people. That if you're doing tests in your local machine, you can run them locally just as easily.
Yeah, that's really great, because in a large organization, you can basically have most people running on, let's say, locally, and then certain teams or whatever to access the cloud, right?
Yeah. Well, exactly. Yeah, especially you have a beginner who
two different
you
systems.
don't. Right. Exactly. Yeah. You maybe just want them to run everything locally until they're ready to, or you can run it in a dedicated project to them. There are a lot of ways you can manage that access. Yeah. Yep. But but we're not a cloud only solution, I guess, as a lot of other companies tend to be. We're a comprehensive solution, both local and cloud, where it makes sense. Okay. So, and there's no CFD stuff right now. Eventually we're going to get there. I promise you, but yeah, there's no CFD yet. And Dragonfly, if you're curious, again, it's mostly for running urban scale energy simulations. You could also run urban scale daylight simulations with them right now. So it's really just, it's kind of just like an abstracted layer on top of Honeybee for running urban scale stuff. So anything you'd run with Honeybee, basically you can build with Dragonfly. But yeah, we're not going to get into that with this workshop too much. So, okay. All right. I think at this point, let me check on our run. Yeah, it looks like, well, you guys can see all of our 20 CPUs scaling up here to run each of the ray tracing steps. And it looks like it went through the end of post-processing. So if I go back to the workshop project and then to our particular parametric job here, yeah, we'll see all of them succeeded. It ran about 8 minutes per each run. Again, now we have each of those shade depths here, and instead of just showing you the inputs, now we also have outputs for each one of these. And you can see we have that visualization output, the same thing that we had that we showed you this morning. So if I wanted to see how effective shade depth of 2 was, I could just send someone the link to that VTK.js file. And again, I can then preview what the UDLI is going to be like in the browser. But instead of going all the way there, let's do something a little more grasshopper-y for now, because we're Grasshopper to interface, we have sliders and everything. It's a little easier, I think, to explore parametric results while we're here. So I want everybody. I'll save this one to a Google Drive, to our Google Drive, so that everybody can access it. Let me see here, and maybe I'll just put it into a Grasshopper subfolder. So do you guys have a record of? What do I call this? Okay, Grasshopper. All right, and then we'll call this parametric daylight. Okay. All right, so you have a copy of that, but now I'm going to start a totally new document here, because the idea being that if I'm someone who knows Grasshopper and my coworker ran an annual daylight simulation, oh, I don't need that anymore, right? Then I should be able to see the results of this job. I should be able to download them and bring them into Grasshopper myself and explore them. I don't need that original definition to do that. So in order to get this job, basically, in order to import it into Grasshopper, we're going to bring down that same check job status component that we used earlier to to find the link to our project. I'm going to bring it down again onto the canvas. And just so that people can follow along here, I'm going to drop bifocals here so you guys can see. Okay. So I just need this check job status again, and you can double click it or right click and go to, there are two ways to get here. Basically, either double click it or you can right click and go to browse project jobs from Pollination Cloud. And this will bring up a dialog not too different than what you'd use to search through projects and different runs and stuff. So first, I want to basically change this. Instead of running through my personal demo project, I'm going to go and browse. And I think right now this is just going to show me all the projects that have been created on Pollination. So I have to hit next a few different times here to get to the very end where we have our workshop project. There we go. All right, now we're at the end. Oh, we got a bunch of new demos from all the new users here. All right, so here we go. Here's the workshop, AECtech 21. All right, so I'm just going to select this. And then you'll see that'll bring up all the runs that we've done so far. So we actually see, this was the annual daylight simulation that Mostapha ran this morning. This is that annual energy use one that I ran during lunch to show you guys. And then this is our parametric daylight one that we have here, our parametric louvers. So I'm going to select this, hit OK. And you'll see now, basically, it'll tell me, that this run, the status of it's completed. There are 5 separate runs within the job. And if I pull up a panel here, right, we'll get actually we're just getting a single run object, single run object out of this right now. And that's because when you have a parametric job like this, you need to connect up an index in order to specify basically which one of these you want to pull down, you want to download. So right now it's just pulling up shade depth 0, right, the first one up here. So if I'm going to connect up a slider so that we can iterate through those different, the different runs that we have here. And again, I'll use the same shortcut I used before. So I'll make a 0 less than 4, all right, because there are, from 0 to 4, those are the indices of the jobs. All right, and then I'll connect that up to index. And so now I'll actually be able to access, whether it's the first one or the, second one, with increasing depths basically here. I'm scrolling through those different runs that are a part of this job. All right, so maybe let me go back to 0 so that we'll just pull in the kind of base one with 0 depth shades. And all right, and next thing we'll need to do is we're actually going to want to download the various inputs and outputs for the simulation. All right, well, let's grab the outputs first. So under the Pollination tab, there's a component called check run results. I'm going to drop this onto the canvas. And you'll see that this will take the run object that's coming out of our check job status. And if I connect it up to here, it's going to transform. And we're going to get a little, basically a list of all the outputs that this recipe has. So we have continuous daylight autonomy and daylight autonomy. We have the visualization output even. And then we have the one that we really want to look at here, which is that useful daylight illuminance, that UDI. So again, you'll notice that this is just a kind of object, like a reference to the object. It hasn't been downloaded to my machine yet. So if I actually want to get these UDI values into my Grasshopper definition, I need to go to the very end of the Pollination tab here and grab this load assets component. And so this is the one that's responsible for downloading, the output that you want and then loading that up into Grasshopper. And you can select the folder that it downloads to. I'm just going to leave it at the default for now. And I'm going to connect it to this UDI that I'm interested in here. And then you'll see this component will transform too. And now instead of getting just a UDI like kind of reference object, we're actually going to get for each and every sensor in that model, we're getting the UDI value, the useful daylight illuminance, or the percent of occupied time that is daylight. That is between those two illuminance thresholds. Okay, all right, great. So I've got the raw data. I could already do some analysis on this in Grasshopper. Like if I want to figure out the, the average useful daylight illuminance, I can plug that in. Whoops, well maybe that was a little too premature because I think I have some nulls within this list. But right, you can already use this. Maybe if I cast it to a number, I'd be able to do this, right? You can do various types of analysis in Grasshopper that might be otherwise more difficult to do in other interfaces. And so you can see room by room, like what the average UDI is. But really what we'd like to do is I'd like to actually, visualize this on top of my geometry in the Rhino scene. So in order to do this, I'm going to go grab a it's not native Grasshopper, it's a Ladybug component that lives under the Ladybug tab. and it's just called LB Spatial Heat Map. And so this component, if you guys are familiar with it, we used to call it Recolor Mesh in Legacy, but it just takes a list of values and a kind of mesh of sensor grids, and it will give you a nice false color image of that mesh, basically based on the values that you connect to it. So in our case here, we want to connect up the UDI. Those are our values, and then we'll need to connect up a mesh, basically. So the question of how do we get the mesh? So we know that the mesh, right, it's a part of the sensor grids, right? We have it back inside the original file that I used to create, generate these sensor grids. Like there's a mesh here. But, I don't want to go back to that original file. I'd rather get the mesh directly from Pollination, from this run. So in order to do that, we're actually going to have to look back at the inputs here that we have, the various inputs for this. And we know that those sensor grids are a part of the model. So we have to somehow download the model if we want to then get out the sensor grids to color the geometry in the scene. So, all right, so in order to get those inputs, let's go back over to the Pollination tab. And if you guys see, just like the check run results component, there's a check run inputs component. And so if you drop this onto the canvas, again, just like the results component, this takes a run as input. And when I connect up a run, it's going to transform. Right, so all right, so now I've got all the inputs basically now, just in the same way that I have the outputs, I have the inputs available for my simulation. And of course, yeah, so the things that are just numbers, they aren't going to have a little asterisk next to them. The things that are actual files that are going to get downloaded, those will have a little asterisk, and those are just the model and the WEA in this case. So all I need is the model basically to get that mesh again. So I'm going to actually use the same load assets component to get both the UDI and the model. I'm just going to connect up the model here to asset 2. And then you'll see the component's going to transform, and we're actually going to get a path to an HBJSON model here. Okay. All right. And so one thing you guys will notice, so, when we brought the model in from Rhino to Grasshopper, it was an actual model object, right? It was something that we can edit and deconstruct and do everything with. When we download models from Pollination, they're just going to be a file. In this case, it's a .hbjson file. And so all of the information that's needed to recreate that model object exists within this HBJSON file. We just need to load that model up into Grasshopper to get that object, extract that object basically from that file. So in order to do that, under the Honeybee tab, there's a whole sort of subsection devoted to serializing models. This is basically, different ways of writing and loading models from files. And in particular, this HB load objects, this will allow us basically to take any HBJSON or JSON basically of Honeybee objects and load those up to the actual Python, the objects that we can play around with in Grasshopper instead of just having those be in files. So, all right, so I'm going to connect up the model to this HB load objects, and then you'll see we still need to connect something up to load, and that's just a Boolean to tell it to run, to load up the model. So I'm going to double click and bring up a Boolean toggle. So double click on the canvas, search for Boolean toggle, select that, and then we'll connect that to load. And then once I set load to true, I'm going to double click the false to set it to true. And then we'll see, instead of getting just an HBJSON file, now we're back to that model unnamed object. Again, so this is exactly like what we pulled from Rhino. We could deconstruct the rooms of this. We can get all sorts of stuff out of this. And in particular, if we're interested in coloring the sensor grids, right, of this model, then we can use the component I showed you guys earlier, right, that allows you to take the sensor grids out of the model and basically get that sensor grid information. So if you guys remember where that was under the Honeybee Radiance tab, under the basic properties, and towards the end here, there's a HB get grids and views, right? So this basically takes a model as input and spits out the grid objects so we can then use them to color the results in Grasshopper. All right, almost there. So we just gotta, drop this component on the canvas, this HB get grids and views. I'm gonna connect up our model to this. Right, and then out of this, we'll get the actual sensor grid objects, right? The same thing that we generated, that we originally assigned to the model. But helpfully, we'll also get, the points, the sensor points that make up each one of those grids, and we'll get some meshes. So that each sensor grid, right, has a mesh associated with it. So that's the mesh that we ultimately need to color in order to create a spatial heat map here. Okay. All right, we're almost across the finish line. So the last thing I'm going to do here, we'll take the meshes from the model that we've loaded up here. I'm going to connect them into here. And at first, right, when we're connecting, you know, a list of values like this and a bunch of mesh, I think it might not like it too much. Yeah, it's not matching the number of mesh faces between vertices and the values in this list. So what we have to do some Grasshopper list management. So we need to flatten the values. So I'm just going to right click on values and flatten them. And then I need to join all these meshes into one. And for that, I'll just use a native Grasshopper mesh join component. And make sure, yeah, I guess I don't need to flatten the input, right? As long as I get just one mesh out of this. All right, then I should be able to go and plug that into there. Okay. All right. Now, all right, we're finally there, right? We've loaded up the UDI results. We've loaded up the model, extracted the meshes of the grids. And now, if we go over to our nice Rhino scene, we should see, well, we got a few things previewing on top of each other. Notably, we've got the preview on for these get grids and meshes. So I'm just going to right click on this and turn the preview off. And what else? Oh, and we still got the mesh join is still also, we were seeing that mesh previewed in the Rhino scene. So I'm going to right click and preview off. All right. And finally, we're looking at our UDI results within the scene here. All right. So maybe I'll take a second here. I know that there's been a lot of questions probably in the chat. Let me see if there are still any open ones, because we're at a good breaking point now before we actually go and start interpreting the results. Okay. Okay. All right. Yeah, people are already asking. They're one step ahead of us already in the workshop.
Yeah, I think the one that you can help, right? The last question is, lots of my Honeybee components are red because of lacks constructions and modifiers folder. Any idea how to fix?
Because it lacks. I mean, what is the specific error? I mean, so somehow it sounds like you don't have your standards folder, which should have come with the installer. Yeah, I think, I mean, that's a generic error that you get from the Grasshopper plugin when it can't find. I mean, basically, the folder that you need is, I'll show it to you right now quickly. It's under users, whatever your username is, Ladybug tools, resources, standards, and then Honeybee standards. So it looks like you lack these folders here that are meant to keep basically your kind of both your user library of standards as well as your as well as the default values that get assigned to the Honeybee objects.
So my guess is if you use the Grasshopper installer, the Grasshopper installer doesn't come with Ladybug tools installer. If you use the Rhino installer comes with everything, including the Ladybug tools installer that has everything updated. So that might be the reason if you just use the Grasshopper installer, which it's my bad. I initially sent it in my first email, that was only Grasshopper installer.
Yeah, that makes a lot of sense. Yeah, because the Grasshopper installer is really just meant to augment a Food for Rhino installation of Ladybug tools. Yeah. Yeah, so that's the source of the issue. Yeah, so just make sure you run the Pollination Rhino installer, and I think it should work. Okay. All right, cool. All right, if that was the only kind of open question here. So you can see, right, so these are now the exact same results that we were looking at in the VTK in the web browser here. But the nice thing is now that this is all within a Rhino Grasshopper definition. Oh, maybe I'm just going to add one more finishing touch here, because the legend doesn't have a unit here. I'm just going to, for clarity's sake, I'm going to call it, make sure it's labeled as UDI. So you don't have to do this if you're following along here, but right. So UDI 0 means that none of the hours are, are within the daylight range. And we can see we have some of those in these interior spaces, which maybe I think are the bathroom. They're probably not regularly occupied. Right. But importantly, right, this is without any shades. So we're seeing that same really poor UDI values in this kind of glass box that's on the bottom floor here. Now let's see what happens when we increase the shade depth. And you know what, keep this a little magical here, I want to be able to look at the shade depth as I am, you know, as I'm scrolling through the slider. So I'm just going to grab this HB Visualize wireframe component, and I'm going to connect up the model that I loaded here from the HB.json file. And so this will, I mean, you're not going to see anything change in the Rhino scene right now, but this will basically give us a wireframe representation of those louver shades, so I can actually see how deep they are as I scroll through these UDI results. All right, so now it's time for the magic. So I'm just going to go grab this slider over here, and let's see, maybe make the Rhino scene a little bigger. And I'm just going to start scrolling through. So shade depth of 0, we'll go up to a shade depth of 0.5 feet. That was our first value here. It'll take a second to load, but we can already see, right, there were these big blue spots previously. And just by putting in, you know, these half-foot deep shades, that is already dramatically, yeah, I mean, that's a much better UDI than what we had before, right? If I were to go back to what I had here, I think most of this floor was actually, you know, below 50% UDI, right? Yeah, so we're seeing a really big increase just by adding a little bit of shade in there. So let's see what happens maybe as we increase it from, you know, half a foot up to a full foot.
Is the legend fixed?
Oh, you know, maybe, yeah, maybe
Yeah,
that's something we should probably do, right?
Legend
I mean, it's not changing too much. Yeah, but you know, if we, right, because it's mostly still from about 90 something from 0. But if you guys want to fix the legend to be static, here, I'm just going to grab some Ladybug legend parameters. And this, you know, this allows you to customize the min and max the legend, the colors of it and everything. So I'll just make sure that we're always fixing everything to 0 and 100 as our upper and lower boundaries, because those are, you know, whoops, those are the limits of what UDI can handle. And I'll connect those to the legend parameters of the spatial heat map. Yeah, so all right, so this will be a little more consistent as we scroll through the results. Still, you know, this is way, way better, right? Way better than what we were seeing before, and this is with a depth of 1 foot. We can see, you know, it's still a little yellowish up here if we keep going up to a full 1.5 feet. You know, we'll see, will it change from yellowish? Yeah, now it's more orangey, right? We're getting a lot more useful daylight in this upper floor. Thanks to these louvers. And even if we go all the way up to 2 feet, probably it looks like we're starting to hit, like, you know, we're leveling off in terms of the benefit we're getting back now when we're around at 2 feet. It looks like it's still better, you know, the deeper we make them, the better it gets. But probably, I mean, there was that huge jump between like no shades and, you know, half a foot shades, whereas the jump between, you know, a 1.5 foot and 2 foot shades was a little bit less. But you can see this is, I mean, this is just way better than what we had earlier. Right, so we found a solution, you know, at least for the client, that if you, I mean, maybe they don't have to go all the way to 2 feet, because I imagine that's probably going to be tough to convince a client to do that. But maybe if we got them all the way to go to just 1.5 feet, we'll see that they'll dramatically improve the useful daylight within their space, and they'll really cut down on that glare that we were seeing when there are no shades in this model. Okay. All right. So, are there any other questions before we move on from here?
One would be just in terms of how do we get additional information in the legend, or how can we pull out additional data so we can, you know, give the client what percentage of their floor plate is, or any other things that we would normally pull out of results.
Yeah, so I mean, if you wanted to, well, you can always do native Grasshopper processing on, you know, on the UDI results here, or you know, whichever results kind of come natively out of here. Like you saw earlier that I did, you know, I don't know if we want to do the average, let me make sure they're cast the numbers, and we'll do the average UDI in each space. And then, you know, basically anything that you can do with Grasshopper, then I can go and, you know, get the centroids of these meshes and use those to create text labels. You know, where's text tag 3D? There we go. Right, for basically what those numbers are, and then, you know, what the centroids are here. Oh, I gotta flatten that though. Right, so you can create visuals like this, and you can see, right, like, okay, this space has 68% is the average UDI. This one has 72, right? You know, you can play with the justification of this, maybe center it, right? Yeah, so there's a, you know, you can do anything you do within Grasshopper, you know, you can use that, right? That's the beauty of being able to load the results up here, is that you can still customize all the results as you would with you know, with you know, just using the LBT plugin locally.
Thanks.
Yeah.
Yep. I also wanted to point out one other thing that this script can do now. And Chris didn't use the model to visual. Oh, he actually did. So now if we save this, right, save this file and send it to someone else, like if you want to send it to your colleague, basically if they have a Pollination account and they have access to this project, they don't need to have access to your Rhino file, to your Grasshopper file. This script is self-sufficient to download all the results from Pollination and do all the post-processing inside the same Grasshopper script, if that makes sense. And the result will always stay there. So it's not like in a month you don't have it, or if the project comes back, you don't have it. It's always staying there in the,
yeah. So basically, right, and this component is going to remember what that run is that it's pulling.
Right. I mean, you can right-click on job and extract it. That's what I usually do. Extract parameter. So to make sure, otherwise the user have to go and find. So this is always now like pointing to
so this is static. So so if I were to open up a brand new file, I don't even need to have the Pollination Rhino plugin installed, even, because we're just using native Grasshopper components and Ladybug tools plugin components.
You need Rhino because that's the way you load the model into Grasshopper.
Oh, yes, because
no, I'm wrong. You don't need Rhino.
Right.
Like for the post-processing, you don't need Rhino. You're right.
Yeah. Yep. You just need to make sure, though, you do need the Pollination tab. But if I were to go like, right, this is a totally, you know, separate Grasshopper definition. Right. And if I were to grab, oh, no, not this one. Where did I just write this to Google Drive? Here, right. If I were to the Grasshopper file that I saved for you guys to access here, right? You guys can just open this, even if you don't have a Rhino model open. Oh, yeah, here it is. Right, I just select it, and right, and I can load up those results without having anything connected to the rest of the project, right? So yeah, it just makes it easier now. You can pass the model, pass the results to, you know, any of the team members can access them when they're on Pollination. They don't need to have the original source file, right, to do their own types of analyses on top of the simulation. So let me see. Oops. Oh, it looks like it's just, oh, I have to log in first. That will be the only thing, I guess. You just have to log in, but once you do that, right, it's all good to go. All right, were there any other questions here before we continue?
Hey, Chris, I just have a question. I figured it's probably too hard to put into the chat, maybe too open-ended, but first, thanks for the workshop. This has been really great. So I noticed in the daylight results that looks like some of the shafts or chase areas received sensor grids, the dark blue areas on the second floor. What would you recommend as the best practice to eliminate that? Is that something you need to do as early as Revit? Something you do when you're setting up the grids in terms of another kind of dispatch text matching parameter?
Yeah, so yeah, there are a few ways to do that. I mean, so basically, right, that you're talking about back when we were creating the model, oops, not that one, oops, okay. Sorry, I just dragged the wrong Rhino file over here. So this is the one, okay, where we set up the model. Yeah, so right, so I mean, you could definitely, you know, just copy paste and keep using native Grasshopper components like this. Honestly, at that point, though, if there are a few different names or something that I want to filter by, probably what I would do at that point is just grab a native Grasshopper or just a GH Python component, and I can, you know, change this to list axis, maybe change this to list axis, and I'd make, you know, something custom with a few lines of Python. You know, this will be names, you know, to cull or something like that, and yeah, this will be the model. Or sorry, the rooms, right? And I can just write you know, a few lines of Python, maybe, well, I'll connect up this, but I can say, you know, something like this. And you can, you know, rather, instead of having, you know, so either way is acceptable, right? You can either have a bunch of Grasshopper components, or you can, you know, loop through basically for room.
Okay, so this is a way of like identifying generic room names instead of like shaft 214 and having to list all those individual names out.
Yes, yeah. So that's one way to do it. I mean, also like, yeah, I won't finish that, but you know, there's also a way that if you only want to select certain rooms from Grasshopper. I didn't really explore these other components under the For Rhino tab, but there is one that just allows you to select like rooms that you want. So if I bring this pollination room component on the canvas and I say select pollination rooms, then I can go and just pull, you know,
nice.
the rooms that I want. Actually, yeah. So if probably I did the very, you know, developer-y, grasshopper-y way to sort through things. But yeah, but this is also, you know, probably an easier way. And then, you know, once you have those rooms selected, right, it'll bring in, you know, those rooms as objects into, I can show you in a panel, right, into the scene. So in that case, I could have, you know, maybe I could have still brought the whole model, but I have a separate one that brought in the rooms, and maybe I just use those rooms to generate the grids or something like that. That's another way to do it.
Okay, thank you.
Yeah, no problem.
Chris, can I ask you a question on user objects?
Mm-hmm.
All right. I've got a mash of, I guess, legacy user objects and the ones that were in the Rhino plugin. First of all, what's HB-E? HBE?
I think, I mean, so you clearly have some older, yeah, the older legacy ones on. I mean, it might be easiest just to handle, because it's specific to your machine, to go into a breakout room maybe and just, you know, if you want to delete the objects that are old.
All right. Is there an update component that conveys with the new bundle that does this automatically? Where is that located?
There are separate update components for, well, I mean, yeah, there's no one that's going to delete all your legacy components.
All right,
yeah,
I don't know. I got the idea that there might be something like that.
There is definitely an update component, but its purpose is really just to, you know, if you want to sync your, you know, the LBT components with the latest version or something that we have. There's no one that really, I mean, legacy and LBT are meant to be completely separate from each other.
Right. If you check on Ladybug Tools discourse, there is a component that actually removes all the legacy ones that we used to share for if you check the latest release of the legacy, there's also a Grasshopper plugin on the forum that you can use. But yeah, as Chris said, the clean way is just like delete all the user objects, then install fresh. If you want to have the legacy, you should have the latest version of the legacy that stays separate from the new ones. And back to your question about HBE is for Honeybee Energy, because we have Honeybee Energy, and Honeybee Radiance. Now there are like 3 of them.
All right, so they're not out of date. All right.
I mean, well, those ones that might have been for, I don't know what HBE, because right now it's, you know, it's Honeybee.
No, I think if you go back to Grasshopper and display, you're displaying by icon. I'm guessing Outershare is displaying it text. So
no, I'm doing icons. Yeah. I'm talking about the tab titles. I've got HBE, HB, LB, and I've got P and DF, I guess.
If you make it a little bit smaller, that will change.
I see Radiance.
Yeah, that's right. If it's text and you have a smaller Grasshopper window, right, it's not going to spell them all out. You'll get HB, you know, HB.
Okay.
Yeah.
Okay. Yeah. All right. Sorry. Confused.
That's all good. That's all good. All right. So maybe we'll keep moving on here. I can see. Okay. Yeah. And yeah. Now Alex, you just asked. Yes, the Rhino plugin will be paid. The Grasshopper plugin is always free and open source, but the Rhino plugin will be paid once we're at the end of beta. Okay. All right. So I think maybe we'll move on here. So it's great that us as good Grasshopper users were able to load up the results here, right, and really scroll through and understand them. But now the next thing that we're going to ask is like, all right, we got to go over to the client and somehow communicate these results to them and show them why these louvers are such a good idea and really try and sell them on it, because otherwise they're going to get a lot of glare in this space. So for that, I'm going to pass things over to Mostapha, if you're ready, Mostapha. Yeah, okay, to go and present stuff to the client.
So you cannot share a screen with other participants. I think you have to stop.
Yes, stop share. Okay.
So let's share. You see my presentation slides?
Yes.
Okay, so you saw like just a wrap up of what we did from the morning. You know, like we said initially that the whole goal is for Pollination to help you go from a question to actionable data quickly. Then we showed you how we tried to automate all the pain point that makes things slow. We had a couple of crashes that we will fix, but overall you saw like how we are automating the process that if something is going to change in the initial geometry or something is going to change in the model in Rhino, there are always ways to sync it. Then we showed how you can go more than just running a single run, set up and run parametric stuff to get a sense, get the best answer quickly. But we are listening, like so many people ask, like, you know, now there are questions, okay, if I want to share the recipe with my team to run it, how can I set the default to make sure that's the value that I want, right? There are questions about how I do share this with client in a way that they can see it, or do they need to come to Pollination? Do they need to have Rhino? Do they need to have the Grasshopper? There is another question right now is, can we load multiple runs into one result file? That makes a lot of sense, right? Because when you run these parametric runs, you want to have them all in one place to be able to see it. And that has been a thing that we didn't have. And that's something that I'm going to show now how to resolve. So I'm going to get back and start from recipes and the concept of recipes, and then build on top of that to go to the concept of apps, which is the one that we're going to introduce today. So we have a new concept called Pollination Apps, which basically brings all the things that we just talked about it together in one place. So we can build all the custom ways of putting visualization, post-processing, letting people how they want to see your stuff. All of those will be much easier with using apps. With that, let's go quickly and review Pollination recipes. So Pollination recipes are core of the product, as you just realized. They are production ready, they are reusable, and they're customizable. Again, we use the cooking analogy for that to say, we separated the description of the problem from the execution of the problem. And that's why you can run it locally and you can run it on cloud. We just did this today, right? You can run energy simulation locally. Chris just ran the same recipe on the cloud. Annual Daylight, I ran it on the cloud. You could have run it locally. And it's just a switch of like run locally or run on the cloud because the execution is separated from the logic of the problem. And the other thing that happened that you didn't notice, everything that you ran on a cloud actually ran on Linux. And I think most of you are using Windows, especially if you have Revit, you definitely are using Windows. And things ran without any issues on your side, so you didn't even notice the difference here. One more thing is that we will do, again, because this, closer to the end of the workshop, we still have time, is what if there is a recipe that you need that's not available to you, right? How can we collaborate on that? Because of the concept of the recipe and how they're set up, now you can basically go and share recipes without changing your platform. So it's not like before, if you had a recipe and you just didn't have one, then your client would have told you like, oh, you don't have this thing. For example, if you didn't have reflection study, then you had to send all your models back and forth. With the concept of recipe, you can stay and keep working where you're working. And now the client or your consultant can just push a new recipe and you can just use that recipe as part of your workflow without sending your models. So the collaboration stays in a smooth way that we are designing it. And now we can work together to build better solutions. The other thing about recipes is if you start writing recipes, you basically, your recipe will run the same as the recipe that we wrote. So you are developing cloud native solutions without really knowing how cloud works. And that's a big thing, because if you want to understand how cloud works and to set up a server and do all those stuff, that's months, if not years of work. But now it's just like by writing a recipe in days, you have a cloud native solutions. By editing one of the recipes that we have written, maybe in hours, you have a custom recipe for your stuff. Why Linux for cloud simulation? Because it's much easier to scale. And like, I'm pretty sure Tyler and Anton want to talk about that but in detail, but that's the preferred platform and it's cheaper to be able to run it. So all the recipe language is open source out there. You can do it. We have another Python DSL on top of it. For developers in the audience, if you want to develop a recipe, you can do it right now. today, you can go to this website and you can start writing your own recipe. We are trying to make it easier by making it visual, so you can build visual recipes too, but right now you have to write it with some Python. And there are more than 20 recipes already on platform for you to learn. So that's one thing. The more value of recipe, especially if you are on the consultant, like design performance specialist in your office, or you're a consultant works with other architects, or you're an architect who knows this stuff and do it for yourself. Now you can write it once, use it from everywhere. And that means if you design a recipe and you run it on your local machine and you're exploring it, and then you want other people to use it in production, it will take only minutes instead of taking weeks or months to set up it, right? If you have something which is a small and then you want it to run it for a larger model, that also takes minutes. And that's kind of the value proposition of the recipes. The other thing that we went through, and you saw it during this workshop, was this. The recipe was on Pollination, right? We can load it from web. We didn't show this actually today, but you can run a recipe from web. You can start a new job from web, put all the inputs in and run it. You can do it from Rhino, which we did. And I don't know if you've noticed, but when we ran it in Rhino, I didn't select the model because the model was already linked, because the recipe is context aware. So when you load it inside Rhino versus Revit versus Grasshopper, it knows where it is and the inputs are going to adjust and the form of the recipe is going to adjust based on that. We also ran the same recipe from Grasshopper. So you have already seen the third one, right? You can run the same recipe from Grasshopper, from Revit. And we have this experimental development that you can actually run a recipe locally as a desktop application. Because the inputs are the same, right? The execution logic is the same. Why shouldn't you be able to use it as a desktop app? So imagine you can write a solution and then deploy it as a desktop application and share it with your client, or use it as a desktop application for people who do not have access to Rhino or Grasshopper, right? Or Revit, because the execution of the problem is happening outside. The only thing that we really use the CAD tools for is to prepare the HV-JSON file, which has the geometry and metadata. The other problem that recipe is resolving is when you write it once now, instead of having 3 Grasshopper scripts that people have, which are kind of like the same, but they're not the same because you changed it over the projects and you don't know what you changed. Now you can write one, push it to Pollination, and different people can use the exact same recipe from all these different platforms. So your effort for developing a recipe is going to be multiplied by number of platforms that people are going to use it right away. And this is part of our loved by experts, used by everyone kind of approach too, right? We always think we want to build things that experts love. They can do, it gives you the freedom and flexibility to deal with real world complexity. But at the same time, everyone else can use it too. It's not a thing that only for experts. So if you don't know how to use it, you can't use it. This is the link between experts to share their knowledge, share their expertise, package it, and for everyone else to be able to using it, because this will, to us, this is the only way to help beginners become experts, to help the whole industry to go better. As I said, running garbage in, garbage out faster is not going to make our buildings better. Helping each other to learn this concept and understand what we are doing and try to educate more people as we go is the way to just push this, you know, the performance-based design and everything forward. So this is a presentation that we showed. This is a slide from our presentation in 2020 when we did at AECtech, which at the time we said, cloud computing runs simulation faster. We have done it. Recipe, we have done it. We didn't have as many recipes as we have today. And then we said we will be working on Lens and apps. The idea was Lens was to make a platform so you can make sense of data, which was data visualization. And the idea of apps was to bring all of them together, to make it easier for people so you can deploy an app and everyone can use it, right? So introducing Pollination apps. Basically, this is customized interactive application that are powered by Pollination and built by a technology called Streamlining, which means you can do all this stuff that we just showed and have an app as an interface that you can share it with other people. Here we go. So there are 2 different technologies, Pollination that I just showed. There is another technology called the Streamlining app, which is an open source library and application, web-based application that's developed mainly for machine learning people using it. The idea behind Pollination is making building simulation easy, generally speaking, while keeping the quality high. For Streamlit is making building data apps easy. So they have a Python wrapper, you can just write like 20 lines of code and you have a full-fledged web app. So what if we basically merge the two? Then we're going to make building simulation apps easy. So for people like you, you can quickly build things on top of what you have done with Pollination and one. I am going to show you an example here, or maybe I shouldn't show that because that's I'll show you some stuff live. Let me start here. So I'm going to show you some of the apps that we have developed, and these apps are a couple of 100 lines, and we most likely open source them so you can see how they are developed. I see like so many chats are going on here. Do I need anything to answer? Or is it good? So this is to answer the first question that someone asked, that can we basically load all the results in the same place? I had the app open for a long time, so it started to disconnect. So if you have been using Ladybug tools, probably at some point you either have heard about Design Explorer or you have used Design Explorer, right? So this is a Design Explorer-like app that uses this technology called HiPlot, which is developed by Facebook people, a Facebook research team. And it's very similar. It has some cool stuff that Design Explorer doesn't have. For example, I can drag, drop this, but the whole overall concept is the same. So this is a study that I ran with daylight factor, and here it gives you the average daylight factor in only a single room. So I'm going to remove this, and run ID I don't need. So you can see based on shade depth and shade count and shade area, and I don't need the name too. So it's giving me the average daylight factor total. So I can see these are the options that are working the best if we want to go with daylight factor. And I'm sure like someone there is asking, what about the geometry? So if I click here on show 3D model grid, so here now are the results loaded from Pollination, and every single of them are actually a full-fledged viewer that we just showed that you could see on the app too. So finally, I think after waiting for a long time, now you can get your Design Explorer for all the studies that you do, and you can do all the stuff of, you know, like checking the parameters and everything. So what if we just go and get the a study that Chris just ran and load it here inside the app? Yes, no, I can't see any faces, but I assume you just say, yeah, let's do that.
Yeah.
I hope.
Yeah.
Yeah, okay, let's do that then. So if I go to workshop and check this one, parametric louver UDI, and I go here and I copy this and I go back to my parametric job visualization app, you see this one needs a job URL. I paste the job URL here, press enter, and it's not going to work. Why? Because this is a private app. So sorry, this is a private run. We ran it inside a private project. Once we fully integrate this Streamlit apps inside Pollination, it will know who you are, so it will know if you have access to it or not. But as you can see, it says see the sidebar for more information. So here, what I need a Pollination API key to make sure, like by using Pollination API key, then the Pollination knows who I am, so it can use that information to give me access to private projects. I wanted to use this as an opportunity to show you about API key. I know a lot of you may not want to develop this stuff and all those, but it's good to know because maybe this is a way even to share stuff with other people who don't want to have an account on Pollination. I think they should have an account on Pollination, but that's a different thing. So the way you get an API key, if you go under your profile, settings, then you scroll down, here is the place that you can generate API keys. So I'm going to generate one and then I'm going to destroy it after this workshop. So name is AEC workshop key. Or actually, even that is dangerous because now you can use it. I'm going to use one of the other things that I have. So I'll just show this to you. So this is how it is. So I just generated one. I can copy this and I can use it. I'm going to use it and build it in a second. So I'm going to put it here, press enter. And now it should load the app. And the first time it takes a little bit to load the stuff. But once it does it, now you can see I can get all the studies, like all the options that we had here. I can get the average UDI for all the rooms that we had here, right? And I don't need this UUID. But now we can see if we care about a basic room, we can go there. Or if we care about this, we can basically understand these are the best 3 options with shade depth of 1, am I correct? Yes, 1, 1.5, and 2. And interestingly enough, no, the pattern are the same, but the difference is not that much. So if you want to go with 1, you see that you will still get 46% average UDI here. Does it make sense to everyone what just happened? Yes, no, maybe. I wish this workshop was in person, but
it's
yeah,
really cool.
Okay,
it's really cool. I think everyone is shocked how easy, you know, to bring and create a design explorer on the fly is super easy right now. You don't really need to go back, you know, to use the Calibri or whatever the other intermediate stuff. You just create the API key and boom, it's like,
boom, you just have,
yeah,
yep.
it's
For
amazing.
something, and this is, I think this code, the whole thing for this was like 200 lines to do this. And it's not because of us. It's partially because of us, because we have abstracted everything that you need from Pollination, but the Streamlit also makes it really easy to build an app. So this is another one that I want to show. So I know Design Explorer was something that some people liked. Some people thought like it's just too many things in the same platform. So this other one, and I don't know why, but I'm concerned someone is going to do something with the platform. I just deleted the API key that I just generated. So this is another one. So in this case, I'm loading daylight factor simulation job that has 22 runs. So this is taking a little bit longer to run. And in this case, what I'm doing 2 side by side, or I can change my mind and say 3 side by side, right? If you want. And then there is something here that I can set this thing, and you can see these values gets updated. I can also update the threshold for average daylight factor if you're working on a European project or something. You know, I don't know like what the thing is. So what really matters, and I want you to see here, is how easy it was to build on top of everything that you have done. So now for you, instead of sharing the pollination of stuff, right? Or like bringing people in, or you have to make a report or something, you can build an app like this, and then you can send the app to the client. And for most of this, we have URL values, so you can pass the URL. You just send them the link, they basically open the link, and they see the page, and they see your app, and they can get in. And you can set up password, you can do whatever you want to do. One more thing, one last app that I'm going to show you before Chris makes an announcement is the other one that Chris showed for showing the result for the energy simulation. And this app is stop working. And we are going to share the link to an app with you. Just don't worry, like so you can play on your side and see how it feels. So do you remember the energy simulation that he ran and he wanted to show the result? And you have to download it in something. Now you can bring all of this into the same platform, into the same viewer. And you can say, okay, show me the 3D one. And it downloads the 3D one here that is fully functional, right? I can color with anything I want. And then I can build a combo too, in case you're interested to have both the 2D and 3D results next to each other. Make sense so far? Any questions? Yeah, and I see some comment about daylight factor. I also want to retire that too. Sorry, Go ahead with your
Yeah, so
question.
Mostapha, that's very cool feature. I was just going to ask if there is a feature that, for example, we just filter those parameters and just say give us, like, for example, 100 studies with different variations. Is it possible to
Yeah,
do
so
that
what
as
you're
well?
talking about, an app that executes, that schedules a run to do the run and then get the result from pollination.
That's right,
Yes.
yeah.
We don't have a sample for, but that's basically how Pollination Cloud works, right? So we can make the same calls from inside the app and do that. We will provide, I'd love to hear, and we will send a questionnaire will go out at 5:15 to give us some feedback about the workshop. And one of the things that I would love to hear is like, what are the apps that you guys want us to build as the base for you to build on top of? So the overall idea is like, we build a lot of apps which we can share. And it's like how we did with Hydra with all the Grasshopper script. And other people can build their own apps, with the difference that this time for running an app, you don't need to download anything. You don't need to have anything installed. And now you can quickly share it with your clients, with your customer, with your team. And we will make sure that the RBAC, the role-based access control, is built in. So you make sure your private information and private runs are protected, and the ones that are public are going to be public, and more people will have access to it. Any other questions before we just say what client said?
I heard someone ask, or in the chat, like how the Windows act as customizable widgets, or like, you know, basically how many windows you can have and stuff like, that's all pretty much figured out by Streamlit.
Right, that's basically, you can script whatever you want. And so the technology that we are using, as I said, is a Streamlit. Great project. I love it. And as a lot of credit to what they have done. So if you go to gallery, you can see a lot of the stuff that they have done. And if you want to code, you can go to docs, and then there is a place for like layout and everything that you can see how they, I think it's under advanced features or somewhere. You can basically set up different layouts, and yes, you can pretty much customize everything that you want in the app. You can't build a very complicated app, but for most of this is the one, layouts and containers. But for most of what we see people use, for example, a Grasshopper script to show, you can do a Streamlit app with Pollination, and, you know, like, do it once, use it everywhere kind of thing. Yes, the platform is still under development. It's not available to everyone to develop apps, but a Streamlit is available to you to do your own other Streamlit apps. We will release a Streamlit Pollination, which will make it easy to make call to interactive pollination using the Streamlit. And if anyone wants to hack something using Pollination or Pollination apps during the hackathon, let me know, and we'll figure out how to help you doing that. Okay, I think that's all I had to show for now until, and I hope you're not tired, because we have like 55 more minutes to go, and we want to let you know that, oh, actually I shouldn't have stopped sharing. Chris, do you want to make the announcement? Yeah, and then I'll do the...
I'll just say, using our great Streamlit apps, we were able to convince the client of this Revit sample model that they should definitely do the louvers, right? And so, you know, they could see and scroll through everything themselves. It was great. But then the client came back to us and said, well, if we're going to do these louvers, though, I'm kind of worried that, well, you know, even though they'll cut down the glare, we still get the lead daylight credits. And so, you know, now we realize, okay, their main concern is about lead daylight credits. So we have to find a way to address this concern.
Right. And I think this is the time that we can talk about what I just said. So this is now a type of a study that you don't have a recipe for. Did you guys see any lead recipe on the platform so far? Probably you have not. But there is a lead recipe, which is a private recipe under Pollination that we haven't shared it before. What I can do now, instead of telling you, oh, if you want to run lead now, like send your model to us and like break all those stuff, basically I go here and say, for this project, under settings, let's give access to the to lead, and I'm going to just give you the latest version. And done. Now, if Chris wants to run a study for the client with lead, which I will hand it over to you, you should have access to this lead recipe so we can reuse the same Grasshopper script to run lead studies.
Okay. Let me make sure I share the right one this time. Okay. All right, awesome. So yeah, so now everybody, you should be able to see the lead recipe. I mean, or I guess if we go to, yeah, to our organization, or you added it to the workshop project, was that right? Mostapha, or
sorry, say it again.
Sorry, where I'll see that I have the access to the recipe, I guess.
It's under the project. So if you go inside Grasshopper and try to load the recipe.
All right. So what I'll do, I'm going to start a completely new, fresh file and just see if we can load up the lead recipe now. So the way I'll do this, then I'll go over to the Pollination tab and get the component that we use to set up our runs and set up the recipe. I'll just click Get a Recipe, and now when I search for a project, so let me make sure that I'm going to our. I guess I'll run this under the workshop project. But probably, did you add it also to the playground one, or just the workshop?
No, I just added it to workshop. I can add it to playground if people want to play with it.
Yeah. All right.
Anyone wants to run it? I don't know.
I mean, I'm just going to run the thing right now on workshop,
and everyone can use it. Yes, that sounds good.
But you should see, yeah, if you're accessing the playground one after Mostapha's added access to it. Right now, we have that lead daylight illuminance recipe. And so this is a special one that recipe that we've concocted. If I hit OK, you'll see what the inputs are for it. It's really not all that different than a lot of the other Radiance recipes, but actually maybe now is a good time to summarize, because I know people were asking, like, which recipes are free versus, which ones are special. Like this lead one is actually a kind of special one. But maybe if I can break it down to 3 hierarchies. So there actually are recipes that we distribute with the Grasshopper plugin that can only be run locally, but they're the exact same thing as what you would run on Pollination, right? And these are kind of what we call like static Python recipes. We ship them as kind of these static Python components that we ship out with Ladybug tools, versus when we ran this study before, right, with Annual Daylight, we were loading up a recipe from Pollination, specifically, this, I'll go to workshop again. Right, this Annual Daylight one, right? We'll see actually these two are the same exact thing. This is just a purely local thing, but this is the the Pollination version of it. And so I think Talia was answering. So the recipes like these, the recipes that you see that we ship at the Ladybug Tools plugin, those are always going to be free to run, and you could run them. Obviously, you can run them free locally with just the Grasshopper plugin. And there will be, kind of, minimum level, like free tier of the Pollination account that really won't have many computing resources for it, but you'll have access to these, Ladybug Tools recipes from there with just a, basic free account. However, though, if you are buying, a Pollination package service, you'll get access to a bunch of extra special recipes we've written, like this lead one. We have ones in the works for lead energy and a few of the other things that are really in high demand. So that just maybe gives you a sense also of which recipes, that you can always count on these ones to be free, but there will be some special ones. And obviously the ones that you create yourself, you can control who accesses those, whether those are just ones that that your team has access to, or your company, or you and your clients. Okay, so all right, let's get back to the fact that we actually have this lead recipe now. So if we want to, like, all right, so the client's okay with us maybe doing up to, 1.5 foot louver depth or something. Maybe we realize that after giving them the nice Streamlit app. So if I want to run basically a lead simulation of just a 1.5 foot shade depth, louver depth, and see how many credits we still get. So in order to do this, I'm going to jump back over to the same file that I shared with you guys, that if you were following along, this parametric daylight file. So I'm just going to copy certain parts of this so that we can run just one of those louver options basically through this recipe. So let's see, I'm going to select my depth slider, holding down shift. I'm going to select the model. I'm going to basically select everything up to here with the inputs. And maybe I'll take the file path to the EPW here, the WEA. So as long as I have just these components that are creating the model, I'm going to copy these into my new Grasshopper definition.
You're missing the user input. It's okay.
I guess, yeah, I guess you're right. I guess I could take the user input. I mean, yeah, we won't need it because we're only going to run this one option this time. But I guess you're right. It doesn't hurt. All right, let me paste it all in here. So the most important thing is as long as we have the model, you know, and the EPW file, those are the only real required inputs for EPW-WEA. Those are the only things that we actually need to execute the lead recipe. So let's just connect up. I'm going to change the shade depth to be, you know, 1.5 here, like we said. And I'll connect up the model to the model input of the lead recipe. I will connect up the EPW file to the WEA input. I'll connect up our user inputs so that we can maybe just remember what shade depth this was that we ran here. And let's see. Maybe I'll also just, you'll see that we have a CPU count. For pretty much all the radiance recipes, we have a CPU count input. Again, I think I shouldn't need more than 20 CPUs to run this. So I'm just going to connect up a 20 to the CPU count. Okay. All right. So we got our model all set up, right shade depth, right sensor grids. Then I think all these other ones, I mean, you could read through the other inputs for the lead recipe here, but they're all pretty standard. Maybe one just to keep in mind is that in order to use, so this is using the option 2 method of the lead daylight credits, which is basically running 2 illuminant simulations at 3 p.m. and 9 a.m. And then seeing how many of the sensors, essentially how much of the floor area passes the criteria at those two point in times. So in order to do this, you know, there's an option, like it's a very different type of criteria used to evaluate the results depending upon whether there are blinds to control glare versus no blinds at all. So the default is true, you know, just be aware of that with this recipe. But pretty much my run is ready to go here. I have all the required inputs. So I'm going to grab the pollinate component that we'll use to execute this, this run. And let's see, we'll add a subfolder again. I guess I'll add a subfolder of my, let's see, my username. And we will add a, let's see, name. Maybe we'll just call this lead, you know, 1 foot 6 inches depth, something like that, right, for our name. And then we can connect up the run. Okay. And then because we're not doing this parametrically, we'll just run this one option to see if we still get lead credits. Right, we're pretty much good to go here. So let me double check. I don't think I'm missing anything. All right, we've got all the rooms here. We've got 15 sensor grids. All right, so I'm just going to hit pollinate now. Yep. Yeah, and I see the questions in the chat. So yes, option 1, we are working towards that. That will be available in the future. It's just a lot more complicated than the option 2. So that's why we have option 2 is ready right now versus option 1. But yeah, we are working towards that. It's just we just have to get the dynamic blinds implemented, and then we should be able to support that. But for now, yeah, we can at least see how we're doing with this option 2. So all right, so the run was created there. I can use the check run status or check job status, just as we did previously, to if I connect up the job there, and use that. It'll tell me, okay, it's been running for 38 seconds. I can right click in order to check the job on pollination, see how things are going. All right, and we should see again. This will be under the workshop project. If you guys want to see track the progress of this, and you can just click on the one run that we have here at a shade depth of 1.5, and seeing the debug window as the steps of the recipe execute. So I think it'll probably take. It was maybe like 6 minutes or so to finish. Let me see. It looks like there are some other questions here. Maybe. Let's see. Sebastian asks, so you're asking, will a single sign be available in the future? I'm not so sure what you mean by sign.
Single sign on. So Sebastian,
on.
Yeah, we need more information here. I see that you're, yeah, like let's talk about this because okay. It's very doable, but you know, like we want to make sure like if we do it when people really need it.
Understood.
Yeah. Okay, maybe I'll just, while we're in between questions here, like I'll point out, so you guys can actually see the simulation scaling up, right? So it's the first thing that it does is it creates 2 simulations for 9 a.m. and 3 p.m. Is that, you know, all the logic basically that's needed to evaluate credits is packaged into this one recipe. And right, and it does the ray tracing where, you know, these are the 20 CPUs that we specified here, right? So it's running basically all those sensors in parallel. In order to look at illuminance during those 2 times, and you'll see at the end it'll bring it all together and evaluate the lead credits at the results. But let me see. Were there any other questions here in the chat? Okay, yeah, just more single sign-on stuff, and yeah, and knowing that yes, the option 1 will be available in the future. And yeah, we're curious to know if they're, like, you can see we definitely have lead, you know, lead daylight is one that we're going after. We'll have recipes available when you purchase a Pollination cloud package. We'll have the energy, basically the Appendix G methodology that the lead energy credits need. That we'll have a recipe for that. That'll tell you the number of lead credits there. And if there are other workflows that you guys are really looking to you know, to have available, please let us know, because we can work towards implementing those in the platform. So yeah, if there's other you know, either code compliance, maybe recipes or other types of compliance recipes like that in particular, we're all ears about them. Yeah, ASHRAE 55 compliance. Yes, yeah, that's a good suggestion. We have recipes that actually do detailed thermal comfort mapping. You know, it's at that scale that you could really see, you know, the parts of the room that pass ASHRAE 55 versus not, and see that over the whole time period. So we'll definitely, we're definitely gonna probably, we have streamlined workflows because we already have those recipes kind of started. Those will be things that we'll have in the future. I know probably if it's just for lead ASHRAE 55 compliance, they really only care about the center of the room. And you don't need to do any kind of detailed comfort mapping like you can on Pollination. So we can probably also add some recipes for that.
Yeah, that kind of thing I would say like it's a great fit for apps too. So to have an app that that's the only thing you're interested, you just go to that page for the app, just run that, you're done for what you need to do. So while that is running, I do a fast forward here if Chris doesn't mind.
Yeah, do you want to share your screen?
No, I want to just let people play.
Okay.
So while this is running for lead, you will see the result. Do you want to, so there will be results that are generated from this lead report, right? Mm-hmm. There are results for the daylight on 9 a.m., 3 p.m. Then you have a pass-fail result for each of these hours, and then you have another pass-fail for the total time, right?
Right, yeah, and so these are the outputs, yeah.
And I think more than anything else, what you will be really interested in is like, did I pass or not? How many points did I get? So this is, and again, these apps are experimental. We just deployed them to be there, but I'm going to go live. So you guys check this. I just sent a link inside chat, and Chris can also check it. And you can play with it with a run that we did before. And Chris can show like the app, how it works, and the concept of app in general. And then we will visualize the result of this run that Chris is running, which should be similar. I don't know if like now, like everyone clicking on this is going to bring down I don't know, like how much resources.
Fingers crossed.
Yeah, I think that's, we'll see how it goes.
Oh, I got a connection here.
Yeah, I think like that's what, like I should have not shared it with everyone.
Oh, it's
I think Antoine is like, what did you do? But let's see. I think like some people should be able to see it. So if you go back to, let's see if it loads, or maybe if I can get it here, I can, because I think I already have it.
All right. Yeah. Do you want to share your screen?
Yeah, I think I have it. So if you stop sharing.
Okay.
So here is, oh, you see yourself, you see all this. So, okay, now do you see my screen?
Yes.
Yeah, okay. So once the lead recipe is done, you can paste the URL to the run here, and you will see something like this. So this is a report that we created. And this is, again, like everything else, is a custom report, right? So you have the result here. If I check here, this is the pass-fail value. So you can see this is passing pretty well. And I get all the 3 points. If I want to see exactly what happened at like 9 a.m., I can go to 9 a.m. and then it's like too much light. I can set this to 2000. And now you can see still, like, except for this areas that like get no windows, pretty much too much light, which was the glare study that we did, but there is no issues with getting your lead points. Then here you can see the model breakdown. And if you get more than 3 points, there will be a happy moment, or more than 1 point, actually. I'll do it again for people who missed it. Here we go. And this is from a Streamlit app. Like, they have these balloons that go, so like just having something fun at the end of the workshop for you guys. So now you can see all the report here for, you know, the values for all the metrics that you guys are looking for. And then there is, like, we added, for example, you can add full help to your app so people know like how to work with it, what it does. And then we have a space by space breakdown here. And you can do this to just zoom in and see something. We can add download. So you can download this stuff, you know, if you want locally this data, but it can get even better. And that's the place that I want to go. So these apps are fun, right? We showed recipes. Recipes are reusable, great. Apps are good. But what if we could write the app and use it from inside Rhino or inside Revit? So what if, so I just showed you the, you remember I had a slide for recipes and say, write it everywhere, this time for Pollination apps. What if we could do this? So what if we could see all the breakdown and I have into this report, be able, this is the exact same app that I just showed you on the web. Like, this is not a new app. It's just similar to recipes. It just senses that it's now loaded in from inside Rhino. And now what you can do, you can basically send this model to Rhino. And here, you just write your app once for visualization and go that. What mostly known for weather data visualization, right? Idea of like writing a web that we did initially on the web that customize everything. It's just like, this is the weather on this web. And again, like, you guys don't have access to it. Has any questions? I heard some of this, okay. And I actually have access to full-fledged pollination from inside Rhino. So all this is stuff that I showed. Do you remember, like, we had this recipe runner that we just showed it to you in Rhino? What if we just could use the one that we developed for pollination from inside Rhino? Instead of writing like 4 different versions of loading recipe and running it because they're the same. I can click inside Rhino. I can even, like, we can add commands like PO EPW And now that's the EPW app that we just showed you inside Rhino. And just to make sure it's clear, I'm going to see, let me, a second. Okay, here's the app. So this is the app on the web. This is the same app on the web, right? What it does, it basically has some information. It has a sample EPW. I can also upload an EPW if I want. So I open this one, and now it loads the location. It draws the SunPass in the same viewer. It does some data information. We didn't really spend a lot of time to make like a full-fledged app, but you know, it has all the good things of like saving an SVG, whatever you want. There will be save as PDF. So this is cool, but I can't get this SunPass inside my Rhino model. So it's kind of like disconnected. So you have weather data analysis, then you have your design stuff. So the same app now is running inside Rhino. So now I can go do the same thing, right? I can upload EPW app. And because I know we have people from the other side of the world, so I'm going to open the SunPass from Sydney this time. So north and south are going to be the other way around. So now this is the SunPass for Sydney. So what I can do now, I can say, oops, sorry, send this SunPass to Rhino. Oops. And here you go. The SunPass showed up in Rhino. It's actually the other way that people who live on the northern hemisphere used to, sun comes from north. And I can turn it on and off. So basically the idea is not only when you write the app, you write it once and you use it from everywhere. you really write it once and use it from web, from inside the CAD plugins, from inside Pollination. This will bring down this effort of developing similar apps, basically to close to zero. So we can write the app really once and reuse it everywhere. So we can just speed up this process of sharing knowledge and getting, giving access to more people to this kind of knowledge that is kind of lacking. And I mean, I have a rant about fast food and how it's hurting everyone, but I'm not going to do that now. And I'm going to continue with my presentation. And then we should have about like half an hour for any question, comments, discussion to follow up. And I think like we want to show the result of like what Chris ran right now for lead 2. So people know that's for real. I'm a real person too. If you were thinking this is like recorded. So this is again like something that we have from the time that we started Ladybug Tools, we're showing to people. If you have a tree like this versus building like trying to build all these smaller ones, then you will have a lot of reusable parts that you can share. So if the way we develop projects in the industry, a lot of the project is like this. Everyone is trying to build their own tree, starting from nothing. There is no root, there is no, like, you don't go that far. You just have this app, the other company has the same app, the other company has the other app, and all of them are like somewhat similar. They're not really great. But if you can build together, right, then there is a place that you can get up to speed and we have a lot of things and we can go much further than just building it separate. So this is how we see this tree. You know, there are engines that we didn't develop, DOE has developed, like other people have developed, Energy Plus, Radiance, years of development we're using. Then there are libraries that we wrote on top of them. Then there are APIs, then there are plugins, and then there are scripts and apps that we are developing. Writing this a script and app takes an hour or takes a day, right? Writing a whole plugin takes days to weeks. Writing APIs takes months to years. And writing libraries is like years, ages to write that. So what has happened right now, because of all the work that all these people have done so far, we are at the point that we can take advantage of all of those. And you know, like we can quickly generate all these apps and knowledges. And one of the things that we're doing, so if you're using Ladybug Tools code on Pollination, then we can give you a different license so you don't have to open source it for people who are concerned. And this is only if you run it on Pollination. So you can develop apps with Ladybug Tools code on Pollination and keep them closed source to your company. I'm really excited to see where it goes with all the work that we have done. And this is not us like starting this. This has been done for code development. This has been done for machine learning. How Kaggle is doing this has been done for visualization. And in the building industry, Hyper is trying to do that in a very larger scale than what we are trying to do. So we hope this ecosystem that we showed to you today, you get a sense of where is it going. We see this as the place that we developed all these recipes that we made available, and you saw some of them during this workshop and we used. We hope, like especially with coming apps that makes it easier than writing recipe, we see a lot more contribution from community to start developing their own solution that they can share. And finally, there will be always enterprise solutions. We are already developing some enterprise solutions for the companies that they have very particular use case that they want to run on Pollination. And yep, this one of the most favorite quotes that I have is just like, when an expert network is functioning as its best, the smartest person in the room is the room itself. And that's kind of like what we are trying to build, and we are all trying to be part of that room that is the smartest in all of us, because really we don't have that much time to get these things fixed, and as you know. And if you want to start today, you can just go for it. We have your back. I'll show you the link where you can ask questions, where you can do all this stuff. For beginners, you can already start with like just work from Rhino Grasshopper, run a script, the things that we showed you. You can visualize result back in CAD plugins too. So if you're an expert, now you can build stuff and share it. So you can develop custom recipes. You can customize the available recipes, and you can share your solutions internally or externally, and you don't have to do zero infrastructure to make that, to deploy those stuff. Pollination will take care of all of that. And then for software developers out there, now you can get all the things that we just talked about, but you can build your own plugins from scratch. You can use our APIs and SDKs, which are ready to use. So you can just integrate them into your applications, whatever you have, pretty quickly. If you're interested and you want to stay in touch with what we're doing, we have the user meetup, which happens at the last Thursday of every month. This month is different because of Thanksgiving. It happens on the 18th. Probably what we are going to show there, you have seen most of them already. We are going to show the apps again, but probably there will be more apps and with better design. If you want to join, go and register to our, what's that, mailing list too. So we send out a mailing list once a month. So we keep you in the loop. That's the easiest way to know like what's going on with the whole Pollination and Ladybug Tools universe. And yes, with that, I just wanted to thank you for trusting us, coming to this workshop. I was not expecting us to sell out for a product that hasn't been out there. So that's pretty good. Thank you for sticking around. If you want to get started, Pollination Cloud, you already have been there. If you have any questions or if you want to help people, if you want to learn from each other, you can go to pollination.community. That will take you to Pollination Discourse. And if you have more questions that we couldn't answer here, we still have like time to show the latest stuff and ask more questions. But you know my email, you can email me directly, you can email anyone on our team, or if it's something that a larger audience can also benefit from, pollination.community is the place to post it. We are pretty active there and we'll get back to you if you have any questions. Yep, I think that with that, I'll just hand it over back to Chris. If you want to show, really load that lead result that you just ran. So I stop sharing.
Okay. All right, let me try. All right. So, yeah, all right. So we can see the lead simulation finished executing here. And just to give you guys like a little sense of like, well, you know, I want to see the results probably before anything else. So right now I have the lead app. Oops, it looks like I have to refresh it here to get it to work again. But I have the lead app ready to go. I think I have an API key so that I can access the private project. Right, remember that that's a you know, a critical thing for people to have. Mostapha showed earlier, so that you're not, you know, not just anyone can come and see your lead daylight credits that you're considering. And so this is still the old project, right? Because it's a URL here of the you know, just of a random demo project. And I think you can see that this is this one that has 99% passing. This is the version of the model without any shades. So let's see what happened when we put the 1.5 foot shades here. I'm going to grab the URL of our lead option. We'll paste this into here, hit enter. And remember, you need both the job and the run. Oops, maybe I forgot the, yes, I forgot to get, yeah, we need the run as well. So the URL needs to include.
So this recipe, like this app works with a run. It says like run URL. If you click.
Right. Yeah. Okay. Yes. Yeah. If I hovered over this, right.
It's a run or after lead option to report. It says lead URL.
Okay. Yeah. Right. Right.
Run URL.
So,
sorry.
yeah, instead of the job URL, right? A job URL can be written for those parametric runs, that, you know, those apps that Mostapha showed you earlier. So, all right.
This is raw. This job and run wasn't the strongest choice that we made for naming. I'm to blame for that. But.
There's always, well, naming is one of the toughest things in software development.
Right. It is.
All right, so we can actually see, all right, well, we didn't get a full 3, but we have gotten 2 credits. Let's see, and you know,
you still get the balloons because you're more
still
than
get
one.
the balloons. That's the important part, right? Because all right, and so you can see we have 2 here. I guess so. If we wanted to look at what exactly, so we have 83% that's passing in both times, right? And that's what we're seeing in the scene here. If we wanted to like dig a little deeper into this and figure out exactly what's going on, maybe it helps to look at the space by space breakdown. And actually, it looks like a lot of the rooms where we have 0% are probably things that wouldn't count as regularly occupied spaces anyway for the lead credit. So that's kind of my bad. Maybe I should have filtered them out, as I think as Sebastian asked about earlier. It's possible maybe if we filter these out that we actually get back to the same 3 credits. But we know at a very least we have 2. Even with these shades on here.
Yeah, and we can actually, this is an interesting one because we can add this post-processing to the app, kind of make it like a lead navigator. So you can add, remove rooms on the fly and see like how your lead points, lead credits are going to change. You can do that too. And you can probably close that sidebar, Chris, to get like a better view.
Oh, right. That all, yeah. Right. It's a much better way to look at it. So, all right. So then this is just, I'm looking at, yeah, we can scroll through, right, the individual times and actually figure out what exactly we might be able to do to get it to work better. And scroll through, right, the illuminance at 9 a.m. as Mostapha showed. You probably want to boost this up to like 3,000 or something. But yeah, so all right, so we get, you know, right, this can be used on real projects, right, to actually send this now over to a client and show that we still can get lead credits even with these shades on. Okay, yeah. So maybe I know I was looking at a few of the questions that people asked about, and you know, just also so that you get a sense of like maybe what's behind the scenes first. So this actual run that we have here, like if you really wanted to write your own apps, right? Like maybe you don't like the specific type of way that we've done this lead to reporting app. I mean, all the data, all the raw data comes out of the recipe. So you see, right, this information that we have that you see in the model breakdown. This all comes from right, this credit summary.json. So right, so we see the two credits here. You see all the same information. So you can write your own app basically to parse these results, or if you don't care about some of these properties, you don't need to put them there. You also see, like in the results, right, that space summary is just a CSV that's being parsed by the app. Right, so all the raw data exists here, like right out of the recipe, so that you can basically pick and choose what you'd like to go into your apps. And then here are those results, these illuminance values for the individual. Well, the bath doesn't have any, but for the individual spaces, right? So these are, I guess these are pass-fail results maybe, and then we have, yeah, then there's illuminance values for each one.
It's not under results if you go to root.
Oh, right, it's under simulation.
Simulation, yes.
Right, yeah, the luminance results are here. So yeah, so again, that's all, you know, it's all the data. The recipes are meant to, again, to give you like everything you need to work with, and then you know, build the apps so that you want them to display those results. So yeah, I mean, maybe just to give, people are asking, just I saw some general questions about other resources. Mostapha listed a good number of ones at the end of the presentation there. I mean, the other things I'd point you towards, like we didn't necessarily show, but the discourse forum that we have for Pollination, this is a great place to ask questions if you're beta testing. You know, we have a forum also for the Ladybug tools plugins. That's also discourse. So these would be great places to, you know, if you get stuck, to ask us questions. If you're looking for more like fundamental getting started stuff, I mean, there are docs on pollination.cloud that you'll be able to access under resources. There's a user manual, which is a searchable, basically it's a Git book under the hood, but it has a bunch of instructions on how to get started with the plugins, with both Rhino and Revit plugins. And yeah, and if you're looking to gain more knowledge about the Grasshopper plugins, we also have a Git book for all the components, all the various Grasshopper components. And these are searchable as well. So these are, we've tried to give you a lot of resources. We're still working on videos, like video tutorials, to get out to you guys. We know that's the next like main piece of things, main thing that people need to get started. But hopefully, at least there's a lot of written documentation and samples that you guys can start to work from. Okay. So I'm going to stop sharing my screen, I guess.
Sounds good. Okay, so we just opened the floor for questions, comments. If you want to turn on your video so we can see your face, anything, everything, like this is the time. We have about 20 minutes, hello everyone, to chat. And yeah, we tried hard to make sure like we don't end up the workshop like what we usually do, and Elchin said that like we go even like 30 minutes over and we were still running stuff. So we wanted to show you more of a workflow, the concept, where we are going with Pollination, where our Ladybug tools application are going, and why we spend all this time to standardize everything for Ladybug tools. You know, a lot of people, I remember, told me like when we started Pollination, it was just like, oh, you already have the recipes. Why did you just deploy to Python code to run on cloud? You know, that wouldn't be providing all the things that we're providing now. It's more than just running simulation fast. It's to have access to data when you need it and being able to pass this data to information, you know, like among collaborators in the project together. That's, I think, what we are trying to build. But by that, I just stop talking, and anyone who has any questions, comments, will be happy to hear or answer.
I'll just say it was really simple today to go through and keep up. So it was quite easy to go with everything, get results. So that was quite rewarding.
Thank you.
Glad to hear it.
Yeah, Mostapha, this is Behzad here. It was a wonderful presentation, and especially your team. It's my first time participating the kind of, you know, kind of like, you know, this presentation, like technology and like with Grasshopper stuff, nodes, you know. I'm not familiar with Grasshopper, but I learned a lot today. I think I was just trying to follow stuff. But the only thing that I can just mention, which, you know, we could just simulate stuff with Dynamo as well, because Revit, I think, is, I'm based on my experience, Revit is the only program that you know, it actually analyzes the geometries and the buildings.
So
then you don't need to rebuild the, you know, the model like other programs like AECtech or yeah.
I think the challenge that we have with Revit is there are two things that we have seen so far. One is like everyone says, oh, Revit plugin will be great. And we developed the Revit plugin. And initially we thought Revit plugin will give like the same functionalities as the Rhino plugin. But then, I mean, Trevor did a presentation in our previous user meetup, and he's like, the first thing that I did, I exported polylines from Revit into Rhino and didn't touch the Revit model. Because one, not everyone knows Revit. Two, there are so many stakeholders inside that Revit model that unless it's like a final thing, you just don't dare to change anything. Like you can't do anything. It's just everything is kind of a stock for doing studies. But there is one solution that we are working with. Oh, Keith just said it, Rhino Inside. So we are working with McNeil to basically bring the power of the Revit side into Rhino Inside. So you get basically the best of both worlds. So you can stay inside Revit. Tyler also said Dynamo is very possible. We even like did a test. We can automatically generate the nodes that we have for Ladybug Tools Grasshopper plugin inside Dynamo. But from my experience, it didn't worth it for us to do it because it added a lot of maintenance. At least at the time, every release of Dynamo would break the things that we developed, and we already have a lot of plugins going on. So I think, yes, the near-term solution that we are working on with McNeil is Rhino inside Revit. And they are real people, unlike Revit API people, which I have never met.
Yeah.
Just there is a name. So, yeah.
Yeah, very wonderful. Especially I found two similar features that, you know, Pollination has, you know, with kind of plugins that, or maybe that, you know, the tools that Revit has like inside, you know, that it just generates those energy analysis on the cloud. And also, another one was design generative that you were showing, you know, how to, and it was really interesting for me that, you know, you have both things in one package, which is really cool.
I mean, this is being recorded. Otherwise, I would have talked about that generative design thing.
Okay, I'm sorry.
Oh,
I'm sorry.
Yeah, we'll talk about it later. But yeah, there are very similarities for good reasons.
Yeah.
Yeah. Great. Thank you so much.
Thank you.
Anyone else?
Maybe I just wanted to know, I think it's really interesting to see how you guys are anticipating the organization and how people will relate to each other and like levels of expert knowledge and you know, passing off levels of abstraction. One thing I can say, like from the morning session, it took me a little while to map when you were switching programs and how information was moving from one place to another. So maybe like, I'm imagining some kind of a GitHub kind of like branching structure where you see how things move. You mentioned you might do something like that. But I think like that kind of a roadmap would be really cool. But that's really just the icing on the cake. I think the work you guys have done in anticipating all this is just amazing. So kudos.
Yeah, thank you so much for the kind words. Trevor actually has posted a post on the community asking for that. And we have discussed it. It's, and there are ways, so one thing that I can tell you is like, we don't want to write our own get, right? There are technologies out there. I think Speckle is doing a great job, like trying to address some of that. So maybe we use that as an infrastructure, but that's definitely something that we have talked about a lot on our side. And I think we have also to find what is the unit of change that we want to report to people, because probably it's not like code that like, you know, you want to tell people something more meaningful. It's just like, this system has changed these 3 parameters in it, more than just like do a text-to-text comparison. That's not as helpful. So when a manager or someone can see it, can see the process, oh, this model came in, these are the things that changed, these are the next step that we are going on. Yes, this is definitely, you can see where we are going with this. I mean, internally, I always say like, we have this thing of like, what would GitHub do? So for a lot of decisions that we're making. So if you see a lot of similarities between what we're doing and what GitHub is doing, this one, unlike Insight 360, is very intentional and like for great reasons. Yeah, thank you. And should I thank everyone who stayed up so late? And Paul, this is your morning there, right? Is it right now early morning in your side?
Yeah, it's 9:45 in the morning.
Oh, wow. Wow. Okay. Thank you for staying up. Like
Well,
through the night.
it was more an early start.
Yeah, hopefully it was worth it.
It was, yeah, no, it was a great presentation. Thank you.
Yeah, I think I would echo Alexander's comments. I think in the morning session, I was not overwhelmed, but just like surprised at all the different maybe permutations of starting with a Revit model and maybe ending up with an analysis model. It seems like there's a lot of different stages at which you can define zone definitions or other types of your analysis, which is really exciting. I think it probably lends itself to the expertise and which platform teams are comfortable working in. But I think Mostapha, as you said, as maybe Revit models scale, more people are inside of it, it becomes much harder and more burdensome. So I was wondering if you had any other kind of stories to share in terms of how organizations that either, you know, only use pollination with project partners only, or maybe utilize it more on an organizational wide basis, how those have been successful or challenges. Does that make sense?
The question makes sense. I don't know if I know the answer. Because from the ones that using it, so most of the ones who are currently using pollination are heavy Grasshopper users. And we have seen a lot of, and for the Rhino side, we see mostly people who are energy modelers or consultants who clean one single model, you know, and clean it quickly, they are using it. So I don't have a good answer for that because I have not seen enough. It's mostly like what we have seen so far, I can tell you, is I have not seen any serious project that gets started and finished in Revit. It's always getting out somewhere, and then, you know, we have that disconnect happening, and we didn't get the chance to do that. But I really, if the merge comment wouldn't crash, the end of the workshop, we wanted to tell you like the design has changed, and then we could have shown you like how we can merge this time a different design into a model that's analytically ready to go. Because this time, instead of like syncing, I would sync the geometry and I would keep all the metadata. We didn't do that. But I think one of the things that we are facing is like the culture of how people used to work, you know, and I don't think everyone is ready and even comfortable with this idea of, you know, like things are changing and everything is just going on. And you still, and we need more validation. And that's why we have people validate. We validate model when it comes in, we validate model when it comes out. Like I think Alexander was asking, like, is there a way for me to see the template as a spreadsheet? There can be an app for that quickly. So if you have it quickly, like you can edit it. What are the things, so that's the thing, like we can go and talk to these people and say, what are the things that you check in your model before running to make sure it's the right model? There can be an app for that. a recipe was a lot of work to make that, but app, I think, is going to solve that issue that we had before. So we can make this culture of, you know, trust, which we did with Ladybug tools initial years. Some of the teachers who did teach them in schools, I mean, I can name them, but it doesn't really matter. He basically took the whole summer, took the whole source code of Ladybug, read through Ladybug and Honeybee, came back and said, you guys know what you guys are doing, so we are going to teach it. And they're still teaching it, right? So I think we need that kind of thing to happen with Pollination too. To people to gain trust, like, you know, hardcore energy modelers, hardcore radiance users come in, like Ladybug Tools community comes in, and then we build this level of, okay, now we know we can trust this and move forward. I think we will see good things to happen then. I didn't answer your question, I know, sorry.
No, that's a really good insight. And I'm thinking about how conversations that I've had with energy modelers have either had a kind of a push-pull relationship with leveraging Ladybug Honeybee models. And I guess, how would you respond to modelers who are maybe partial to IES and now don't believe in Energy Plus? Like, I think that's often the reaction we get, like wanting to have this.
Yeah, we are totally fine with that. So one of the things that, I don't know if you have seen it, but we have GVXML export that you can go to IES.
Yeah.
And we have been in touch with all these teams that I have all the software like set here on my desktop. Probably have seen IES, even IDA Design Builder. And I think what we are getting at is GVXML in the middle is causing a lot of issues because it doesn't include all the data. Every single tool everywhere doesn't import everything. So there will be a push. For example, IES has a gem file format, which only gets the geometry, right? But if they can open up their API so we can directly write to IES with more information, then I think that can like bring us together, because I don't think you can ever convince someone who's using IES like for 10, 20 years to start using Energy Plus just because Energy Plus. But there are collaboration aspects that I see like changing a lot of those IES users. The way they put it is just like for parametric studies, we use OpenStudio and Energy Plus, which basically means they're using Ladybug tools to run inside Grasshopper for all this stuff. Yeah, that's what I've seen. Chris has a good experience working on that when he was working in practice.
Do you mean, yeah, just passing it between?
Yeah, with engineers, and like you went through the process, and I think you moved them from EQS to OpenStudio in this case.
Some a project or two, yeah. But yeah, but it's definitely, yeah, it's a, you know, we know it's going to be a slow transition, and yeah, and the best thing we can do is just make our ecosystem as interoperable as possible.
Yeah, I think this will be my last statement and let other people talk, but I think this is a huge step in the right direction in terms of changing culture, just shifting cultures, as you're saying. You know, I think if designers and project partners can find ways to share this experience and to facilitate that model transition, you know, with enough trust, I think it can definitely like facilitate the turnaround, the sharing of the inputs of the analysis, which probably increases fidelity as well. But yeah, I'm really excited to see where this goes.
Thank you so much. Any other comments, questions?
And to advocate for it on projects.
Okay, thank you so much. Yeah, I love to hear that. And I mean, the questionnaire will go out in 19 minutes. I really want, if you have, again, as I said, any ideas that you couldn't share here or you want to know more, this is the right time for Pollination. You know, Ladybug Tools, a lot of it is, we're still developing, but it's really well formed what it is. But Pollination is kind of like, if I want to compare, like Ladybug Tools is kind of like a high school or maybe it's college level, but Pollination is kind of like an infant kind of kid. We can do a lot of exciting things, but we need input to make sure like we're doing it in the right direction. I think that's one of the things we have been doing. If you see, like, the real world is the thing that is pushing us forward. We have a lot of commands that I didn't show today, which is only for fixing your model quickly, which are not fancy, you know, but they're really useful. They save you hours. I have fixed models for companies that they shared, which unfortunately we couldn't show. I would have loved to show that. It was it 1400 zones or 1600 zones? Something like that. They spent a week to fix it. They couldn't fix it. With the Rhino plugin, I could fix it in 4 hours. And then do the whole solve adjacency. It was like 2 major towers next to each other. And I think that's the real value. That's a lot of time that people spend to just get that energy model to run. Again, a quote I use a lot, which we got during one of the interviews. There was this younger engineer who said, like, we have all these amazing scripts and all they need is a clean model. And we never get a clean model. So all the time It's just a pursuit of getting a clean model to get to the script. And as soon as we get the clean model, the design has changed. So I have to go through the whole process again. So one of the other things we hope with the Revit model to happen, and especially with this validate command, is so the people who receive this HPJSON from Revit and the people who create the HPJSON or the Revit model that generates the HPJSON can start having a conversation and having like a handshake moment, you know, saying like, these are the validations that this is automated in the process. So if you can get the Revit model to this place that it passes all this, I'm responsible for the rest of it. If there are things that are missing, then you're responsible for the fix of it. And I think at some point, this will make a culture. I think this was the same with Ladybug tools. And that culture is something that will help everyone. And we tried a lot to make what you need to do in the Revit plugin for a clean model to be very close to how you do the design process, more than saying like now you have to model in a different way to work for us or for our model. But we will see how it works. We have 2 more minutes. Any takers? The next 2 more minutes.
I was going to comment, Mostapha. That was one of the reasons why I joined today. I wanted to see more of the troubleshooting. I think that's going to be a huge hook for IES type users, myself included, is the model generation, just to rapidly build that analytical model. I think you can, even if you didn't have buy-in initially on all the visionary things that you're doing, that part alone and just bypassing it and going straight to IES, I mean, even that is going to be, they're going to take it. And then once you get them in that environment, you know, you start opening up, hey, do you take this next step or this next step? So I think like that's something that I wish we would have had time to touch on and troubleshoot and understand, because that's some issues that we're seeing.
Email me, we'll do it together. I'll be more than happy to do that.
I got 2 models right now. Yeah, I can send you.
That's what I told you. Like, I mean, I can't do it the next 2 days because I'm driving to New York for the AEC event and then the hackathon. But like next week, I'll be more than happy to help you with that. And we had very good experience. I know Rhino plugin crashed today like 2 or 3 times, something, but it's really like the amount of things that you can do with the Rhino plugin as someone who used to clean models. It's just, yeah. Like, I mean, internally, everyone knows like how much I rave about the Rhino plugin.
For 10 seconds here, I just think that I try to talk, I've mentioned Pollination to our, you know, in our team meetings internally, and I talk about all the other features, but the one that like just kind of percolates to the top or whatever is the clean, hey, I don't have to like build it manually. Like, so I think that's going to be a hook for a lot of the users. And then from there, it's just, you know, the sky's the limit of all the recipes and everything. So.
Would love to. Just send me an email and like we'll make sure like to have a chat for it. Yep.
All right, thanks again.
No problem. Thank you all. Okay, I think by this we can just wrap it up. It's 5 p.m. here. And I know like 10 a.m. for all there in New Zealand. Have a good rest of the day for our tomorrow. Thank you everyone who stayed. Thank you our team also, like from China, Italy, like everywhere to stay up for this. Thank you all, and I hope to see you around. Email us on Discord. Like we have your back. So if you want to get started, don't be afraid. We are here to help you.